Good morning, everyone, and welcome to the second day of our Rise of AI Summit 2020. My name is Daniel. I'll be your host for today. We started strong yesterday with only some very minor glitches, for which we, of course, sincerely apologize, but also with a wide variety of inspiring speakers and brain-tackling content. Yesterday was the day where people were incredibly excited about all the possibilities of AI and also a little upset about the specific German attitude of regulate first, invent later, but also it was duly noted with regards to AI that politicians seem to learn fast, and that's a compliment seldomly heard about people in politics, to put it mildly. We also heard a lot about the advantages of being in Berlin, not only for an AI summit, but also for individual people and especially for companies like Merantix, for instance, who picked Berlin on purpose over places like California or Zurich. We talked about values yesterday, not only ethical values or the value of companies, but about the right attitude needed for success, whether you are a founder, a manager, or really any person working on or in AI. Courage, trust, and flexibility come to my mind. And at the end of the day yesterday, Daniel Jeffries once again showed us a glimpse of our future distinctly improved on a foundation of AI. And we heard yesterday about the golden age that we live in which AI applications are ripe for the picking. And Fabian Westerheide mentioned yesterday, since the start of Rise of AI, he has always been dreaming of a whole day of applied AI. And today is that day. Let me remind you of a couple of things. You may ask questions during any keynote in the Swapcard app. Please make sure that you are in the appropriate session and that you post your question in the question tab so we can find it. And yes, everyone watching over the internet, apply your favorite volume and video size. Everyone on location, please apply the seat of your pants firmly to the seat of your lounge chair, and let's get right into it. Our first keynote speaker is a man that says of himself, "I have dedicated my life's work and career to advancing artificial intelligence for societal and economic prosperity." He has led R&D of hundreds of AI approaches for a quarter century. Today, he is the Chief AI Officer at Tietoevry, the leading Nordic digital services company. Please welcome a backbone of the AI community, Christian Gutmann.
Thank you for the kind introduction. It's my great pleasure to be here in Berlin and give the introduction talk on the second day at the Rise of AI. Thank you for the organizers to have such an important event here. And my thinking is for this presentation that I will discuss some of those insights that I have gathered over the last almost 20 years working with different businesses around the world. I've worked in 4 continents with many businesses in manufacturing, telecommunications, finance, and so on. And of course, you see a lot of, you gain a lot of knowledge and experience with the CEOs, with the leadership, with the company, with many projects that happen within the organization, and also with the board. So my feeling is, and my ambition with this talk is to really share some of those insights. The talk is also dedicated a little bit towards the leadership, the CEOs, the startup owners, the entrepreneurs, those in organizations that are responsible for scaling AI, for scaling the business of AI. And I think that is a very important topic because, of course, the leadership needs to also understand where the boat is going. And finally, I think before we start off, really, I go into detail on the issue of this duality between new technologies, new disruptive fundamental technologies such as AI, but of course also many related ones like 5G and IoT, and the existing business. So your cash cow, the existing business that some companies have been building up for decades, maybe 50 or 100 years. So, with that started, the talk is really from grassroots to boardrooms. And I would like to start suggesting the question, are all your ducks aligned? I guess most of you are familiar with the saying. It means, well, how ready are you? How prepared are you for this challenge to come? And I would like to discuss about 8 ducks, eight reflections that I believe are important when you look at the spectrum of these grassroots movements that employees have that start to investigate and execute AI projects, as well as boardrooms, the owners of the company. How do they see the future of the company? It's all about how ready you are. So in this new era of AI, it's really revolutionary questions that are important to reflect on. There will be a smorgasbord of different topics that we will discuss. I believe we have a good amount of time for question and answer, so please feel involved. As mentioned earlier, ask questions. We're very happy to reflect on them. I think we leave plenty of time. And I would also like to say that those 8 topics that are coming, it's very customer-centric and very value-centric. So what type of value propositions can you detect and can you elaborate on? So that is at the core of this entire presentation, really. So let us start. Let us start with the boardroom. So I mentioned grassroots to boardrooms, and as many of you know, the boardrooms and the boards of companies are those that are usually the owners. They're really sitting and steering how the company is moving forward. And the responsibility for boardrooms becomes even bigger in times of massive change, right? So how can you represent the interests of the owners of this company in the best possible way? Choose the right executive team in order to achieve those types of targets and be aware of what the company will become in the future. So then, of course, in those boardrooms, one important aspect is how is that knowledge in the boardrooms around new technologies? Is there an entrepreneurial attitude? Do you have commitments and obligations to owners which have, let's say, a much more dividend focused, or are you able to actually start changing your outlook and perhaps have less and accept to have less revenue for some time in order to gain higher traction and more market lead in the future? So this is a very important part. I have been interacting with many boards, and I understand that the setup of these boards is quite different, that the tasks that they have are quite wide-ranged. In some cases, it's really less risk, and the boardroom board members are having a certain background which is non-digital, non-data, and I would always strongly encourage to actively think about executive or non-executive board members that are entrepreneurs or that know the AI technology very deeply. That's a very important aspect. So that's the boardrooms. Then, of course, again, looking from a CEO perspective, from a leadership perspective, it is so important to cherish the enthusiasm and the entrepreneurship of your employees. I've seen many projects over the last couple of years, maybe 5 to 6 years in European Nordic companies, where you see excellent POCs, proof of concepts, first prototypes, pilots, they go really well, and you see outcomes, but then they often stop. They are buried in the POC cemetery, which is full in Europe, right? So we need less of those short-term projects, but more of these long-term projects. But how do you get there? Well, one aspect is that you as a leader need to understand, you need to connect these grassroots movements, these grassroots projects, and start seeing how they developed, what impact they have on the organization. Study them carefully and understand how you can make a full value change in your organization. So be close to these enthusiastic employees. It's a very precious resource which you would really like to foster and use as good examples across the organization. And then, of course, focus on how you can get those POVs to full-scale, end-to-end solutions in your organization. On the other scale, I've also seen a lot, and particularly in Europe, we heard a lot of those discussions yesterday, also from a German perspective, that there's, of course, many employees, also unions, there's a certain angst, the German angst, the fear that, this new technology would essentially introduce challenges into the organization, take away jobs, make life hard and difficult. And of course, that is a topic which is very important. And we have been involved in several projects where you need to focus a lot on building that trust into these AI systems, starting to see that it is not about replacing jobs, but it is about replacing certain tasks which are executed within a certain job, replacing them or augmenting them, and looking from a perspective that it is a combined effort between the human and the AI system in order to really create value. So having augmented value sets. And then, of course, when you're introducing AI for employees to use, they need to trust the outcomes of these systems. And I could give several examples, maybe just two. It is about, we talk to recruitment organizations, and when you are starting to look at scanning resumes and starting to match them to potential job applications or job offers from companies, then of course you want to be very aware that these scans detect and make these types of assessments of what that resume contains in terms of qualities and characteristics is done in a fair and transparent fashion. And at the same time also understand that these job placements, which are today manually assessed, just as the resumes are assessed, are when you're assessing whether they are correct, complete, appropriately written, and so on, that you actually do that also in a fair and complete manner. So a human is still involved, an employee is still involved to assess whether these, or to decide whether these resume assessments are correct and complete, but then you also need to trust the outcomes of these automation and AI systems, right? So that is something that you would really like to highlight. At the same time, you have situations, and we have been increasingly talking to sales departments at organizations, at, for example, manufacturing companies and finance companies, where when you are starting to use AI to predict which customers are more likely to buy your product and services in the future, and you recommend that to your sales force, to your sales representatives, and they are paid based on commission, right? So, and they have their way of being successful in the past, which is perhaps based on manual assessments and discussions they had with customers and so on. But now you have an AI system making recommendations on whom to call. Then, of course, you would like to be very, you need to trust, you need to build that trust. You need to see that you can still achieve the outcomes that you set yourself to achieve by the end of the year. And so these are all new processes that need to be included in these organizations and these sales organizations. So the employees are your driving force in your organization to really transform and adopt this technology. You're the CEO, I mentioned before. The talk is a bit geared towards CEOs, leaders, and entrepreneurs in the organization. So what does that mean? I see a huge interest and curiosity when it comes to this technology as I'm speaking to CEOs and CFOs and CTOs in large organizations and also smaller organizations. And what is, though, let's say, missing is a bit this feeling of what's the art of the possible, right? So it's actually quite hard to assess how your company needs to be restructured, how you will play in quite a different market without having some understanding of what that technology can do. And I really like to give often this nice example, as I have also met a fine colleague in Finland, Risto Sillasmaa. I'm sure he would be happy for me to mention him because he is the chairman of Nokia and CEO of F-Secure. Nokia, I guess most of the audience know Nokia, and so he decided to really go back to the bench and learn machine learning and AI. Went to my colleague Andrew Nang to Stanford and actually learn what these algorithms can do, to get a tangible, real feeling of what it does. And so, in fact, as a result of those insights, not only was he able to make a much proper assessment of where the company would be going, but also there was a lot of advice given to governments and other entities in order to learn more about AI. So one result was the Finnish parliament is now learning AI, and that is obligatory, mandatory now in Finland, that everyone in the parliament actually has an understanding of what AI is. Also in part the Elements of AI course that comes from Finland, which has now been broadly distributed across the world, is in part related to this initiative. So I can only highly recommend for leadership and executive members to learn more about the technology. So don't let outsiders determine your future. Obviously, you are responsible for the core product and core services that your company is building. I will in fact mention something about this later regarding partnership, but it is very important that you are in the driving seat and you have this knowledge in order to make decisions for your strategy in your company. And then I would actually, from a practical point of view, I would recommend that you hire the best AI people and experts that you can get your hand on, and have as many, place these people next to your desk and have as many coffees with them and lunch breaks as you can possibly have, to get a tangible feeling about what is possible in terms of applying AI and data technology, and in fact other disruptive technologies that are now on the horizon. So that's a very practical advice, because otherwise it tends to be a discussion topic that's happening at the end of the day or at the end of the week or end of the month, rather than being the core of where you should be focusing in order to re-situate your organization. And you will become much more knowledgeable, insightful, and have much more mature discussions also with the rest of the organization and the board. So, we had a lot of discussions, and of course AI is a lot about the technology and the data. And then of course there's a bit of this fear how complex it really is. And I can highlight just the idea that it is true that in some cases, in many cases, the AI that we have today, and one subpart of AI is machine learning, requires a lot of data. So many of you are aware that we talk about supervised learning, for example, neural networks that require a lot of data in order to learn. But that is not the only way how to create value. So you can certainly build AI without having massive amounts of data. So that is worth noting. The AlphaGo success that we had a couple of years ago, in fact, the AI system there was not built on legacy data. The first AlphaGo was the wisdom of all humans that ever played Go. But the second version that was superior actually learned its moves and its game behavior from the rules of the game. So it was actually not based on a lot of data, and that is worth noting. There are a couple of those examples. Another one is, which holds organizations back, they believe that, we need to look at all the legacy data that we have collected over the last 10, 20, 30 years. And that's certainly not always true either. It was mentioned yesterday when it comes to external data, so the usefulness of external data, adding it to the data that you already have in your system can vastly improve the power of the AI system that you're using for predictive maintenance, let's say, or for many other topics. And secondly, think about creating new data sources. So if you're in a factory and you start making predictions or want to assess anomalies in the factory process, you can install cameras. We heard yesterday a very interesting talk about also how camera data is perhaps one of the biggest sources of AI in terms of data, but you can install them today and collect that data and then use that data in order to do this anomaly detection forward. For that, you do not necessarily need a massive data strategy as to how you handle your legacy systems. So work your way backwards from the value that you want to create, from the value proposition, and see what type of data is necessary in the most minimal case to start off with in order to unleash that value. It is not always necessary to boil the ocean and try to connect all data sources that you have in your organization. Although, of course, in the long run, if you really want to play the long haul, then, of course, it is useful to make a very decent, full-scale investment in order to have all your data connected. Okay, so organizational changes, what I've been seeing a lot, and I think many are familiar with that notion that over the last couple of years, maybe last 4 or 5 years, that's where it started, that businesses have started to build up AI and data teams in organizations, right? So many CEOs and leaders and board members and key employees went over to Silicon Valley and to Shenzhen to get the inspiration, and there was a lot of travel and to see how did the guys in the US and China succeed. Of course, that is not enterprise AI, it is consumer AI, and that that era of these types of visits have gone down, but and this first wave that we have experienced in Europe in building AI teams is now also coming to a next level, because there is an understanding and a learning that these pure AI data teams that only consist of data science experts, which you absolutely need, it's very important, but you also need to have those people that understand the business integrated into the rest of the organization, have responsibility to do an end-to-end process implementation in your organization, and also understand what the business impact is to the market. Also have the mandate to actually change the organization, right? So those types of things are now moving into what I would call a second wave, AI maturity, right? So more and more companies start realizing, well, of course we need the data scientists and the AI scientists, and that is very important. But on top of that, we need to give them the more capabilities, business change capabilities, transformational activities, and the mandate to make fundamental changes in the organization. Of course, hand in hand with other stakeholders and with the CEO. But that is very, very important. So I see, in fact, also in the second wave, to be very careful about defragmenting your AI approaches. So I'm looking often at the two extremes which don't work. If you defragment and start distributing the AI initiatives across the organization, and you don't connect them with each other, you have big risks of having parallel agendas which compete. You have big risks in reinventing the wheel. It is not necessary that different service lines and verticals are all reinventing their, for example, AI transparency agendas and algorithms that can be reused across the organization. So this is not recommendable to fully defragment and decentralize your entire AI efforts, right? On the other hand, it is also not advisable to completely centralize your AI approach, because you will be needing the insights that reside and exist in the individual business teams, the service lines, in the country teams and the verticals, and that knowledge there is, of course, absolutely important in order to create value propositions around the technology of AI. So be quite mindful about the building an organization that effectively adopts and translates these AI and data science technologies into business impact and value. Yes, I could certainly go on this topic, but maybe we have a chance in the question and answers section. So, very important also, which I'm seeing is still a big trouble, let's say it's still a big issue for us here in Europe, is you need to find the AI talent, and how do you keep and retain that talent, right? So it is still so that for a big implementation of a big change and big business impact in your organization, you still need kick-ass talent. You need the best of the best in your organization in order to really make a change. So there is a huge competition in finding that talent, attracting that talent. Europe overall is a netto exporter of AI talent to the Valley, to the US, to many parts of the world. And it is a matter of how to attract and also retain that talent, right? How can we keep that talent in Europe? Many of our fellow areas and countries, innovation countries like Silicon Valley, Shenzhen, we had a big discussions around moonshot projects, projects that really make a difference and move the needle. That is attracting top talent in the world, right? So there's many examples in the US, and that is certainly one attracting point. And you will be competing, if you're a European company and a European CEO and a European entrepreneur, let's say, and a leader, you're competing with those companies in the US, in China. So you need to be quite innovative as to what you bring to the table to this talent in order to really keep them here. Yes. And of course, highlighting something that I often say, but I think it is still very clear and obvious that talent is still scarce, and to put it in numbers, WEF, New York Times, Wired have estimated the global talent pool of real leaders that can move the needle at about 10,000 experts in the world. Right? So in the Nordic countries, I often break that down statistically, that means we have about 5 in Sweden, 3 in Finland, and about 3 in Norway, right? That is what you are mapping it down to. So there is a big challenge in having this type of talent and keeping that talent. And as I mentioned earlier, we are netto exporters, so it's actually less than those numbers that we're actually having. Right? And this is not, of course, many experts and talents that have learned how machine learning works and how you can apply it, but also starting to see the bigger picture, business, having a business understanding, working with governments, seeing the regulatory frameworks and how you're actually creating an ecosystem around the technology. And then, of course, it is more and more, let's say, it is an increased trend that you as an organization, if you're a manufacturer or a finance organization or a recruitment agency or you work in tourism, that you need to find a qualified partner. A partner that you can rely on, and it is a partner where you will see that you can speed up your innovation, that you can speed up the adoption of AI. But I've seen many unfortunate cases where due to the early days of this technology and less knowledge as to how this actually translates, that partner choices have been suboptimal. Let's put it this way. And one advice that I give here is, as you're evaluating your partner, look closely as to what talent they really have on their side. Whom have they employed in order to make this partnership happening? And it is then not enough just to have someone that is a technological knowledgeable figure, so having, let's say, a PhD and many years of scientific experience in this field, but you also need someone that has a very deep business insight. So how do you translate this technology into business environments? What is the impact that is in this organization? Does this person have an entrepreneurial background, for example? How much business has been translated? So you need someone that understands the mathematics, the algorithms in depth, and that same person, I say that clearly, you don't need 2 separate persons at this point. You need the same person that has the ability to also understand the business impact, and ideally also one that understands the regulatory environment and the government environment, let's say the state environment in which you are performing those AI projects and how you're turning into more AI-first company. Yeah, finally, I will reflect briefly and then we can probably take it to the Q&A session. Now we start becoming ready towards building a roadmap and a strategy for AI, putting it all together. I mentioned earlier that having a full strategy of AI considers some of the aspects I mentioned before, and there's so many more aspects that I couldn't discuss in this talk, but please reach out to ask more questions. I'm thinking, of course, of value propositions. How do you technology, no one sells AI, right? You're selling the impact and the business and the value to the organization. You need to be pretty clear as a company, as the owner of the company and as the CEO of the company, in which market you want to compete in 2 or 3 years' time. Where have you found your niche? How do you want to change your organization? And what capabilities do you need to successfully arrive there? Choosing the partners, attracting the talent, and knowing what type of products and services you're going to offer to the market. That is the comment on strategy, and this is pretty much the last slide, summarizing all the different ducks, the different reflections that I've shared with you, and I leave this last slide where it is, and I'm looking forward to many great questions and a good dialogue. Thank you.
Thank you very much, Christian. We already have one question from the audience. I want to encourage you to ask more. So the other Daniel, welcome back, asked the question. Yesterday it was shown that corporates usually don't have entrepreneurs or an innovation-focused role in company leadership. In your experience, is there a different development on how that innovation is evolving in those companies?
Yes, I mean, you can say that in the we will see in the short and midterm that the companies that are applying AI and have a certain risk appetite when it comes to these new disruptive technologies will be different to those that don't, right? So of course, there's always a higher risk doing new things, but the chances for you to prevail in this market is of course higher. And I think this is of course not necessarily empirically completely studied, although I'm sure there is actually a lot of evidence, and I think I've read a couple of research papers on that. But if you have a more entrepreneurial board team and leadership team, you're starting to consider your business in quite a different way. You're starting to look at opportunities. But if your leadership team and board team consists a lot of, let's say, those that understand how standard business, the mature business is executed, which is very important. Like when you bring your startup organization, as Hans pointed out yesterday, to scale stage and it becomes mature, you need people that execute. You need transactional leaders. You don't need transformational leaders. You need people that just execute. And those tend to be in the boardrooms of the established businesses today. Right? So yes, when it comes to revolutionary and new transformational technologies as AI is, you will almost certainly benefit from having an executive or non-executive board member that is an entrepreneur, or ideally several. So I see the tendency, we will, of course, with AI, we're still sort of in the beginning of that in the enterprise domain, but over the years, I'm almost certain that you will find that companies that have 2 or 3 entrepreneurs that are rocking the boat, that are saying, hey, we need to do it differently, will have a much better chance of prevailing.
That's very interesting. And last time I checked, most of the board members and CXOs were human. And since humans always have to deal with feelings like fear and maybe rivalry, what's going on when there are suddenly a lot of, I would say, new people on the playground that do things differently, are maybe admired. Now, these are the new guys we got in to do the great new wonderful thing of AI. What happens from a human perspective? How are the dynamics?
Yeah, exactly. It's true. I mean, people are, how to say, some feel comfortable in really looking at the cash cows of the organization and optimizing those, right? And that brings a lot of comfort. And as you're introducing variables of uncertainty, you will start seeing people, getting a bit nervous on the seats. Yes. So if your question is how do you deal with fear, I mean, I remember, and I think it is still partly let's say, a method in boardrooms and the leadership teams, that you are taking out your leadership team to particular events, right? To really stretch them, to make them feel fear, right? To make it part, I exaggerate, but I know one example where they pretty much just went with a helicopter on a mountain and pretty much pushed them out of the helicopter skiing down, right? So you need to be experiencing this feeling of there is many uncertain environments. You need to take a chance, and things will be good at the other end. So I think this is a very important exercise.
Right. Thank you. Let's talk a little bit about the proof of concept graveyard, you called it, I think. And that's a picture that just doesn't fade even after your talk. So why do you think there are so many proofs of concept in the graveyard? Because the idea, of course, is you have a proof of concept, right? Then you explore the market, and if the market is there for it, you immediately go for it, and this doesn't seem to happen. Is that another fear thing, or what is it?
Yeah, I think there's a couple of factors. So first, what my team is doing, and what I'm often encouraging, and also encourage the customers in the ecosystem to think not of proof of concepts, but a proof of values. So that when you're engaging and you're doing a particular project and you're investigating whether this technology makes a difference, then don't just focus on it being, is it technologically feasible, which is important, but also does it create value? So measure the outcome, define the KPIs, what difference does it make to the organization from a business perspective? Does it reduce costs? Does it increase revenue? What difference does it make to the operational model? So keep a lot of focus on that. I've seen so many projects where the first thought is, we do POC, because everyone knows what a POC is, and that is sort of the end of that part. The second variable is it's often a bit of an easy choice, right? Because you say, look, I put a few million on the side, I give them for some people to play with. I mentioned earlier the employees, the enthusiastic employees that think, luckily they get the few million and they can play and they can show.
It's a wellness program or appreciation program for employees.
Almost,
yes.
yeah. So I'm exaggerating, of course, a bit, but then they get those millions, but there's really no follow-up plan,
right.
And it is also worth noting that even if you show this POV at the end, right? You need to scale and deploy it. So let's say it works for 2 shops in an organization. Well, how do you scale it to 10,000 shops, right? Across Europe, if that's and that requires much more investment. And that's what I mentioned earlier. Connect the grassroots movements to the boardroom, because they need to understand, this POV has worked. Now these guys need 50 million euro, maybe 100 million euro in order to scale that. Where is that coming from? Even the CEO cannot just take it out of his pocket and say, here it is.
This probably has to do with the other idea you introduced, like the art of the possible. Not only possible to get the product, to make the product, but to get it out and to roll it out maybe globally or Europe-wide, right? This should be probably considered early.
And you could argue that, the scaling and deploying, that's almost a bit more standard in some sense, because you need to, at least on one level, because you need to start thinking about, well, what type of business logistics do you need to consider? What type of processes in the big process map do you need to change, and so on? What business processes will be impacted? But, there is analysis and methods for that. Then, of course, AI comes with different challenges.
Right. Do you see a problem there together with the idea of the war of talents? Of course, you want to recruit incredibly talented people, and maybe you get them, and they have these great proof of concept, but they're never put out into the real world, and then they might just as well leave and go to Apple or Google or wherever they're going. Is that a phenomenon that you see, or a danger that you see?
Yes, of course, and I would even say, now I want to be a bit careful, but because I have a lot of colleagues and friends that also work at the big American organizations, right? At Google, Facebook, and many others. But I think it is fair to state that when it comes to the maturity and the exposure of that talent, and now we speak data, people that know the algorithms fantastically well, they can sometimes be a little bit spoiled, because the Googles, the Facebooks, the Amazons have so much money. They're reinvesting that money right now, and the business value, the business outcomes are not always the highest priority. So you can very easily create 200, 300 people project, right, with top researchers and top scientists, where the outcome is not critical to the organization. That is not a luxury that many European companies have. And I would almost say that as we are succeeding here, we become much more, battle-proven, right? Because I would still say that, the 20, 30, 40 people that we have in big organizations in Europe that are leading these initiatives need to think more about this business impact, and I think they are more prepared in this enterprise AI era forward to really be, let's say, more competitive. So,
I would like to talk about one aspect that you briefly mentioned, almost as a tangent. You said drink a lot of coffee. And of course, I know you live in you live in Stockholm. I know that in Sweden there is this fika tradition, like drinking hour-long coffees in the morning, in the afternoon, with everybody in the company, which to Germans is a nightmare. Like so much productivity, right, left at the coffee table. And you talked about your Finnish friend who just said, I'm going to learn something, although he's running a company. A luxury probably many CEOs in Germany would take for a day, but not for a month or a couple of weeks a year. Do you see a different mentality there? Is there something we can learn from the Nordic countries?
Yeah, I think everyone, and I'm looking even at myself as a person, I've been living in many places in the world, and I tend to think, and I hope that I'm sort of picking certain positive aspects and characteristics from certain cultures, right, to collect it together. And yes, I think there's something to be learned from the Nordics. I think one aspect, and that's also one that Tietoevry as a company and the Nordic AI Institute put very boldly on the map, is that we have a lot of respect for the individual, and we have a lot of respect. We really consider there's very little hierarchy. right?
Right.
And I would say in part it encourages this
Not
fika-
only a nominally flat hierarchy, but a really flat hierarchy. That's
very
what you mean?
quite you can
Okay.
call our CEO
Right.
almost any time, and then have discussions, and he's very engaged. Just to take one example, but I think you find that in many Nordic companies, so I think, and then the fika culture is I think I would say is particularly strong in Sweden, right? The
Right.
Finns are not
Yes.
they also drink a lot of coffee, may actually more I
They
think than
drink other things, right?
they drink.
Yes.
I don't know. Yeah. But of course, look. I mean, there is benefit in having meetings, which we now have much less due to Corona, of course. And it depends probably a little bit what the nature of these meetings are. Specifically to the CEO, I mean, it was a bit tongue-in-cheek comment, right? You don't have to obviously sit all the time and have coffee,
Right.
but sit close to the people that know this technology. And at least me and some of the people that I know, the curiosity sparks these interests and saying,
Right.
hey, what here's a business problem that I'm seeing all the time. I cannot predict why is the sales unit in the Netherlands not performing well, right? And so the AI person, the experts on the side can, this is now very, very tangible, but can certainly give you insights as to what's possible and what isn't. They
Right.
say, well, can't we just take all the data and then make a prediction? They give you a bit of an assessment. I think that is a good sparring session, a good session of you getting deeper inside, hands-on.
Right. So thank you very much for your insights. I will have a coffee with you any day you want. Thank you.
Fantastic.
Christian Gutmann.
Welcome.
Thanks
you.
a lot.
Thank you.
Yesterday, we all enjoyed the keynote of his co-founder, Adrian Locher, and today we welcome the CTO of Merantix, the ambitious Berlin-based venture studio. He is also co-founder and board member of the German Association of AI Companies. He's one of the masterminds behind Hack Zurich, the biggest hackathon in Europe, and he is, among many other things, a RoboCup Junior World Champion. Please give it up for Rasmus Rothe.
Thanks for the kind introduction. So I'm going to talk about tech trends and business model trends around AI. And I hope you take something with you after this talk. I will talk about 3 different pillars as part of this talk, but what actually qualifies me to talk about this. So we are a venture studio, Merantix. We are building AI-first companies here in Berlin. So what we do is we take founders or potential founders with us, work with them for 6 to 12 months, test and validate a lot of business ideas with them, then incubate a company with them. We invest even up to 3 million euros per company, and then also help these companies to scale. We've been doing this for the last 4.5 years and actually started a few AI companies. So for example, Vara in the space of medical imaging that is right now live with a medical product, helping in the case of breast cancer diagnostics. And also SIA Search that is giving a talk today here at Rise of AI, which is focused on data management, on handling large unstructured data sets. And finally, also Merantix Labs, where Nicole also will give a talk today, which is around really building customized AI solutions for clients. And recently, we actually started 2 new companies, Causa and Cambrium. Causa focusing on explaining KPI changes, so the AI buzzword around it is causality and causal inference, and then Cambrium, which is at the intersection of biology and machine learning. And we actually plan to build 10 more companies in the next 4 years. And so we've just started 2 companies and we are planning to build 8 more companies. And that obviously poses the question, what areas are we looking at? And as I mentioned before, with these entrepreneurs in residence, with these founders, we work 6 to 12 months. We test and validate a lot of potential business ideas around AI. And so we've made quite some learnings over the last couple of years, but we have also looking forward a few areas we are particularly interested in. And that's what I want to talk about. I want to share some of the things we've been looking at or we are looking at the moment and where we believe there could be a lot of potential for building AI-first companies. I want to structure the talk actually in 3 parts. So I will talk about surely technological achievements as a second thing. That is maybe the most obvious, so seeing where is research also advanced. But before that, even focus more on kind of industry trends, understanding what are industries, spaces where it could be interesting to build a company. And then the last part, which is a bit overlooked sometimes, is also business models focused all around AI that are very particular to this. And starting with the industry trends, I want to talk a bit about first, maybe also the last, I guess, decades of innovation. So I think if you look at the startup landscape, we've seen a lot of these lone dropout founder paradigms. So the idea basically that you have a group of people, 2-3 people who maybe dropped out of college or dropped out of a company and then started working on a company. And so we've seen a lot of these kind of more execution-heavy B2C business models where you need great execution. They're very hard to build. You need to usually raise a lot of capital, but also you need relatively narrow domain expertise. I mean, many of those people come right out of university or just have a few years of work experience, and I think that's what we've seen in the last decades, especially also very much in Berlin. And I guess one trend which we've also seen is that things get democratized. So if you think about how easy it is now to build an app, how easy it is now to launch a direct-to-consumer brand, you can get something live within a few weeks. And even within AI, right, like with all the open source and also tools out there, you can easily get a machine learning model to work within a few hours even. And that has really gradually pushed, I guess, the innovation for these kind of more low barrier spaces. And what I want to talk about is kind of the next frontier. What we believe is that there's going to be a next frontier of areas for the next decades, 10 or 20 years, where you can basically start companies which are in spaces that are much more complex in terms of the research, which are touching much more regulatory hurdles, and where there's still a lot of potential and which are often still very untouched. And this is taken from an article from Danny from TechCrunch. He called it the dual PhD problem. So basically areas where you not just need to be an expert in AI, but you also need to be an expert in another domain. And it's not about the PhD, it could also be 10 years of work experience, but it's areas where you have the AI expert and you also have somebody who knows another domain really, really well, and it's something you can't easily pick up in a few weeks. And for example, healthcare is such a space, right? If you're great with training algorithms on data, sure, that's awesome. But you also, in order to be successful there, you really need to understand the healthcare sector, regulatory, the incentive systems, all the medical terms. And so for that, you need somebody who has been in that area for a few years. That's not something you can pick up in a few days. And so you need both people coming together and also understanding each other, which usually is the case, talking very different languages, right? And so I think making that work and going after these dual PhD problems is super interesting. And that also actually poses some, I guess, different view on how you build teams in this space. So if you think about, again, the lone founder dropout paradigm, you usually have a group of people, they say, hey, let's start a company, then they look at a lot of ideas, and then you start that. And that works for areas where you don't need too much deep domain expertise. But for this dual PhD problem, actually, you should maybe think about it a bit different. And that's actually also how we've been doing it at Merantix. So the way it works with us is that we actually just work with an individual person, with an individual potential founder, then ideate with that person, so look at a lot of different ideas, and based on the idea that person ultimately will build as a company, we actually also assemble the co-founders. So right now, for example, we have one co-founder who will start a company with us in the space of natural language processing, but he's looking at a lot of different areas, and depending on where he's going to build the company, he will have a very different co-founder. And so I think the way basically ideation or team assembly should work should be very different. And this is you can also look at this maybe not just in a startup context, but potentially also in a corporate innovation context. So and so out of this, basically you can also then derive areas we are currently actively looking at. So we are looking at a lot of areas where there is this other hard science you can combine. And Cambrium, one of the companies we started this summer, is in the space of synthetic biology, so trying to create new biomaterials using also data and machine learning to optimize those. And that's a typical area, right? With your middle or high school biology knowledge, you won't know enough. You need somebody who's really deep in that field, but you also need somebody who works with data. And making them talk together, and that was also an interesting process we saw internally. It takes some time until they start speaking the same language, but that's where there is a lot of true potential. And then you can also look at other areas, like in healthcare, medicine, neuroscience. There are a lot of interesting areas in quantum space, geoengineering. So a lot of these areas, and so if you're interested, I think I would really urge you to pick one of those areas and dive really deeply there. That's the first part. Now, let's talk about technological achievements. So far, most of our companies have been started more focused on computer vision, but we are now actually beyond the computer vision efforts, actually also looking at other areas and actually text. So if you think about yourself and myself including, like we spend so much hours reading and writing text. We're basically like glorified text processing machines, if you want to put it very simple. Like the average worker spends 11 hours a week just on emails, reading them and writing them. And that doesn't even include you writing documents, being on messengers, communications, and all these things. So a lot of the human work is actually nothing but getting text in, processing it, and then writing text again. And so we're super excited about that as a like overarching paradigm. And I'm just giving you a recent example. This is like one application where it's about you got a received email, you want to draft a response, you write a few bullets, and bam, then it directly presents you like a fully written email that is, might have some things you can still optimize, but it's crazy what you can already do with natural language processing in this space. And this has really to do with also some recent achievements in natural language processing. If you think about the previous paradigm, how natural language processing worked, and this is also how much of other areas of machine learning worked, you took a lot of data, you trained some neural network, but then you basically fine-tuned it for a specific task. So depending on what you want to do, whether it's understanding, I don't know, financial statements, or whether it's understanding something in the insurance space, or other types of documents, you would then fine-tune it towards your text and your specific use case. And that's not super scalable, and that also means you need to have sufficient amounts of data for your use case, and it kind of limits how flexible your application are. And as many of you see, like OpenAI published GPT-3 in early 2020, where they basically had a new paradigm. They said, okay, we're gonna just train this model on all the data that is out there in the internet, like unlabeled, basically all the text you can find there. And then this model is generally applicable to many different types of applications. Sure, you could still fine-tune it, but already with this, it had basically seen most of the text that is out there. And that just is really mind-blowing, and I think is very interesting for looking forward. So just showing a few applications. So this is something where it's around filling out a balance sheet. The model contextualizes what's happening there, and then actually automatically fills in the spreadsheet. Or a second application, it's about like inferring some facts. These are all things which are basically in the model, and you can easily then say, okay, what's the founding date of Alaska, and then it will directly pump up this number. So it's crazy what's possible there. And another one is around code. So you just say, hey, I want this web page. It generates that, and you can see on the left it generated the entire code for this web page. So you can think about this model as one model that basically consumed all the text that is in the internet. And you also see that in the model size, right? Like this GPT-3 has 175 billion parameters. It's huge. It costs millions of dollars to train. The next model will likely cost tens of millions of dollars to train. So it's really expensive. It needs a heavy computation, but once you've trained it, you can basically apply it to a lot of different use cases. And if you think about it, the capabilities you can apply these models to, there are plenty, right? There's text classification, there's information extraction, semantic analysis, semantic search, which is more on the understanding side, so basically taking a text and understanding it. You can also, take the next level of conversational AI. You can start summarizing text. I mean, think about how many people spend so much time summarizing content into like a more condensed format. Language translation, especially if you think about languages that are more in the long tail, so basically not English. Code translation, so translating code between different languages. And then also on the generation side, so you can also think about writing text, and that could be kind of serving more the long tail. So think about like writing 100,000 product description, right? Like if you have an e-commerce store, like right now, a lot of that is done still manually, but given some of the structured information, you could automate that. So there are tons of applications, and just to list a few, we're basically right now looking at quite a few of them. We are also running already some pilot with customers with first versions of a product in 1 and 2 areas. So this is really like one space where we will generally go quite big on in the next 1 to 2 years. And you can look at the financial markets, you can look at HR, you can look at sales, you can look at code generally. There's plenty of opportunities. Now the last one is the business model part. So this is very important, and as I said, often very overlooked. One thing we actually did with Merantix together with the University of St. Gallen, HSG, is to also further develop the business model canvas. So we took the very infamous business model canvas and said, okay, what do we need to add to also make it applicable for AI? Because a lot of things are similar, but also some things are different, right? For some things like data, like safety, like AI lifecycle are very specific elements you need to think about when you build an AI application. And so this is also a way how we internally think about different areas to look at before we start incubating a company. So feel free to check this out. We published this a few weeks ago, and we will further develop that in the coming months. No, but like what I really want to talk about is standardization and types of AI applications. So one part of AI application is the vertical products. That's kind of what Vara, our medical imaging company, does. Breast cancer is a global problem, of course. It's relatively standardized globally, so you can really build one vertical product that serves the entire market, and you can go market by market, and the product is basically the same. So you have a very high degree of standardization. Then there's the other end of the spectrum, which is basically what Merantix Labs also does, so any consulting customized solutions, where you basically say, okay, you have a very specific problem, you want to get a solution for that specific problem, and that's it. But what's really interesting and is this middle ground, which is more kind of the self-service solutions, where you say, okay, I agree that not everybody will have the exact same problem, but I also don't want to build everything from scratch every time. So you're thinking about like solutions that are to some degree productized. So in our case, SEA Search, it's a data management solution, it's a product, we ship code, like Vara in some sense, but in the end, the customers do very different things with it. So one company is using that for their autonomous driving use case, another one is using that for their remote sensing application, which are very different applications, and we don't care. So where we basically say, okay, there's a product, but like everybody can customize it. And that space is super interesting. And if you think about how at least we internally thought the things would look like, we thought 5 years ago, we thought, okay, either you build a product and that's it, and you scale it like a normal vertical solution, or you say, okay, you fully customize it, and it's kind of a consulting solution. And anything in the middle basically is just like, okay, there is stuff where it's neither nor, but like whatever, let's ignore it. But like how we see it today, and this is a bit exaggerated, but I think for a lot of product applications of AI, you realize that it's maybe not that standardized across customers than you would think or than you imagine. And sure, medical imaging, maybe autonomous driving, there are a few where this is the case. But like for many, especially when you have to do also with more business processes, you realize, okay, every company is slightly different, or it's a manufacturing, every factory is a bit different. And then it starts to become difficult, and you're like, okay, yeah, trying to build a product, but also I don't want to customize so much, then it doesn't scale. And so I think we believe that this middle ground is actually super interesting, where you say, hey, we ship a product, but then we give people a lot of degree to customize it. And I think this boundary will even be pushed more. So we see that also now with Merantix Labs, where we run right now like individual projects with clients, and then after running 3-4 projects with different clients in very different industries, we realize, okay, wow, actually 80% of their problem is the same, even though the business process looks very different. And so especially in language processing, where it's around processing documents, we see, okay, actually, if we would have given them a self-service solution, they could probably customize it. And so I think this is very interesting. Obviously, you need to be a bit careful when you think about the characteristics of these self-service solutions. So you need to still make sure that there's some generalizability across organizations. You also need to make sure that kind of what cloud providers and I guess open source is pushing in the market is it fits nicely in with that, because the cloud providers have also very much noticed this, and so they put a lot of self-service solution out there, whether it's computer vision, natural language processing, recommender system, and so on. And so they are also pushing very much here, and there's also more and more open source, which is easier to use. So when you start trying to build a company in this space, you need to make sure that you're somehow more enterprisey probably than open source, or make sure you add a bit more value, but you also maybe not competing directly with the cloud providers, because that's also obviously something where you need to be a bit careful. You also need to make sure that the capabilities that the customers are there to customize the solution, and that depends really also who is there on the customer side. So it could be developer, it could be somebody like for ZIA Search, data management. We're mostly selling that to developers, so they can also code, they can use the API. It's a different interface. For other applications, you might rather choose something like in the no-code, low-code space, where you say, okay, this is something where also a business person should be able to customize it. You need to make sure there's data available to the customer, because differently to Vara, where we don't need to train again at the customer because it's a globally standardized problem. In this case, I mean, because you're customizing, you also need to make sure that data is there in the right quality. And then there's still always this vertical versus horizontal trade-off in the end, where you say, okay, do I add a bit more functionality to my product, but then basically can potentially serve a smaller market? Or do I keep it a bit more shallow, but then you might not provide enough value to the customer? And so I think there are lots of areas where you can look at. I mean, quality control is a great example where you say, okay, every factory produces different products. So yes, you want to ship a visual or acoustic quality control solution, which is a self-service solution, but then the customer can basically adapt it, automatically train it with their specific products, or predictive maintenance, very similar. Anything around documents, I think there's, documents are very different in different companies, and so you also need some adoption. And then anything also in the data management, ML ops space, where you say, okay, we provide tools to enable others to build machine learning solutions. So these are all areas we're looking at. Business intelligence, I mean, we just started Cursor, and then data management, ZIA Search, and document understanding, we're also looking very, very heavily at right now. And so with this, I'd like to wrap up. If you want to join us, we have lots of open positions. If you want to found a company with us, if you want to build algorithms, if you want to work on the business or sales side, all based here in Berlin, both full-time and internships. And we're also opening an AI campus in Q1 2021. So with this, let's start with some questions. Thank you very much.
And we've got some questions already. The first one is it possible to invest as a private person in Merantix? Unfortunately, it was not possible for me to find Merantix equity.
We don't take investors into Merantix, but
right.
We have a fund, so through that, private persons can also invest. But they need to be above a certain threshold, so yeah.
All right. And the other question is also about money. Your total fund, how big is it? Is it 25 million euros, it says here? Yes, all right. And will this be enough for your ambitious projects? That's my question, no?
I mean, right now, the thing is, we're a very operational model, right? Like we're not writing checks, but we are actually building those companies from scratch. And so with the current setup, we believe we can basically start 8 more companies in the next 3.5 years. Right. But we couldn't build much more. And then, so the number of companies with our current setup is a bit limited. And then the other thing is, from Series A onwards, we are also taking in external investors and funds into the companies. So then for the follow-up rounds, for example, for Vara, we did a Series A earlier this year. We also took a few investors from the outside to further capitalize the companies. Right,
and I wonder how you pick the companies you want to build up. I mean, you showed the overview of the topics that are particularly hot or interesting at the moment. Are you looking for companies in these certain sectors, or do you see what people offer you and then just choose the best ones, even if they're all quantum computing companies, for instance?
No, we try to diversify a bit. Right. So we also, and we sometimes even, pick founders and residents based on certain areas we want to get in. So for example, biology was a space we were very excited about, and so we looked very focused for a founder who would start a company in that space with us. So sometimes it's also a bit targeted. We would not start 5 companies too close to each other, because also we want the companies to collaborate very openly with each other, and if they would be in competition, it would be a bit harder to collaborate, and so that's why there needs to be like a certain distance between the companies.
Right, and this next question might be a little philosophical maybe, but you talked extensively about natural language processing, and there was this really great example of a long email coming in with business proposal, and then you have like 4 little answers, like yes, no, we only give half of what you want, or whatever. And then it's turned into a big email again. And I bet on the other end, if this future comes to pass, would again be like an AI dumbing it down, then expanding it. Shouldn't we then skip the whole procedure of writing long letters and just say 94 million or 940 million or what it was?
That might happen. It might be that like you just end up sending like structured information,
Right.
some bullets, and then in the end you have some AI or some model on your side in the end that kind of presents it to you in the right format you want to read it in. So if you feel
Yes.
like you want to read a full email, then you show it as an email. If you're like, hey, I don't want to read all this like text,
Right.
just summarize it to me in bullets, then you could just get the bullet
Right.
format. So I think
And if I'm a romantic person, I could say make it nice, and
Yeah, you
then
can
it
make it-
adds additional
Exactly,
maybe
exactly,
lubricant.
exactly.
Okay, that's very interesting. Isn't this also for tech-savvy people like us? If I, for instance, rent your solution or use it as a service, isn't that a bit cheating? I mean, for people who really put in the effort, write the email, or think, oh man, this Daniel, he's so nice, he writes me a long letter.
yeah, I think we will get used to it. I think like right now it feels very weird. Probably in like
Right.
20 years, it's so normal that you know that like a lot of the text you read is not written by a human. Like that's like a mental concept in our brain that like text is generated by humans, but like why should it be, right? Like
Sure. And if you, what do you, because yesterday we were talking about like artificial persons and actors maybe that can be put in film. Do you think if I have a particularly good or distinct writing style that this will be patented? There will be like an Umberto Eco AI, and the heirs will have the rights to his particular style. Do you see this coming?
I think there will be ways where you say, okay, put that into a specific style of writing,
Right.
or like put that into my style of writing. Because I agree, like everybody has some, like a certain style how they write emails, right? And so it's distinct. But I think you can also learn that from your historic emails.
Right.
If you would give me all your historic emails, we could probably build something that sounds very much like you based
Right.
on that data. So
Are you using prototypes of this already?
yeah, we're working on this internally. It's more internally, not to the outside. No, like
No,
all
no,
the-
okay.
Yeah.
I was not right. I didn't want to go paranoid. Like, is Rasmus' email legit? No, but how do you use it? I mean, do you just play around with it, or are
Yeah,
there
we're
cases?
playing around. Like we have a few prototypes right now. We're running a few things with customers. I mean, this is the space. The founder in residence who's looking at this, he started this summer, so he was a first employee at a legal tech startup near the OpenAI ecosystem. So he has a lot of experience in that space, and so with him we'll now double down on starting something there.
Adrian told us yesterday that for every job in the company, he has like 50 people applying for it, and he told us that now he can, because they're all talented, he can choose the nicest people, right? And I just wanted to get your perspective as a CTO. Are you also looking for the nicest people, or is it sometimes just the guy who's the most brilliant coder, or?
No, I think we look for both. I mean, probably Adrian mentioned that yesterday. We're doing on-site days with everyone, so everybody has to come 2 days on site and work for us and with us. And so with that, you really get to know the person.
Right.
This is like, because like for all, we have like online tests and like, you know, things which are more like quantitative and also in the interviews, but like in the end, you also want to see like, can you collaborate with this person? Because as I said, with the dual PhD problem, they will have to work with people who have very different backgrounds, and that needs to work because otherwise you will not build a successful company.
Right. Are there still things at the moment that you cannot do or cannot find and are desperately looking for, like a certain person with these or that qualifications, or a certain startup which is doing something where you just desperately want to get something and don't have it yet?
I mean, we are always hiring founders and residents. I think that's the thing where we have like a lot of applications, but it's in the end it's still like hundreds of applications of which only very few get hired. So I think because also the founder DNA is very mixed. Like some have like super technical background, come right off academia, and have the drive to start a business. Some have domain knowledge in a very interesting domain. Some have started a company before. So people have very different backgrounds, and that's that makes it also very interesting, very wide the funnel. But like in the end, we need to drill it down.
Sure. Like, obviously, you're starting next year in April. You'll open your doors in Berlin, I think. This will be the beginning of something great. Tell us about your plans for the next 5 years, or maybe not plans, but visions. Like, what do you think in 2025? What will we look back at, and how do you see Merantix, but also your many companies there?
Yeah, I mean the next 3-4 years are really about basically deploying the fund and building the next 10 companies, and I think that will then be really the foundation to scale it. And I think scaling you could do in different directions, right? Like you could either say, okay, now let's see how we can build even more companies at the same time, or we say, hey, how can we kind of do that with even more capital, even more human resources. And maybe then the 5-10 years after, we start similar amount of companies, but like with much more capital or so. Like that's still up to a discussion.
And just, of course, like just at the moment, do you think there's a good chance that you will stay in Berlin?
Yeah, yeah. We have. I mean, we have all our people are in Berlin. We've been here. We will stay here. We think Berlin is great for attracting talent internationally, and it's also getting even better with everything happening around the world. I think Berlin is very well positioned, and so we believe very much in this, like in the end, like water cooler chat and this like exchange of people, which obviously now it's a bit of an anti-COVID thesis, but like I think especially in this early phase is super important, and so that's why we want people to be close to each other.
Although it's rather the Mio Mio Mate crate talk in Berlin,
exactly,
not the water cooler. Okay, we're very glad to have you in Berlin. Thank you very much, and good luck with Merantix. Thank you.
Thank you very much.
Thanks.
Thanks.
Our next speaker has set up the Applied AI initiative Unternehmertum. It's one of the largest European initiatives in applied sciences. He holds a PhD at the Entrepreneur Research Institute at the Technical University of Munich, and he has a background working for McKinsey. Today, he's the managing director at Unternehmertum. Please welcome Andreas Liebel. Yes, thank you for your applause.
Yeah, so thanks for having me here now at the day for Applied AI, and I'm speaking here today for the Applied AI initiative, and just want to give you a bit of an overview about how we are thinking about scaling AI, because that's ultimately what counts. We need to get AI into application. Yesterday we heard a bit about the paper tigers in Germany. We tend to talk about things, but it's really about getting it into application. So what are we doing? So our mission as Applied AI, as a kind of a non-profit organization, is to help the whole country to get to an AI age by accelerating the journey to a AI maturity. And the question is, what is this? I will talk a bit about this in a couple of minutes, but that's actually our goal, to really help a whole country, the whole industry, to get to that level. And we do that by two different things. On the one hand, we work on a kind of a platform model, so we try to help as many companies as possible. And we just heard Rasmus with Merantix on kind of building AI-first startups. What we're trying to do with a kind of a second part is to work with the companies that tend or intend to become kind of AI-first companies, to help them to go there, to really work on the core innovation topics of companies to become AI-first companies. And if we look at AI and kind of the AI journey of how you actually apply AI, it's first of all really important that we consider the application of AI not as just one large thing that happens, but actually there are also maturity levels. You start, we heard about this from Christian this morning, you start with doing experiments, you start with doing POCs, and that's actually the first stage. So you get to know this technology, but you actually tend to get stuck at that level. It's not easy to get from this POC to the next level. Next level is practitioner. Practitioner meaning really applying AI into the first 2 to 3 applications, really getting to understand what AI means for you. And the third stage is then really professionalizing this. Because at the second one, it's really hard. It's really a lot of effort you need to put in. It's less replicable. So it's not really efficient, and you won't get much value out of this. So the third one is really about getting value out of what you're doing with AI, scaling it globally within your organization. And then there's a fourth pillar, which is the shaper. And shaper is really meaning you change the way your industry thinks. You build new business models. You really, you really become an AI-first company. So, and if you look at the numbers that are here, most of the companies in Germany, and you have various surveys on that from Bitkom, from others, you actually, many of the companies here in Germany are at this, not even started with AI, or at this experimental level, while there are very few companies here really on the shaper level. There are a couple of startups there, but really on the majority of our industry, we are very much in the beginning. And that's the issue, because also from a political side, from a government side, what we're doing in our AI strategy is helping to get companies used to AI, to get them up to speed. So that's really focusing on this not started and experimental levels of what we're doing also from a political side. But if you look at the AI strategy in Germany, in Europe, what we want to become is global leaders. We want to compete globally against China, against the US, against other countries, and we want to maintain a position where we have our hidden champions, where we really want to be AI-first companies. So we need to get there. And that's what's not happening right now. And the question is how to get from these early stages to these levels here, the professional and shaper level. So let's talk about this today. So what we are doing, and I said this, we try to help as many companies, so we try to shift the curve, right? So there are many companies at this very first levels, and our goal is to help as many as possible to become level 3 and 4. And what we do as Applied AI, we publish quite a bit. We try to develop tools that help as many companies as possible, very practical things that help companies to really become at this level 3 and 4. We do trainings. We do the mentioned Elements of AI course in Germany. We built other courses like Foundations of AI, all free courses that we offer. We have an AI lab. We do kind of assessments, conferences, tools, and so on. But now, really, let's focus today, when we talk about applied AI, about scaling AI to get from this practitioner to the professional level. And there are quite a few studies. This is one from MIT and BCG. And let's focus here on that lower part. And that's kind of confirming what I just said. Of the 90% of the companies that have made some investments in AI, only 40% really report business gains. And business gains meaning some gain at all. It's not really kind of drastic gains and transformative activities and really changing the business, but some gains at all. So what you can see is most of the companies actually struggle to get value out of that. And there are a couple of reasons, and we heard a little bit today, but kind of we cluster it into 3 different parts. On the one hand, we talk about data, and data is not code. And that is really, really difficult to understand for many companies, because you typically tend to write code, you have software engineers, and you actually get a program out of this. Now you have data as the main source that kind of builds your model. And that means that you need to treat data in a way that it's reliable, that you can actually scale with the data. And I mean that means that you actually need to talk about reproducibility, auditability, and all these things, and that is based on data and not on code anymore. So that's kind of the first really difference from kind of traditional business, and that makes it really for companies to struggle on the AI journey. The second one is that we talk about training and not development anymore. So it's really a much more experimental approach. You have uncertainties that lies in the solution space. So you don't really know where to get and what you actually need to do to come to a specific solution, while until now, the biggest uncertainty was changing user requirements. So that changes. That's the second part. And the third one is that we go from a verification to an evaluation of the system. So we need to retrain. It's not that you do updates, that you do patches, or debugging, but it's really a completely new training if you have model drifts and all these things. So you also have to take care of what's happening in the maintenance and the long run of actually using AI, which is totally different from what has been done typically in modern software development. And that leads to something that Andrew Ng actually put quite nicely. We learned in the internet area that if you take a shopping mall, add a website, it's not an internet company. And today it's the same thing. If you take any company and if you add deep learning, then it's not an AI company. And that gets you, if you do that, that gets you to that maybe practitioner level. You have 1 or 2 or 3 AI cases and that's it, but you will never get to a professional company or this AI first, these shaper companies. You need to rethink how you do business. So how we structure this is along a kind of a house. You need to redefine your vision, your ambition of what you want to do with AI. You need to systematically talk and think about use cases, about the whole organization, the enabling factors within the organization. Then you need to talk about execution and what you do different, what I just said about this kind of code and data topics, trainings, and so on. So you need to think also about the different execution process. It's not a classical development process of what you are used to do in companies. So we take this type of structure, and this type of structure is actually valid for each of these maturity levels. And the questions in each of those maturity levels change for all of these dimensions that are on this list. So it changes for the organization. You might have different structures in different parts of the maturity, also different people. The AI technologies changes and the requirements changes and so on. So what does that mean in practical terms? And this is one example. We just take a look at AI in production. And you might start with using a computer vision algorithm to detect errors and like parts that are, have some kind of scratches or something within your production system. So the ultimate thing, what you need in the beginning is actually the data, good parts, wrong parts. You have to find and identify a good model to train the data with, but that's all. To prove that an AI system is capable of coming to a solution to provide value is actually some data, some model, you do the training, and you have this. So that's your proof of concept. In the next phase, if you talk about applying AI in that specific case, what you need to do is to think about how to integrate this. And if you integrate this kind of solution in the whole production system, you need to have the system integration to your cloud infrastructure or your on-prem infrastructure that then collects the data from your camera. And then you have to have a process where you decide what you do with the parts, what you do with the output of the AI system. And the output could be it's a correct part and it's suspicious. It's something that might not be correct. And the question is how you split between correct and suspicious, because you always get a probability. Once you have these suspicious parts, you have maybe a manual inspection, and then this person then decides if that's still a correct part, or if maybe it's something that actually has a scratch or something on the part and just puts it out of the production process. And then you have the feedback loop to the overall system to then maybe start retraining that from time to time. And the system then gives you the recommendation for the overall process. So that implies that you talk about a process. That implies that you talk also about liability. So who is liable if that part that comes out of that is actually something that causes you to have like major recalls in like getting cars, for example, back because there's a really critical issue. That is also a question of how you deal with that, how you train these persons. So it's more about the process of implementing the AI solution in your business. And suddenly you don't talk in the kind of the strategy house here. You don't talk only about data and the AI technology, but you talk about the execution. You talk about the people that are working on that, the processes, the governance structure, and so on. That's the level 2. That's if you want to be practitioner. If you talk about professional, it's not feasible to just stay with a computer vision algorithm for one part in one plant to do quality control. But you now start to think about how can I use computer vision in my production overall, because I have it here, and maybe there are other use cases. There's maybe kind of quality control, picking and logistics, manual production processes, the supervision of the automation systems and the robots in the machine, so you can use computer vision in more parts. If you talk about this, and if you have this larger vision of how to use computer vision in your production, you then think about a data pipeline for all the pictures, for all the videos you actually get. And you talk about privacy and anonymization of data for all the recorded pictures and videos here. You talk about the correctness of the data, bias, also cybersecurity in this data pipeline. And then on top, on the model, you then talk about auditability, about benchmarks. You need to know if the system is better than the one you had before, about validation, reproducibility, explainability, stability of the system, because you don't want your factory to actually have, you need to stop because your system, for example, is not stable anymore. So you somehow come from one case to talking about data pipelines, talking about infrastructures that are on top of one case, but it's applicable for many cases. And then you talk about the whole structure. And that is the real challenge, that you move away from AI as a technological question to AI as a company and organizational question. And what I can only agree to Christian was he said that AI is a CEO topic or C-level topic, because if you want to tackle AI at this professional level, you need to really think about this whole structure. And that means that it's not only a tech topic anymore. So how we deal with that, we just published today a AI journey map. You can find it online on our website, appliedai.de. And what we did is to, first of all, classify and structure all the challenges that typically companies face to get from the first level to the fourth level in this AI maturity on the AI journey, to help you understand what's coming up. And because that's what you ultimately need to understand, is where are you at these kind of different levels, and what are the next challenges you need to tackle in order to become more professional. So that's the first step. As I said, we try to publish as much as possible. In the next phase, we further fill this out, and we then provide solutions to all of these questions, because ultimately it's about then actually helping companies to get through all the different levels to mature on this journey. But as said, you can find this online. You can have a closer look. We did this exercise with a couple of companies, and they really liked it because it helps them to provide an agenda for next year. They don't know what to do, but if we have the structure and if you really thoroughly go through it, you actually have a roadmap of how to mature systematically. Now, talking about this, what I said about this practitioner to professional level, from our perspective, there are a couple of points that you need to consider and tackle and kind of the challenges at that specific level. The first one is you need to talk about this AI business models. You don't talk only about this classical products and processes, but you really need to rethink about what AI would mean at this larger scale if you apply it in your organization. The second one is human-centered AI. What we see in many companies is that they stop prototyping now. They tell us we have enough prototypes. Some large companies have 200, 300 prototypes, and they stop developing prototypes. They only focus on process changes, incentive system for the people, upskilling of people to really get to the application of AI. So talk or think about the human that's behind the system that actually needs to apply AI. The third one is from single cases to use case clusters and value clusters, because ultimately there is a specific capacity in your organization of how many different topics you can handle as a core team within the organization, and you need to decide and re-evaluate what are really the core cases you need to focus on. fourth one is getting to these data pipelines. I quickly mentioned this. And the fifth one is kind of really getting from AI projects to an industrialization framework that helps you scale AI drastically and reliably within the organizations. And these questions are not easy questions. There are no good best practices outside. There have just been a couple of books from Google being published on especially on the latter two points, on the pipelines and the industrialization of how they do it, but that's kind of questions and challenges that all the companies face, and that we hopefully also as Applied AI try to tackle together to then provide it again, because ultimately we need to answer these questions to become professional users of AI technology. And I just emphasized it, AI is not something that is done by the experts, but it's something that needs to be done at a board level, because ultimately the board needs to define the ambition of what you want to do with AI. And most of the companies that we work with then also at some point struggle with sufficient understanding, with sufficient commitment on the board level. We just published this artificial intelligence for boards with more than 20 C-levels that comment on what it meant for them as a company to really start using AI. And this ambition is something that maybe is a bit underestimated. Maybe it's not visionary enough, actually. There are quite a few companies in all different sectors that really drive AI. And just due to the lack of time, just want to emphasize the first one. So please, if you don't know Ant Financial, Google them and see what they are doing. They have the goal of 0 human operations. That's one of the largest banks in China, and they really kind of challenge all the processes in banking with the goal of having a fully AI-driven bank, and it's maybe one of the most advanced companies in this sector in the world. There are quite some articles about that, but this is something what maybe is an ambition in that sector, and you have all the different other examples in all the other sectors. So, final point, what's your ambition? What's the ambition of you in your industry? Because that ultimately drives where you want to stay. Many companies want to stay at that practitioner level. That's also totally fine. If we have the ambition to stay global tech leaders in the world, to stay hidden champions, we need to think about these two categories. And that means for you as a board member, as a C-level, that you have an ambition within your company, because otherwise you won't get to that stage. So thanks. From my side, that was kind of a bit of an insight of what we're doing as Applied AI. Happy to get in touch with you, happy to follow this vision to really transform our economy in Germany and in Europe, because that's ultimately what we need to do, what we heard yesterday that is essential for us. Thank you.
Thank you very much, Andreas. We don't have questions from the audience yet, but we are very glad to take them. I have a couple of questions. I was impressed by this almost gigantic map called the journey, right? And I thought, that's a long journey. Do you think this is like encouraging to CXOs or rather off-putting, saying, well, maybe then I don't need AI if it's that complicated?
Well, I think it's necessary and it's realistic.
Right.
What we did in the last couple of years in Applied AI is actually collect all these different challenges from all these companies. And if you don't, listen to talks on stage from these companies, but if you talk to them in person, they talk about these challenges and they tell you we are at that point and we don't know how to continue.
Right.
It's from my perspective, it's realistic, but you've seen also the numbers. That is an explanation of why these numbers are so much on the left side of this picture. It is a challenge, and obviously, it's not easy because otherwise all the companies would be level 3 or 4 already.
Sure, we've seen a lot of different problems. Of course, on the graphic, everything looks the same, has the same size, the same font. So, in which phase, or maybe where exactly on this map of a journey, are the biggest problems, or the time where everybody thinks, oh, I'm not sure if we're going to make it as a company?
Yeah, I think, so on the one hand, it's this ambition and commitment.
Right.
So on the very top of this landscape, because if we heard about from Christian about this kind of play money you get to kind of experiment and so on. That's all sufficient to get to this first level, to the experimenter. But at some point, there needs to be a commitment from the company to really start transforming, to really think of AI first, or professional use of AI, and that's a different commitment that you have to take. So that's a large struggle. And then I would say on the execution side, on this industrialization framework, that's kind of our main focus also next year, because we haven't seen any working industrialization framework outside of the big digital tech players. And this is one of the key challenges now for many of larger and smaller companies in Germany, that they need to get from this one or two working use cases in the organization to scaling it, to professionalize it, to make it reliable and stable. And that, from our perspective at least, is one of the largest challenges, because it affects the infrastructure on the software hardware side, the data, it affects the organization as a whole. So that is something I would say is one of the largest challenges.
Right. I also remember the slide where the proof of concept was just the first of 3 steps or 3 phases. And we were talking about the POC graveyard before. Yeah. So how do you advise people which concepts to prove at all, and to decide after you have a proof of concept if you should go forward and implement everything and roll it out?
So what we do is we actually challenge companies quite a bit on this core AI, what to do internally for themselves, and what is something that they just do with partners. So, and from our perspective, 90% of the cases they should do with startups, should do with any other providers, because it's not something they should do in the long run on their own. They don't have people to do that, they don't have the expertise, and they simply don't understand this question of retraining and technical depth and what's all associated with maintaining AI systems. Our first discussion always is that really something you need to do on your own? Mm-hmm. If not, there are so many good startups, you can work with them, and it's so easy to get these kind of first prototypes running, and then also they help you to get into application. Then you get rid of most of the questions and challenges there. And then there are quite a few really essential AI applications in the company that really affect their core knowledge, and where they say, well, that's something we need to do internally.
Right.
And what we do now is to help them then mature on that, but it's kind of reducing the vast number of AI use cases to quite 2 or 3 or even 1, and then you really can focus on this one and have partners, strong partners outside of this.
Right, and you also showed a quote, I think it was a quote by Andrew, which said that having a company and adding a bit of machine learning doesn't make it an AI company, but I think the truth is also that not every company has to transform into an AI company, right?
Exactly, that's what I meant. It's totally fair to stay at the practitioner level. It's totally fair to have 1 or 2 startups you work with to do predictive maintenance.
And how do you deal with the fear that maybe it might not be enough? Like the other company across the road, if they transform themselves more, then in 20 or 50 years, we might not be on the market anymore.
I would actually be happy if that's the fear of most of the companies, because right now, many companies don't even think about, they think it's enough. They don't see that it's maybe not enough to get there. So what I'm telling them is, well, you need to think up globally about the companies that are at this level 3 and 4, and you need to get there. So I would be very happy if companies fear that what they're doing is not enough.
Right. We have one question from the audience. From the perspective of policymakers, where do you see the biggest leverage points to help companies advance through this journey?
Yeah. I only shortly mentioned this. From my perspective, what's the kind of wrong approach, missing approach now is that right now policy only really focuses on the very first levels. What I would like to have is a program that helps to scale AI with the goal of getting to this professional and shaper level. both on the startup side, we have quite a few programs, but they all focus on tech transfer and so on. We don't have good programs to build global champions, leaders, these shaper companies on the startup side. And we don't have systematic approaches that really help and accompany companies along the journey to also stay maybe global hidden champion or actually become hidden champions. So on the both sides, if we have the ambition to stay there as Germany, as Europe, we should focus on these 2 steps, at least as a vision, and with kind of programs from also supported by the government, by the politics, to really systematically get there and don't stop at the first levels.
Thanks very much. I'm really impressed how detailed your insights were. I'm sure there's a lot more where this came from, and I hope that everybody who is interested takes a look at it. Thank you very much, Andreas Liebe.
Thank you.
And we will take a short break now. Please remember, if you go anywhere, wear your mask and stay on the marked path. We'll continue at 1200 Central European time. I'm looking forward to it. Thank you. Welcome back. I hope you had a great break. Just a quick reminder, at 1300 Central European Time, things will also be happening over in hybrid space. But now we will hear a keynote on quantum computing and machine learning. Our speaker asks, is this a dream team or just the next hype? As if one would exclude the other, I might say. But I'm very curious what the head of AI and ML at Telecom Innovation Laboratories has to say about that. She's a member of the Bitkom board for artificial intelligence. She's a big contributor to Berlin's startup ecosystem, and she was honored as one of the global women leaders in AI. Give it up for Claudia Polink.
All right. So hello, everybody. And first of all, I would like to thank you, Veronika and Fabian, for having me here today. And my deepest respect, because you transformed this physical event into a virtual. And this is so great, so amazing to all of you and also the team, I think, that was behind. So congratulations. Yeah. All right. Quantum computing and machine learning is the title. Dream team or just the next hype? Yeah, so today I would like to take you with me on our journey at Deutsche Telekom. And this means this is a journey to enter a new technology, quantum computing, quantum machine learning, quantum technologies. And I don't know if you have ever wondered how a new technology enters a large corporation. And today I would like to do some whistleblowing, or in German, aus dem Nähkästchen plaudern. 2 years ago, we evaluated AI trends to detect the next white spots for us, because we are working at the R&D department, and our horizon is 3 to 5 years, sometimes longer. And our job and our mandate is to explore new things on the horizon. Yeah? And then in the cluster devices, quantum computers popped up. And then we checked this in our team with the experts and the usual suspects, and we decided just to dive deeper in this topic. So let's just start. And why am I telling this to you? When you would like to start a new topic, and I mean a new research area and a new research topic, then you need persistence, curiosity, and also imagination. First of all, you have to see the potential and not having all the time numbers or KPIs in your mind. This is my first takeaway for you. So I won't talk about how a quantum computer works. To be very honest, 20 minutes are far too little. Yeah? So I brought a nice quote from Richard Feynman to you. He is a physicist, or he was a physicist and Nobel laureate. He said, I think I can safely say that nobody understands quantum mechanics. So do I. And this quote is still valid. Yeah? So, what I would like to give an overview today is how we observed this new technology and how we explored use cases, how we can transfer these use cases into our business, and what will be the next level of this whole technology. Yeah? And quantum is quite a large field of science. So, including chemistry, biology, also some other stuff which is called quantum sensing. Yeah? But we at Deutsche Telekom, we focus on quantum computing and quantum secure communications. Quantum secure communications is about keeping communications safe, where keys are secure today and could be broken in milliseconds. And quantum computing, this is not only about hardware. Quantum computing, let's try understand it very simple. Quantum computing is about transforming complex combinatorial problems into this new world of quantum physics with the help of algorithms. And I mean you have to program algorithms in another, completely other way. Yeah, so you have to think in energy functions. And when you implement these new algorithms on a computer or on a quantum computer, then you have the hardware as well in the field. And today I would like to focus on the field of quantum computing to make it very simple. Yeah. Okay. Again, this is not only about exploring a new technology and play around. This is, of course, to find use cases. Yeah. So complex problem solving is becoming much more efficient than with classical computers. So that's why let's try to see, or let's scratch on the surface. Yeah? We all know classical bits, where we have states either 0 or 1. So far, so good. The counterpart in quantum computing is a qubit, the quantum bit. And the quantum bit can also have the state 0 and 1. But the huge difference is that the qubits have this state at the same time. Yeah? So this is called superposition. And by the way, this phenomenon is unusual. This phenomenon, this effect, this is the game changer. What I think. So let's just take another classical bit. You have 4 states, 0, 0, 0, 1, for instance. And if you have 4 numbers, 4 states, then there are 16 combinations possible. And you can only use 1. With a qubit, you can have all these 16 combinations at the same time. And if you add more qubits, the growth is exponentially. So if you have 20 qubits, so this, let's say, computer is able to process billions of data or states at the same time. And this is, let's be very honest, this is the magic behind the quantum computers. There's also another effect or phenomenon, this is called entanglement. Entanglement is the connection between the qubits. So it means that if you change one state on a qubit, the other qubit reacts instantly. Yeah? So entanglement allows qubits that are separated by incredible distance to interact with each other instantly, also on long distances. Yeah? On the right-hand side, you see also some more differences, but let's stay here. The most important thing, what you should know is, it is about speed effects. And we would like to focus at the moment, and I'm talking about our, let's say, status in our R&D department, we are exploring optimization cases, yeah? Because when you have complex mathematical combination problems, this is about optimization. Yeah? So our goal is to find use cases with the goal of optimization. Okay, so this is an example to understand this complex stuff better. Yeah? Routing optimization. And this is also known for a long time as this traveling salesman problem. Yeah? So routing optimization is not only in networks, it's also in logistics, field service, navigation, and so on, in the traffic. And this routing optimization is influenced by different factors. And then we have the, let's say in our case at telecom, network points. Yeah? You see this table. We have 3 network points, 6 combinations, 4, 24. And if you have 20 network points, you see the number. This is just to illustrate the amount of combinations. And in this case, traditional computers reaches its limits. Yeah? And what you can also see here is just a visualization. Yeah, I love visualizations with complex technologies. This could be also a navigation from, let's say, a salesperson who would like to drive to 20 different locations. But with quantum computers, you will be able to also use other factors for this optimization, because you can also include speed limit, traffic lights, air pollution, and so on. This is not possible right now. So here's the second takeaway. It's not only about speed, it is also about building solutions which are not possible yet. And this is again about imagination, because you have to think completely over the horizon. Yeah? So you have to find completely new problems. As I said, quantum computing will not substitute classical computers. This is the third takeaway. But it is restricted to certain types of use cases. And I brought some use cases with me. You can see on the left-hand side industries. You can see here already the companies who are in the making, and on the ground you will find the telco use cases. So this is not only about optimization, but let's say we will focus right now on network optimization, for instance. But customer classification would be also a use case. Of course, fake news, quantum key distribution, quantum safe encryption, service scheduling, edge computing, network anomaly detection, and so on. Yeah? So there are a lot of use cases out there, not only for us, but most of the companies, and this is the good news, are already working on these use cases. One step back, if we talk about quantum computers, then there are 3 different types. On the right-hand side, you see the classical quantum gate computer. I mean classical because this is the biggest thing, and you may have heard of. Yeah? IBM, Google, this is the gate computer. On the left-hand side, we have this quantum simulator from the company D-Wave, the Canadian company. And in the middle, you will see, or you see this funny name, digital annealing unit from Fujitsu. And this is a so-called bridge technology. So this is quantum inspired. And this is important if you want to choose your use cases. Yeah? Let's just think in edge computing. So this gate computer, of course, you cannot transport, as well as the other one. So most of the, let's say, bigger quantum computers are or can be accessed via cloud. And the future of quantum computing will be in the next years cloud business. Yeah? But if you see this chip, this is also possible to implement in networks, and you can distribute also the load of your networks, for instance. Yeah? So you would be able to distribute the whole power of computing. Yeah? Federated computing, whatever. So I don't want to make ads here for Fujitsu, but this is just an overview about the technology right now, yeah, the hardware. Okay, and again, if you have identified the use case or the problem class, then there are 3 different, let's say, characteristics, or should be. It is a sufficient problem, complex problem, recurrent, yeah, and you expect a near-time response. And on our journey, I can tell you, we identified some use cases, and then we found out, okay, this is only done once a year. Therefore, you don't need a quantum computer. Therefore, you can, of course, use all the other old stuff. Yeah, and then you can also see the mentioned use case classes, problem classes like this Knapsack problem, the traveling salesperson, routing problems. And then here in the field of quantum gate computers, then we come to the quantum machine learning. Yeah? Grover algorithm for search in huge databases, where, of course, Google will have his biggest hope. Yeah? Or the Shor algorithm for prime number decomposition. So there are a lot of stuff out there, and you have to, let's say, find a way through the jungle. This is our, let's say, one of our first use cases. This is about frequency assignment planning. And you see mobile network towers. And at the beginning of every use case, you have to define the optimization goal. And this is similar to data science cases. So you need the scientists, but also the domain experts. Yeah? And then it could be an optimization goal. Firstly, maximize number of allocated frequencies to meet the traffic demand. And we are talking right now about 2G, not 3G, not 4G, not 5G. Our case is in the field or in the frequencies from 2G. And maybe you can imagine 5G will be much more complex with this assignment of frequencies. Yeah? And the second goal is minimize interferences, because this is one of our biggest challenges, to minimize the interferences. Yeah? So we just derived this Hamiltonian method. FAP stands for frequency assignment planning. Sorry for all the short abbreviations. We run that on a quantum annealer and benchmarked this result against, let's say, classical algorithms, because of course we are doing that already. Yeah? So in every case, right now at DT, you have to compare the classical method against the new method. And it could be that the result will be, okay, it will not support, it will not help. But then you have to search again. This is the game. Yeah. What I also brought with me is an overview of the ecosystem, and this is just because to give you the feeling that we are talking about computers. So there are also layers, the hardware layer, the system layer, the application layer, and also services. Yeah, so we have, for instance, end-to-end providers like IBM, Google, which I already mentioned, or the hardware players, the software players, and also some startups and specialists. This is also good to know when you work with partners or vendors. And as I said, it will be a cloud business. And you see all the global players here already on the chart, which is a sign. Yeah. And this is also just an information for you to see, okay, this is from 2018, by the way. There are a lot of languages in different layers. Yeah, and I just mentioned this new TensorFlow Quantum library from Google. Yeah, so you can try out a lot right now. This is not scientific anymore, science fiction anymore, and also not magic. You can try out a lot. And when it comes to quantum machine learning, it's very hard to say what is quantum computing and what is quantum machine learning. So again, I tried with a visualization. Yeah, you see on the left-hand side AI and ML, on the right-hand side quantum, and the, let's say, how do you say, overlapping thing is quantum ML. Yeah, I like this quote on the right-hand side. Quantum machine learning allows scientists to take the classical machine learning algorithms and translate it into a quantum circuit so it can be run efficiently on a quantum computer. So far, so good. Yeah. So to be very honest, there is not this typical quantum machine learning. So you'll use a lot of your machine learning knowledge to try out the first cases, because you need also Python, by the way. And this is another challenge, not only for the field of data science and machine learning, when we think in talent wars. When this technology is coming, we do not only need machine learning engineers, we also need the knowledge, or this should be combined with physics. Yeah, so start as early as you can. This is my recommendation, also with building up the knowledge and with finding or hiring talents. Yeah. And this is my last example for today. When we explore quantum machine learning, there is no starting point. Yeah? So first of all, we have to learn. And we used here this example from Hartmut Neven from Google, and it is about breast cancer detection and on X-rays. This was the classification goal. And we just tried to copy and to learn how we can do that, how we would do that. Yeah, so, and this is just the formula for the quantum annealer, I think, in this case. And here, this is the comparison of the results. Yeah, you see here classical methods, and then you can see also the new method. Yeah. So, and what would be the result? So, at the end, you have to explore a lot. You have to stay on your, let's say, imagination that there will be potential, and you have to find the specific and dedicated use cases, not only in the field of optimization, but also in the field of classification, segmentation, and cryptography, and so on. Yeah? So that's what would be my recommendation to you. And at the end, dream team or just the next hype, I would say, of course, a dream team, and we have to start. Okay.
Thank you very much, Claudia. I don't have questions from the audience yet, but that's maybe because nobody understands quantum mechanics and maybe also not quantum computing, although I was impressed.
Thank
For
you.
somebody starting with a Feynman quote, you seem to understand a lot about quantum computing. So that's much more handleable than the raw physics of it, obviously. You were talking about the different players that emerge. Which type of player is Deutsche Telekom? Do you know yet what type of player you are?
We're already working with players.
Right.
Sure. Yeah. So, and I read an article about BMW, I think some days ago, and they had the same journey as we had, but they, I would say, 2 years advanced than us. And they started with the same technologies, with these annealing stuff. Yeah, this is about optimization. There you can use the annealing technology, which whether it is D-Wave or Fujitsu. And now they turned their, let's say, bigger cases into the quantum gate computing area. So now I think they're working with the bigger ones.
Right. And you gave some advice at the end. You said hire talent early and start early, start learning. Was that advice you gave yourself as well?
I'm happy as I am, yeah.
Right, okay. So where are you in the talent wars? I mean, you obviously have a small but very, very qualified team, but I think Deutsche Telekom as a whole will need a lot more specialists, right?
Yeah, look, we started the whole journey 2 years ago.
Right.
And this means right now we identified a small community within DT, and the community are 10 people.
Right.
To be very honest.
Right.
Yeah, 10 people who are really in the topic and understands the quantum mechanics. Yeah.
Which is not bad for today. 10
Yes,
people
sure.
who really understand
yeah,
is
sure,
great.
Of course, yeah. And the other colleagues started already with quantum key distribution. This is much more advanced right now for us in DT. Yeah. But we also have to develop this vision for 2030.
Right.
Yeah, and our vision will be to develop a quantum internet. Yeah, something in that direction. Yeah, so have a lot of players, and I think this is not just a revolution; it will be an evolution.
Right.
Yeah.
And you said that you're working with the quantum annealing things. I don't grasp quantum-inspired stuff fully, I must say. But when do you think will you work with an actual quantum computer or with computing time on a quantum computer? Because you probably won't get one right away,
Sure.
right?
I think next year.
Next year?
Sure.
All right. And which type of computer will it be? Can you disclose
So-
that? Do you know already? Or
There's this nice race between IBM and Google. Yeah,
Right.
this is about the number of qubits which you can use. And IBM just announced, I think also some days ago, that they will offer, I think, around 1,000 qubits in 23.
Right.
Which is amazing. Yeah.
Right. And
This is interesting.
Are they? I mean, do customers already line up, or is it that they're rather looking for people willing to put in the money and the work and start using that?
Yeah, there's another an information. So I had also IQM on this ecosystem
Yes,
chart.
yes,
And
yes.
IQM is a Finnish company. And they announced this Monday that they will develop the first quantum computer in Europe.
Right.
And of course, this is a nice development, yeah? But if you develop hardware, you always need the applications and the use cases. So that's why they are also interested in our stuff.
That's really interesting. Apart from the frequency distribution and the interferences, are there other like practical things that at least you, maybe not the whole of Deutsche
Yeah.
Telekom, but you think you will solve with quantum computing in a couple of years?
Yeah, so when you navigate through the city, for instance,
Right.
or through the country, you will always get a recommendation from every navigation system what you have installed. Take this way or this direction,
Right.
from A to B.
Right.
And sometimes you're coming into this traffic, how do you call it? Stau?
Traffic jam? Yes.
Traffic jam, yeah. So then you get an alternative route, yeah, and you choose this one alternative route, like all the others behind you.
Right.
So how about just also distribute the traffic
Right.
and giving all the car drivers or the whole traffic alternative routes? You can use the whole city or the whole country.
Right.
Yeah?
The-
This is the holistic view. This is not possible right now.
No, really interesting. I want to try to relate to things we heard this morning and also yesterday about the management and leadership having to deal with like really new and
Yeah.
not to people mention it, but this seems like a really with technology with a big disruptive potential, right?
Sure.
So how is your upper management, how are your CXOs at Deutsche Telekom looking at these things? Do they call you every day? Do they have it on their minds?
As I told, it was a journey.
Right.
So this is not only about
It still is, right?
Sure, this is not only a playground.
Right.
Yeah. And you have to convince not only with ideas. Yeah?
Right.
So you have to present business models, and to be very honest, this is not possible right now.
Right.
You don't. If you ask IBM or Google or anywhere, don't get a serious business model right now because this is not possible yet. Yeah. So and that's the hardest part.
Right.
Yeah.
But as some speakers mentioned, it is maybe time to do business a little differently and explore
Yeah.
stuff before you have a business model,
Sure.
right? So is this
Yeah.
part of your
Yeah.
work to convince them that this is the time for behaving differently,
Yeah,
doing stuff differently?
This is about
Right.
a mindset change. Yeah.
Right.
Yeah.
And
you have to believe
Right.
in your experts. Yeah, and you have to, let's say, identify the potential and imagine what will be possible in the future. And then maybe you have also to inspire your CXO or whoever. Yeah?
Right. And we also had the idea today that it would be very fruitful to have some maybe non-executive board members from different technological realms. Is this a topic that is discussed at Telecom, or would you like it to be discussed?
First of all, I would like to start with trust.
Right.
Yeah. So I'm not talking about that I'm not trusted. Yeah. So this is not the thing, but I think we have to change this mindset also everywhere. Give them the chance to explore
Right.
such a new technology. And also, if you see the other companies, the big players, and I mean everybody is already dealing with quantum computing, there must be some potential.
Right.
Yeah.
Sure.
At least you can trust them.
Right. But that's of course the difference between, well, we have to do something in an area because everybody is doing it, or like really allocating the resources, right?
And the same with data science use
Right.
cases. Yeah. So we had that 10 years ago, the same situation. Yeah. So you have to start small and think big.
Right. So let's not talk about your management's vision. Let's talk about your vision. Like in 5 or 10 years, if everything goes really great, what would you be doing at Deutsche Telekom regarding quantum computing and machine learning? What do you think?
More AI and quantum computing research.
Right. And would you still understand how it's done?
No, I think
No.
not.
But you could probably understand
Try
the
to
results.
explain, yes.
Right. And what are your personal plans? Are you planning on visiting any physics lectures in the couple
We did
next
already.
month? You already did?
Yeah.
Oh, that's very interesting.
We also visited IBM in the US.
Right, all right.
I saw this real quantum computer.
Right, so this is also an opportunity for lifelong learning.
Oh, for sure.
Great.
Yeah.
Very exciting times.
Thank you.
Very exciting talk. Thank you very much.
It was a
Have
pleasure.
a lot of fun with quantum
Cool.
computing. Thank you.
That
Claudia
was the
Pulling,
goal.
everyone.
Okay, bye.
Thank you very much. Our next speaker has an impressive academic record. He has earned multiple master's degrees in engineering, in computer science, telecommunications engineering, and image treatment, and CAD design. He also holds an MBA from IMD Business School in Lausanne. He currently leads a global department with expertise in artificial intelligence, machine learning, software development, automation, and simulation. Please welcome the General Manager and Global Head of Industrial Computing at Siemens Digital Industries Factory Automation, Thibaut de Assy. Hello, Thibaut.
Hello, thank you very much.
Good to see you. We can see you, we can hear you. The floor is yours.
Perfect. Look around you. Look at the assets around you. Your mobile phone, your production machine, your robotic station. 85%. Huge number. 85% of potential assets remain unconnected. Yet, 87% of machine learning projects never make it into production. There will be 41.6 billion industrial IoT devices in 5 years from now. I cannot see your faces. Unfortunately, I wasn't able to come to join you in Berlin. And I am sure you are wondering how we Siemens are helping our clients in connecting, in protecting, and in turning data into valuable insights. And to answer to that question, I'm here with you today, Thibaut de Assy. When we help our customers in their journey, we really take the time. We really take the time to understand their pain points, to really understand the data flow across the whole value chain, and to really understand how operational technology layer is integrated with information technology layer. And then we bring our hardware and software integrated solution together with our industry know-how and our machine learning experts to answer to our clients' challenges. It all starts with data. There is different data sources in the shop floor. And from there, take a look at the circle and take a look at the left side of the circle. From there, we're gonna create an AI model. But this is not enough. Take a look now at the right side of the circle. From there, we're gonna create a software with domain know-how, including a human-machine interface, helping operators to take the right decision. But that's also not enough. We need to execute that software application on an industrial grade hardware. And for that, we need an industrial PC. We need an edge devices to realize customer value. We at Siemens, we are also offering in operation to manage the AI lifecycle, from connectivity to deployment to monitoring and training. And now, take a look at the bottom of that slide. That could be your power plants. That could be your production machine. That could be the elevator that take you to the Berlin conference or to your home this morning. On top of it, we have what we call the control layer. This is where with the industrial PCs or with the PLC, with the controller, are controlling those field devices. Then we have our edge layer. And for us, edge is not a simple gateway. For us, edge is about connectivity. It's about openness. It's about local data pre-processing. It's also about data and security. because security is at the heart, is at the core of our product portfolio. And it's about machine learning and artificial intelligence. The layer above is the cloud layer. With our platform MindSphere and with Mendix, we are offering to our clients an efficient way to develop their own industrial IoT applications and deploy those applications in the OT on the edge and on the edge layer. This is an example of a body shop. This is the whole ecosystem. At the left side of the screen, the number one, this is where we have the automation, the control layer with our SIMATIC products or other third-party products. Then we have the edge computing. This is our edge devices, the industrial grade hardware, where we are running AI application and non-AI application close to the machine. It's a cloud agnostic. And then we have an edge management system. This is a centralized management system for mass updates, for security updates, and for distributing application across the whole manufacturing line. We have also an app store enabling our partners, but also Siemens, to provide AI and non-AI application and enabling to deploy those applications on the shop floor. These are use cases where we are developing and creating impact with AI at our customer side in different industries. Take a look at the second use case in the first row. Smart assistant, Siri. I'm sure you have been using Siri to find the nearest French restaurant. Uber is becoming a verb today. We have Sam. Sam SIMATIC assistant for machine. It embeds natural language processing and knowledge graph, enabling the field maintenance engineer to communicate and to collect data from the machine and to execute its maintenance of a procedure in an efficient manner. Let's take a look on some of those use cases that we have been implementing in the industry. The first one is about defect prediction for die casting. Today, our customers are inspecting the parts at the end of the line. He's looking at the part manually, or he is using automatic optical inspection. He is scrapping more than 10,000 parts per year. A defect rate between 2 to 4%. At other customers, it can go up to 10%. What we have been doing here, we have been identifying key process parameters affecting the throughput of the die casting machine. We build an AI model and we deploy that model on our edge devices to make real-time anomaly detection and defect prediction and feedback that result to the PLC to prevent further productions of defective parts. It helped our customer to further reduce the process costs and defective products by 30%. And you managed to optimize the process and decrease the defect rate by 40%. And I am sure in your own words, you also would like to have such savings. Let's have a look on the architecture. So we are collecting data with our SIMATIC S7, the controller, what you see on the left side of the screen. Also additional data coming from different quality data, coming from quality management system and other sources. This data is fed into our edge platform that run on our edge devices. There we have our trained AI model for clustering and classification purposes. With the data, we have also a storage. And from there, we have also dashboard. This is where the operator can observe the data to take some decisions that would impact the die casting process in this case. We have also a cloud gateway to send the data to the clouds for data storage, further statistical analysis, training purposes, and later on deployments. The second use case is coming from the bakery line. It's about visual quality inspection. The baked product is ejected out of the oven on a conveyor belt down to the packaging line. Today, our customers are counting manually the baked items. The defects also could come from the degree of burn or the size of the shape of the items. So what we have been doing, we have been implementing an imaging system to get a near accurate count of the baked items, to localize the defects that might happen after at the end of the oven. This data would be sent to the PLC, where we have our AI model running there, and through the HMI, we would be able to look if these baked items has good or bad quality. It helped our customer to save time in inspection, to improve or reduce inaccuracy in the counting area, and to reduce defects. The third use case is about visual inspection in additive manufacturing. A BiderJet 3D printing is an additive manufacturing technology for making or for printing a product out of a digital file or out of a CAD file. This process could go up to 2,500 layers per job. It could last 30 hours to get the product printed. And what we have been doing here, we have been implementing a vision system to detect defects layer per layer. In case of defect, it triggers a stop signal for the printing machine. The operator could take out the product, take some measures, either put it back or discard it, and run another manufacturing cycle. It helped our customer to reduce time and rework around 2.5 hours per day. The fourth use case is about failure prediction for automatic guided vehicles. Today, at this customer, AGVs are being charged at the end of the manufacturing cycle. One stop of a single AGV results in 500 euro per minute. 500 euro per minute production cost. Our approach was to analyze AGV alarms from the reports, getting data from the charging stations, and develop an AI model to predict accurately when the maintenance has to be done. And this helped our clients to avoid stop in the operations, reduce production costs, and optimize the charging processes. Here you have, from architecture standpoint, how this would work. We have the AGVs, they have a controller. We collect the data from the AGV controllers. This data will be sent to an edge devices, where we have our AI model running there, monitoring system that provide the information. When do we have to send the data? When do we have to send the AGV to the charging stations? The fifth use case is about process optimization. It's about improving beer quality. I'm sure you love drinking beers. I do. So today, there is a kind of inconsistency per batch. Process parameters are influencing the beer quality at the end of line. And there is a kind of a beer sommelier after the packaging who is testing the beers and associating grades. And the minimum grade, it has to be 6.8. What we have been doing here, we have been identifying key process parameters influencing the beer quality. If you look at the overall process, we have raw material, brewing, cold block and fermentation, packaging, quality check. Parameters like time, pH value, alarms, yeast type in the fermentation area, dosing data in the fermentation, quality, energy, and so on. These are the parameters that have huge influence on the manufacturing processes. And we developed the AI-based solution to predict parameters for achieving such optimized process to get the right quality at the end of line. And we observe the trend. How we get to this 6.8 grade. And we correlate all processes together to achieve that result. We develop the model, and we train that model on the edge, as you can see here. This helped our customer to improve processes, to optimize his processes, but also to improve the quality of the product coming from its own supplier. The last 6 use case is coming from our electronic plants, from our Hamburg plants. Today, to inspect PCBs, we are using a very expensive machine, X-ray machines. What we have been doing there, we have been gathering data. We have been gathering data from the different process areas in the PCB manufacturing plant, from the solder paste printer, from the solder paste inspection, from the pick and place machine, from the ovens, from the automatic OI inspections. We developed the AI model. Data are being sent to our cloud platform, to our MindSphere. And this AI model being trained with the software application deployed and run on the edge. And there we would be able to predict the quality of our PCBs. It helped us to achieve 30% fewer X-ray tests. It helped us to achieve 100% quality rate and reduce our capital investment by $500,000. We have our software and we have our industrial grade hardware to help our customers to deploy and run those use cases. From the ultra compact, the failless device, what you see on the left side of the screen, this is where we have been running our additive manufacturing use cases. The embedded, this is where we have been running our AGVs, and the high end, when it comes to a real-time quality inspection for high-end images or for training data on-premise, this is where you would require such powerful devices. AI is one of the major breakthrough technology in our century. AI enabled us to trigger tasks that a human being are not able to do before. AI is providing the right information, the right data to the operators, helping him to take the right decision. How do we imagine AI in 2030? I do see smart assistants. Those smart assistants getting data from different sources, from the operational technologies, but also from the informational technology, providing that information to the operators to perform efficiently and take the right decision on the shop floor. I do see AGVs optimizing the routes by themselves within the factories. I do see more and more factories going into autonomous factories. I do see robots with more and more vision embedded system with AI technology, being able to handle different parts, different geometries. So AI will bring a lot of productivity, efficiency, developing our own people to put us at the next level in terms of manufacturing and in terms of industry. And now, before going to Q&A, And when I say go, and not until I say go, I want you all to go to the chat room. I want you all to the chat room, to go into the chat room and write one word, and one word only. So now, look around you and imagine an object. Imagine an object that can be your smartphone, your kitchen appliance, that was produced using artificial intelligence. Ready? Go to the chat and type it.
Thibaut, thank you very much.
Thank you.
Thanks a lot. Thank you very much for your energy and your passion. And I'm not sure if our audience has seen it, but you have also prepared a couple of questions in the poll section of the Swapcard app. So I would ask you all to look at these polls and please give us your answers so we can talk a little about that.
Maybe I want to build on some of the colleagues that are posting some words in the chat. So for example, Dr. Nico Erdmann, he mentioned car, and absolutely here in the welding, in the body shop, in the welding process, we are applying artificial intelligence to improve the quality of the spot welding. Thank you, Dr. Erdmann, for your contribution.
Right. We will. I think we will see how the polls change over the next couple of minutes. I just want to ask you something. You gave us such a broad portfolio of things that are possible, that can be done with your technology, or technology, maybe not from Siemens, but preferably so. I have the feeling that there is something in there for every manufacturer. Do I understand that right? Would you say that it is a fool who manufactures anything and is not looking at the possibilities today?
In fact, we from the digital industry, we are addressing a broad range of verticals. So we are in automotive, we are in food and beverage, we're in electronics, batteries, also within the process industry, in the pharmaceutical, in the chemical industry. So I would say we have the right industrial portfolio to help our clients to take advantage out of AI.
Right. Okay, thank you. Let us look maybe at the answers of the polls now and see if anything surprises you. For instance, nobody voted for batteries being benefited by artificial intelligence. Most people settle on automotive and logistics. Most of the people are not at all using AI solutions on the shop floor yet. I'm not sure if this is like a problem of our audience, or is this something you encounter very often, that people say, very interesting, but we don't do anything at all, and we probably don't have any particular plans at the moment?
Yeah, I mean, absolutely. I mean, actually, if we look to overall customers that we are helping them today, I would say we have around 50% of those customers that are running a proof of concept on the shop floor. Mm-hmm. I would say 30%, they are really forging ahead in terms of implementing and taking advantages. And 20% to 30%, they have no idea. Said, you know what? We know a little bit about AI here and there. How you, Siemens, could help us to really take advantage out of artificial intelligence. And from a customer perspective, we do see, I would say, different buckets. The one who has its own experts on AI, and they are looking for industrial grade solution, software and hardware. The ones who want to partner with us, and the ones who are asking us for machine learning key expert in combination with our Siemens hardware and software portfolio elements.
Right. Apart from the industries that you mentioned now, do you see the possibility that in some completely different fields of industry, suddenly there will be a lot of benefits and gains and we're not thinking about it yet because maybe technology hasn't evolved enough?
Yeah, I mean, absolutely. I mean, I was, for example, at one customer. He was doing is an ice cream manufacturer, and guess what? He wants to apply AI to improve the quality of the images that is on the packaging line. Mm-hmm. So what happened today is that it's a manual activity, right? Is that where we have the operator carrying big boxes of big samples of those ice cream packaging of ice cream, and they are inspecting manually. So we do see in a lot of fields, right? AI could really bring value in there. In the appliance, for the kitchen appliance, right? We also see a lot of, in the consumer world, a lot of AI in there.
Right, thank you. When we look at the question, what keeps companies away from implementing AI on the shop floor, there are top two, maybe, yeah, the third one is also very close. Like the top two reasons is lack of trust regarding AI solutions and insufficient AI expertise for creating and deploying AI models. How do you think these, first of all, do you think these concerns are merited, and how could you work against them?
Absolutely. And first of all, regarding trust, I think my colleague Uli Waltinger, he will have a session around trustworthy AI, and he's gonna talk about this theme very deep in this event. What we do see today is two things. First is lack of trust means how my AI, am I gonna be sure that my AI model would be performing as expected in the shop floor? And here come, I would say, our expertise, our industry know-how, right? Together with our partners, with our clients, because they know their machine, they know their process better than us. And bringing our experts together with them, we would be able to monitor accurately the behavior of the AI model. And in case of drifting, right, of the performance, then we would retrain the model with more and more data to make sure that the model is performing accurately. The first point. Second point is, yes, absolutely right. There is a clear lack of expertise. I was hearing also the colleagues regarding quantum computing. Probably it's not at that scale, but actually there is a lack of expertise specifically in the industry when it comes to machine learning and AI. If you look to companies like Google and Facebook, you can have a lot of these high potential people in there, but in the industry is still a little bit there is still a lot of lack.
Right, thank you. The third biggest hindrance the audience sees is keeping AI solutions updated according to production changes. Frankly, that surprises me. I would not think that it is so hard. What is your take on that? Do you have experience? Is it hard to keep the thing updated, or is it easier than people fear?
Absolutely, and I totally share the feedback from the audience. I mean, assets are the behavior of the assets, right? Is being changed, and here comes technologies and software and hardware being able, let's say, to look at the assets behavior that would impact at the end the whole process, right? And here our solution in terms of monitoring the AI model, right? It's crucial to be able to get closer to our customers and provide additional services to improve the AI model and bring it back on track.
Right. Thank you. Maybe yes, please.
Sorry, I want to build back to the example of the beer, right? You have beer are being produced per batches. So quality, the raw material quality would have massive impact on the overall quality of the beer at the end of line, right? The raw material quality, the meal gap, the malt batch, and so on. So this is also an important element that contributes to the mistrust of the performance of the AI model.
Right. Thank you. Thibaut, maybe just a rule of thumb from your experience. When when companies invest now in solutions like you propose them, when does it pay off, right? So when do they have a return on invest? How long does it take for them to clap themselves on the shoulder and say, well, I've done the right thing?
I would say it depends. It depends from customer to customer, industry to industry. So for some of the customer that I mentioned, or some of the use cases that I highlighted before, we do see a payoff after a period between 6 to 12 months. And here it all depends. For us, our approach is really working together as a partner with our clients. So here we need to both together align on expectation, align on KPI, bringing knowledge from both parties in order to achieve such return.
Right, thank you very much. So let me pat you on the shoulder, Thibaut. Thank you very much for your talk. And I hope you have a lot of success convincing people, but I think with that much energy that you have, it won't be a problem at all. Thank you very much.
Thank you so much. See you hopefully next year on stage. Thanks a lot. Have a good day.
Bye-bye, au revoir. Yesterday, one of our speakers quoted the old saying, never was anyone fired for hiring IBM. And I'm sure never was anyone fired for inviting a speaker from IBM either, at least not this one. She has been fascinated by technology from an early age, and she has a clear focus on artificial intelligence, big data, OpenShift, and open source. And she will tell you where to start with your journey to AI. Why don't we start with a round of applause for the leader of IBM Infrastructure and Ecosystem for Artificial Intelligence, Big Data, and Open Source, Dilek Sezgün. Dilek, great to have you.
Hello.
Welcome.
Speaking out of the cloud. How are you?
I'm great. I hope you're great too. And we can see you, we can hear you perfectly. So take it away, please.
Okay, great. Thank you. So, as already mentioned, I'm the AI, Big Data, and Open Source leader for systems and ecosystem. And I would like to take you today to a journey to AI and how you could start and implement AI for your company. Sometimes when I have discussions with companies on how they could start, they are telling me I do not have any clue, or they are saying, for me, AI is something like a black box and rabbits coming out of it. But of course, this is not. Yeah, AI isn't magic. AI you could use in everywhere, and the base of everything is data. It's just simple like this. And data is the fuel for digital transformation. You could, with AI, unlock the value of your data, and hybrid cloud is the data platform for everything and could support you in going into this transformation. By the way, $16 trillion to the global economy will be AI participating until 2030. So AI is really key for everybody of us, and it's not magic. It is only just a journey for everybody of us. And I will take you into this journey now with me together. And one part of this I would like to show you is that only 15% the companies are getting out of their data, and 80% is unlocked. And because of this locking, you are sitting on a really big base of data and you couldn't use it. And this is really the part where you need to think about AI, because it could help you to get more insights into this data. When we are looking at the companies, and most companies, they are sitting in the 64% you are seeing in the white bubble in the middle here in my presentation. The most companies are thinking about cost reduction, about modernization, but there is a far way to go with insight-driven self-service analytics and new business models with like AI. To come there is needed a lot of new models and new things, and especially now during COVID-19, a lot of companies need to focus on how they could get more out of their data and how they could start this really unique journey. So the question for me is, where are you in your journey in that case? Are you sitting in the 64%? Are you in the beginning? Or did you just started already with your business models? We as IBM and the Data Foundation is, as we have talked, is the organizing of everything. And we are saying to this data organization, it's the information architecture for AI. So you need to think first before you are starting about your data silos, where they are sitting, are they in the cloud, are they on an infrastructure, and how you could handle them. What would be a way to automate and govern your data and your AI lifecycle, how you could operationalize this ones. And a really big thing on this is, of course, ethical aspects, trust and transparency in these AI models, how you could extract them. And in all of this, do you have a login or do you have an agility? Because really important in everything when you are setting it up, how you could get it open with some open source frameworks, something maybe in the cloud, some parts in the infrastructure, because a lot of companies do not start from the scratch. They have already infrastructure. They have maybe started already a little bit in a cloud and have built their some models. And now they are needing to change. They need to think about a change on how do they get everything together? How could I start it with bringing different units together? You have, for example, the data centers, or you have then an AI team. Maybe you have only one person. How could I get all these different areas together? And you have sometimes some business units who are saying, I have this and this problems. And you could maybe think about some AI who could change these problems in that case. When we as AI speak about AI, we are speaking about an AI letter. So but the beginning of everything is this letter when you have thought about the information infrastructure. So you collect data, you organize the data, you analyze the data, and you infuse the data. All to modernize the things you are having in the AI and in your hybrid cloud world. So, and if you are starting this AI letter, you have a lot of things you need to think about. And we as IBM have a couple of offerings where we are putting exactly for this AI letter everything together. The base is always where you are already starting. You have a data center, you have maybe some infrastructure. It could be from IBM, it could be also from other vendors. You have any cloud, maybe on Azure, on AWS, maybe also on IBM Cloud. So there are different bases where you're maybe starting. The base for everything at IBM is Red Hat OpenShift. You know, probably we have bought Red Hat, and with that, we have figured out that Red Hat OpenShift is the base and could be a great part for everything when you are going into AI. One offering in that Red Hat OpenShift, and where Red Hat OpenShift is also included, is Cloud Pak for Data. And Cloud Pak for Data has a couple of more functions than only what OpenShift has. But the base, and this is why we decided for OpenShift, is it's really open. You could switch in different clouds with different infrastructures, and you could use everything. And you have a container-based model. What is really important in that area, because sometimes I'm saying when you have infrastructure, it's like you have virtualization. This is sometimes like a new normal car. But if you want to have an electronic car, then you need containers. And it's a little bit the same. It's a new world. And with these containers, Red Hat OpenShift is a possibility, especially in changing also between the clouds and using that what you are already having. And Cloud Pak for Data is something where you have a couple of more possibilities, especially in that AI journey. On the top of this, we as IBM offering data open governance Infosphere in the DB2 family. But the real important parts are the ones who are from data scientists. And data scientists in their life cycle, when they are doing something, they are preparing their data, they are building with their data, they are running the data, and they are managing their data. So these tools, what you are seeing here, are really for the data scientists to work with the AI and the algorithms here in that case. On top of this, we have, of course, a couple of pre-built use cases and Watson applications, so that you do not need to begin everything from the scratch. So you have the possibility that you have already some services around it, or could get from IBM people who are doing things for you. And I think a lot of you maybe have heard it already during COVID-19, especially the chats are most important part, where we have also a focus on it to have chatbots in that area. And of course, we have in all of this business and technical services. And what we are starting, or when we are starting, the most thing what we are doing is using an IBM Garage. What is IBM Garage? It's like a little bit a startup concept, yeah? A lot of people are coming together and bringing their know-how together. It's depending also from your know-how. If you have, for example, use cases already on which you are working because you are thinking it could be a good one, we could work with you on this one in the detail. Or if you do not have any ideas of a use case, we are coming with use case and explaining what other market players are doing in that area, what you could do for your industry. The aim of everything is, of course, to give you an advantage in that area to settle up in AI. And this brings me also already to the call to action for your company. I would tell you not to start with an AI strategy. Yeah, a lot of, when I'm discussing with customers, a lot of customers are saying, I need an AI strategy. When I have this AI strategy, I could start with projects. Often I say, no, please start with projects, because if you are starting with projects, you have the possibility to have a look on what is effective for your industry and for your company. What are things what will be interesting for your company? It could be very simple things, yeah, like matching offerings with some receipts. It could be much more. And you have in your business units, when you're asking them, a lot of cases where you could bring a lot of value to them because it's stupid work. It's simple work where you could use AI and where AI could make your life much more better. And this is why we are saying start with some projects, especially with the ladder of AI. So collect your data and organize it, analyze it, and infuse it. With this ladder of AI, you could start your first projects, you could start your first use cases, and could get some advantages. And you are knowing then better what is the best for your company. You could build an in-house AI team. Sometimes and often it's not only a complete team, sometimes it's only one person. Please make aware yourself of you have always a data center team. Yeah, this should be maybe a separate team who is thinking about what could be useful for for the business units, and it should be one team who is helping and supporting the business units, but interacting with the data center team to bring it together. If you do not have the right skills, or the people do not have the right skills, provide broad AI trainings. And there are a couple of ones. So I'm also in social media. Sometimes I'm linking them or telling here, these are the best ones. There are a lot of Coursera courses. There are a lot of trainings outside, and even on YouTube, you find a lot of things. So make yourself aware about which possibilities you have, and then start your strategy, because then you are knowing what is important for your company. What are the things that could help your company in that area? And then finally develop an internal and external communication that you are started this use case. Of course, it could be for your own customers, for example. It could be a great use case, and we have a lot of from this one that customers are coming to us and we are developing a use case for their end customers, for example. So then you need, of course, external communications that the other customers are aware about that what you are having on possibilities. As I said, all of the base of this is our AI letter, and I will be very happy to explain it more, you could imagine that there are a lot of more possibilities to show you what are in the different bullets of collect, organize, analyze, and infuse. And of course, there are a lot of offerings behind it. But this will be too much for the 20 minutes we are having here. So you could reach out to me to have this discussion on that area. I'm in LinkedIn, and it will be a pleasure to have the discussion. And I had already in the morning today at 8 o'clock a discussion. It was nearly about the same subject. So I think it makes really sense to have this collaboration and the networking in that area. So, but as key takeaway from my session, I want to tell you again, data fuels digital transformation. So data is the key. And we could unlock this data via AI. The base for this is hybrid cloud, so a mixture of on-premise and cloud, and we could support you in that case. But in the most of the thing, and this is the most important one, is AI is not magic, it's a journey. It's not a rabbit I'm taking out. It's very simple, and you could start with it. And we as IBM would be very happy to help you and support you with that. And of course, because we are saying we have an industry leadership in that area and had already a lot of industry awards in that area. And we are open. This is one of the most important things for me, and I like this very much. It's a lot of open source, and that we have bought Red Hat and OpenShift and take this as a part of AI, our AI story, shows that we are really meaning it, that this is really important for us, and that you could use open source in that area. So that's it from my side. I thank you. So I had a little bit time over, but I think there is also a poll, as I'm knowing it right, yeah?
Yes, there is. We'd ask everybody to answer. Did you already start your journey to AI? Yes, no? That's interesting that there is a third option. It says not yet, but I plan to start with it ASAP. Very interesting. So that's a double no, but one no is with a little excuse. Dilek, thank you very much. Let's talk a little about maybe two things that interest me. Of course, you were very clear, and everyone knows and agrees that you need data, right, to fuel your AI endeavors. Absolutely. But I think there are many companies who either don't know what kind of data they have, or they don't know or are afraid that the quality of the data is not enough. How do you work with people like that? Do they even approach you and say, let's talk about the data, or do they probably never call?
Yes, of course, they are approaching also in that area.
Right.
And you can imagine we have for everything a solution and an offering, yeah. And we are very, we are knowing also that 80% of everything in the AI, especially the data preparation, is taking a lot of time. And this is something where you have a lot of offerings and possibilities. We have, for example, but I do not want to go in detail, but we have, for example, for visual recognition, a tool where you could put 5 pictures in, and you get automatically some other pictures helping you to get more data. Yeah, when you do not have, for example, enough pictures. But of course, we have also offerings where you could organize your data. Yeah, this is the base of the AI ladder.
Right. I'm not sure if it's the case in other countries too, but I know that at least in Germany, there's also, especially with SMEs, still a large fear of cloud applications and using cloud services. And you also mentioned that a hybrid cloud is very important to the goals that people should set for themselves. How do you deal with cloud fear? Do you experience that too?
Yeah, it depends, yeah. So for us, is the base, of course, Red Hat OpenShift as cloud, yeah.
Right.
And we use it in everywhere in that case, yeah. But I'm not sure what you are meaning with fear.
All right. Looking at the poll, nobody has not started or is not willing to start soon. So good for you. You're obviously underway in the right field. What would you say if people just blankly ask you, is AI for everyone? We heard earlier that it's probably not for everyone, at least not with respect to building a whole AI company from the current situation, for instance. But would you say everybody will have to look at AI sometime in the near future?
Yeah, even if there's somebody else who's saying it's not for everyone, there is also a course in Coursera is saying AI for everywhere. I'm very keen that my daughter, she is 7 years old, will maybe drive electric cars and they have an AI automatism in it. So there will be a lot of things in the near future where we are maybe not thinking about it. Yeah. So as I'm started and I studied, I had my first smartphone, and everybody had a look on me and said, "Oh, why do you have a smartphone?" Yeah, we couldn't imagine this. And I think in 10 or 20 years, we will see things where we are not thinking about yet that we will have this kind of things. And it will help us really to get an incremental, a really great future if we are not afraid about it. And this is something what I'm liking in IBM the most. We are thinking about how we could use it ethically correct, the AI, because this is a real important thing. It starts all with ethics. If we are not thinking about it, and we are not thinking about the ethics, then we will have, of course, always the people who are afraid to go this way along with us.
Right. Thank you very much. Those were my questions. Thank you for sharing your insights and perspective with us. Dilek Sezgin, everyone. Thank you.
Thank you. Have a nice day. Reach out to me.
Thank you. You too. Bye-bye. And that means we have a slightly early lunch break. We will continue at 14:30 Central European Time, and then we will talk about trustworthy AI for the physical world. See you then. All right, that was just an audio glitch. So enjoy your break.
I can't hear yet, right? Okay, no worries.
All right. So, as I understood it, maybe Uli is already there, but he didn't hear me because my mic wasn't working. So,
Yeah,
for
here we go.
everybody that just tuned in and is not in this room, I'll introduce our speaker again, of course. He's deeply interested in the foundations of computational intelligence, and he's a zealot when it comes to an open and interdisciplinary research and innovation culture. He has more than 40 publications and more than 100 talks under his belt. He's the technology head of the Siemens Artificial Intelligence Lab in Munich that he founded with his team in 2017. And I hope that he hears me and is here, Uli Waltinger.
Thanks very much. Yes, I can hear you. Can you hear me okay?
Yes, I can hear you too. I see a slide, and I hope that's what we're supposed to see right now.
Exactly. So first of all, congratulations. You know, this team behind the scene and front of the scene, you did an amazing job. I super enjoyed the Rise of AI event. Amazing event. Thanks very much. And I'm more than honored, folks out there, to talk to you a bit on trustworthy AI in the physical world, actually. My name is Uli Waltinger, and I present work here from a lot of teams actually out there. Actually working for one of the oldest startups, I guess, in Berlin, isn't it, right? So Siemens. And if we're talking about AI and if we're talking about industrial AI, I guess we are now at the point where, you know, we need to put industrial AI in operation, right? Towards a focus and towards a pervasive use. And if you look in a large corporation, such as I'm devoted to work for, right? You know, as broad the applications are, from energy management, you know, building grid controllers, from putting more autonomy in mobility streams, from what it means actually, you know, bridging the world between simulation and machine learning, what it means actually control optimization, obviously, or, you know, bringing and shipping additive manufacturing to the next level, you know, or robotic systems that, you know, can be more adaptive, more independent to new demands. But obviously also in the shop floor area, right? More throughput, more availability, you know, all these kinds of tracks. And we along the line of these use cases, you know, which need to provide some value, right? We can somehow, you know, discriminate between two different application areas. The one is the natural reflex, I guess, self-existence, what we call it. That means like we need to increase the level of machine autonomy. That means, you know, we want to have a depth and a breadth of value and more adaptive, more efficient, right? A cost saving, these kinds of adaptive technologies, you know, on the horizons. At the second is, I guess, the natural reflex as well, right? It's assistance, right? We call that digital companions. So embodying some kinds of capabilities along the line of machine intelligence in certain decision support systems. So autonomy and assistance maybe the leading principles that we see in the industrial area. Second, obviously, you know, our job, industrial AI, means, you know, we connect the physical and the virtual world. And this is, I guess, the interesting part in there, right? We work with partners which have a whole, you know, install base of industrial assets coming from turbines, coming from trains, coming from compressors, coming from wind turbines, obviously, as well. And the challenge is, you know, how do we connect this asset together, and how do we make sure that the virtual world and the physical world are bridging together? And obviously, data does play a role, right? We are nonetheless, obviously, in a data-driven society somehow, in a, let's say, supervised data-driven society, isn't it, right? But it's also clear that, you know, we will not have the time to actually label all the data in our world that is accessible or not yet accessible, right? So we will move towards what we call the system-driven, you know, society more. So relying more on self-supervision, relying more on that not every data is being sensed automatically. At the same time, we rely heavily, especially in industrial flavors, on expertise, on domain know-how, and so human-driven systems. And I guess, both worlds bring together the implicit and hybrid knowledge, but also the aspects moving further away from the purely supervised, let's say, weak machine learning paradigms. And what helps here, and I think I loved yesterday actually the call, like ecosystem beats, ecosystem beats a strategy. Love that. And I think the ecosystem of applied research is the core and the key actually how to accelerate further, right? Because applied research is for me the impact-driven research. Not only advancing state of the art, obviously, right, but actually applying and challenging real-world challenges and helping enabling to transform these ideas into innovations. And from a geeky perspective, obviously we can say in research we fix the data and we tune the model somehow, right? We advance knowledge, we find good architectures. Once we identified a great architecture, a great model, we comes to application. And in application, it might be vice versa, right? We fix the model and tune the data. So we apply different data and different applications to a given, computer vision architecture, predictive maintenance architecture, anomaly detection, and so on. And the business impact is driving and defining actually these questions, these research questions applied AI. And it ain't that easy. What's a different impact? What does provide value? We are in current stage far further that is machine learning providing any value? It's a no-brainer, right? It's the questions, what is actually, and I love the notion of the minimal justifiable improvement. What is the right problem to tackle? And this is how you're actually starting, right? From where, why to how to what. What is the right problem? What are the right constraints? What number needs to pop up in which dashboard, in which Excel sheet, in which decision-making application that gets you your boni? This is the problem. This is something where does it actually been integrated? So identifying, what is good enough? Is it 1%? Is it 2%, right? What are the key drivers of the performance, right? This is such an essential part in identifying it in first place. Don't worry about data in the first place. Worry about what is the right problem. Then the second step is how, in which business process it needs to be integrated, right? And once you have that, then you can talk, okay, what do we need to do in order to enable that, right? So start from the deployed object, and work backwards, not the other way around. Otherwise, you are ending up in the proof, right? In the proof of concept cycle you don't want to have. Second, obviously, data, data readiness. If I talk to partners, all around the corporates, right, they all suffer data. And I mean, with data readiness, for sure, right? It's not we have some data in some CRP, ERP, or asset, right? Data readiness means you are mature enough in access, in delivering, in sharing, and utilizing your data, right? And there's a whole spectrum, actually, what can be considered there. Talk to us or talk to me if you, think about, hey, how do we address data readiness in your corporation? And third, obviously, is about research questions, isn't it, right? And really real-world challenges, drive the applied research direction actually have. And these are, sometimes the blueprints that we use it throughout, I don't know, the last 3 years, and I guess we'll use it also for the next 3 years, right? What's some typical questions we have, and we ask for the, applied research ecosystems and the partners out there is, how do we do with data efficient learning, right? Not every data asset, is being connected, is available, right? What's the role of active learning? What's the role of simulation? How do we do prior knowledge induction? Second, about companion, what is multimodal interaction? What is if we deploy very fastly end to end and then continuously increase the accuracy and the level together with the partners? Third pillar, obviously, explainability is something which, especially in physical domains and physical worlds, is quite important. But also about, the capabilities of, for instance, federated learning, right? Can we distribute? Can we learn from a distributed asset base? Nice. And fourth, obviously, and I think this will be the next 2 years of, trustworthy predictions and reliable operations. So we need to think about safety architectures, about robustness, but also about what it means, industrial trustify grade solutions. So trust seems to be a bit of a role, right? Right. So in simple words, right, we need to talk about industrial grade trustworthy solutions, to be honest, right? Because obviously you have, the AI capabilities, and I love the accessibility of current AI technology, right? Starting a TensorFlow or PyTorch, getting the notebook up and running, easy, nice, done in maybe a couple of hours, right, for most of the stuff. But what it means actually providing value end to end is a bit of a different twist, right? Because in order to solve the right things, it requires some kind of understanding, in what kind of business integration needs to be done. The second is that if it changes the business process, right, it needs to be deployed in a productive system. And this requires trust. If a system automatically triggers some kind of changes in the business process. And obviously, since we don't want to have this one-on-one and we have a continuous loop actually in deploying it, it requires automation on the machine learning capabilities. And this brings us together that industrial grade trustworthy solutions are a bit more than launching a Python Jupyter notebook. Especially in this industrial AI, the challenge is that we need to make from both worlds actually some benefits. The implicit data, obviously data-driven, insight, but also the explicit stuff, domain know-how being integrated, because the data you seen in the industrial layer, it's not easy to label them, right? It may be cats and dogs for the outer world, but sensor, is it an outlier, is it an anomaly, right? A lot of data is not yet sensed, so brownfield environments, the cope, and there's a lot of domain know-how, because, we need to have some sense of feeling, how is actually moving, how is the physical control, how is the actor actually been moving? So that brings a bit of some challenges in out there, right? And we all know from our daily, I guess, consumer tech experience, machine learning can be truly a fragile beast, right? Obviously, in certain aspects. And for most of the aspects, if we interface on a daily basis with machine learning technology, we don't necessarily expect 100% performance. It's okay if it's rank 2, or if you bring, well, potentially not a rat bell pepper, to your wife because somebody recommended in the store that, this is a good replacement for that, right? It's a bit of fragile, right? And this, I guess, respect the past, but, invent the future. Correlation is not causation, right? Causality is for sure reasons, the last 2 years, one of the key pillars of research, right, in the machine learning departments, right? And I guess it summarizes also like that, Nigel. I love that, because this is something how it feels in many cases, right? French is a crazy and a beautiful language. It's spelled different than you speak it, right? The sound of the language is magnificent, but it's somehow a bit of a difference. But still, machine learning, it looks like that, right? You could just, memorizing everything, and that's still, cracking up on the French Scrabble Championship without speaking actually any French, isn't it? And for business, what does it actually mean for us? We demand scalability solutions. That means for sure you can start the POC in a certain factory, right? You can train a model on a certain and apply it in a certain applications. But we actually demand scalable solutions. That means we need to rely on that if we train certain solutions, we can transfer them across different deployments. And that means we need to cope with environmental discrepancies, but also deployment discrepancies, different cameras, different angles, different data, different setup, and this requires quite some push towards robustness and quite some push towards what is called domain generalization. And this is where we also start together with university and with the partners, but also in our own turf, right? It's how do we make sure that, we advance the field of trustworthy predictions, right? If you use softmax, neural network, so you have most of the layers, right? At the end, you use the softmax layers for get some distribution. If you put that out of the main, it does crazy things, guys, right? Isn't it? So how do we make sure that we, get some feedback, right, on the robustness of the applications if you move the machine learning model from one to the other? At the same time, obviously, as we build up this large nets, right, on certain capabilities, right, we need to deploy it in the physical world somewhere on the edge level. And the edge may be a sparse resource edge, right? A sparse resource device, which you not can consume like, megabytes to inference. Nevertheless, right, we need to provide reliable models with a low memory footprint, for years to run. It's also a different question, right? At the same time, obviously, how do we approach that, we're not seeing this hundred thousands of events that we have in the consumer space on the ad rate, but how do we actually use a meta-learning mechanism in order to come with a few gradient steps, few shot analysis, to a sufficient detection algorithms, right? This is all typical problems that arise in the industrial domain, which we approach and which we also share with the research and academia partners out there. Next level is obviously active learning. Active learning helps us primarily also, obviously, getting feedback done. That means from annotation, obviously, going fast end to end, from data to actually, actuation, but allowing the experts and the partners to seeing and listening, but also injecting their own knowledge. This is an anomaly. This is, just forget about it. This is interest. This is not seen yet, right? And active learning and annotation gives us here, two sides: the domain know-how capturing process, as well as, enforcing a bit more explainability. And I guess, and we have a lot, heard yesterday already, right, from Hans and so on, about knowledge graphs, right? Yeah, for sure, we are in a huge hype of data management again, right? Remember the big data hype? And yes, knowledge graphs are an interesting and very, very, great and easy to go actually way in digitizing these kinds of domain structures, digitizing information, bridging silos, but it allows us also, to somehow, enter the phase of graph-based machine learning, which is also very nice because it has also the explainability aspects in there, so giving more explainability, and it allows to inject external data to our internal data source. So that's quite interesting aspects. But nevertheless, once you have the methodologies and you worked with your partners in there, solving certain kinds of pieces, and then it's shipping it, in operation, right? And in operation is one of the, paradigms is, tightly integrated, but loosely coupled. Because open source, yes, plays a vital role, right, in industrial AI, also on the shop floor level or in corporate level. But there will be also always proprietary software you need to dig in. And we don't want to recharge again with this patching of open source, patches that, are adopted somehow as we, the best practice learned from obviously the, big data hype, right? So it's the main idea is highly integrated but loosely coupled. There will be always on-prem stuff going on, right? And that brings actually a new horizon, which I would say is super hard and currently being, put together. It's the notion of, that there is an AI ops, the industrial AI ops twin actually, as a few of deployment and tested in virtual environments, but then also to target to the device of production. We applied similar aspects in the simulation domain, process simulation, product simulation, having a virtual representation before it's actually being constructed in some kind of plants. And I think we need exactly these kinds of twin in an AI ops direction as well. We need to apply certain machine learning capabilities in a simulated, in a virtual environment before we go actually on the target devices. Given this here, which we call the ops twin. And there's many reasons, right, why somehow end-to-end and the POCs, and we had this morning quite feedback already, right, why it's in. I think it's, one of the aspects is, most of the companies I see, they design proof of concepts. Don't go for proof of concept, right? I think we are over that stage, right? Design for the deployment, design the minimal justifiable improvement, design for that, right? Second, obviously, team structures, right? Every company has this, our working students does that. He's the AI ops, he's the business analyst, he's the software engineer, he's, this one-trick pony, right? Thing. Don't do it, right? Bring people together. Ops needs different expertise, from data science to operationalize, from business to customer, right? It needs different capabilities to make use of your team that you mostly have, or use the partners out there. A third one is obviously, technology. Technology, we need best practices, obviously, but we need also to design for repeat certain aspects. It should be not the one thing, we did it once, but it's always, focus on, is that repeatable in the process? And last but not least, I think kudos to Diego here, right? He said, like, machine learning project without an executive sponsors, never see the light, And I think that's some truly thing. A lot of people bring that up and say, like, go for the PSC, but if you don't have a corporate sponsoring or the decision maker in the aligned with his values, interests, right? What is we need to do in order that you get your money, right? This brings value statements sometimes on the end. This helps obviously as well. Shifting closer to end-to-end integration. And last but not least, right? I think we are talking a lot of data, and I've seen the first pitches already coming on with we have this magnificent tool of this unbiased button. What the heck? Right? There is no unbiased buttons from my perspective, right? We deal with bias and data. We deal with data, and data is dirty and biased as it is, right? We can have a closer look, we can monitor, but it will be always somehow flawed and somehow biased by certain aspects. And this brings us actually to an aspect that's, that we need to reflect on the actually applications that we built that are fueled by certain technologies, fueled by certain data, right? Which obviously comes with a lot of capabilities that we have, right? Like visual monitoring allows some transparency, it allows some security, something pretty good, right? Or, process efficiency, or, cost and failure reductions in certain capabilities. But sometimes these use cases bring also some accompanied by some kind of risks, right? Like, misuse or bias or, safety, or, intransparencies or black boxes, right? But there are certain mitigation scenarios one, and as you as a decision maker can take, right? Whether it's awareness, whether it's training, whether it's technology, whether it's co-creation, maybe sometimes also regulations, right? In helping to mitigate them. But I think C-level needs some kind of blueprints and playbook, and in order not only seeing capabilities, but also not only seeing risks, but actually, having a playbook of awareness, how to approach certain use cases, enabling and mitigating risks. And this brings me actually to the key takeaways, I guess, right? And the famous three, right? AI models, obviously, easy to prototype. It's super, super nice, the accessibility of machine learning methodology. I love it, right? But it's a different if you maintain it in production, but you go for end-to-end. This is, even though you're not having the highest accuracy, continuous improvement needs to be targeted, but it needs to go end-to-end, otherwise you don't do it. Second, I'm a geek. I love tech. I love exploring technology, but favor for business-driven innovation. What is the minimum justifiable, improvements you want to have? And define what you don't do, right? Especially in large corporates, right? There is a tendency of not defining what you don't do, because if you know exactly what you don't do, you can leverage this awesome, ecosystem which has the speed and scale that you actually need. And third pillar, is trustworthiness, explainability, robustness, but also security, will be the imperative in industrial AI, right? And I'd love to engage with you further. Ping me on the books or on the email or on LinkedIn. More than happy to engage with you together. Thanks very much.
Uli, thank you so much. I think I have a couple of questions for you already, although we only have a couple of minutes time for them. But I was quite curious. You dared to say there is no unbiased data, right? And I think that made many people quite nervous, I think, because they're striving for unbiased data. Maybe some people in their companies told us, no, of course we can remove bias from data. On the other hand, you were talking about explainability. And I think there are some people who would say there is also not a completely explainable AI. What do you say to that?
Yeah, let's tackle bias first. So, bias is there's always bias. I think there's a great tooling in there, which helps sheds a light. How is your distribution of the data? Yeah, How is the coverage? Is it only dogs, or are there some random cats in there as well, right? Stuff like that.
Right.
Or what kind of features are being used, right? Is gender included, right? Or is gender explicitly excluded, right? But it also goes in the direction even so if you have in the training material, in your training set of smart applications being said like, okay, I think it's a bit of a representative what we actually target, then it hits the real world and different data comes in there, right? And so I think, if you talk about reflecting on the bias or on the fragility of machine learning modules, it's also clear that it doesn't stop with just the training, but it's a continuous, and that's why we call it, the AI Ops Twin. It's a continuous monitoring what's going on here, and to make sure, we're aware of the implications that it can have. Second aspect, explainability, right? And yeah, for sure, there was quite some hip, and they're like, neural networks are these black boxes, and I don't know, get what it's in there and stuff like that. And that's why we don't use them. There are tools and technologies around there, and there's certain, obviously, pieces, where a transparency, and this is, I guess, what most demands in terms of explainability. I totally agree with explainability, but transparency, right? I have currently no clue what my wife is doing. I surely trust it. I trust her. We will do okay. I don't have transparency about what she's currently doing. But in certain pieces, right, we need to invest and say, like, why certain decisions are being made. And there are different versions and different, actually, instruments. We can enforce a bit more explainable features, what it has learned, how it behaves post-mortem, how it was trained, how it's applied. But also maybe, combining different explainable and non-explainable models and having a bit more closer. So I don't see it as, it's if you're using neural networks, everything is black box. It ain't that. So there are measures to, work together.
Right. Thank you. You were making a strong case for making business-driven AI decisions and not tech-driven AI decisions. But at the same time, we have been talking a lot about the proof of concept graveyard, right? I presume that probably the decisions to do a proof of concept are all tech-driven, right? People want to experiment, want to see if anything goes, and because there is no business decisions driving it, then the whole thing stops. But is it really a good thing to demand business-driven decisions? Because maybe people will just stop developing AI solutions then because they don't see the business case yet. Maybe they're not confident enough that they will have a successful end-to-end integration. What do you think?
Yeah, but I still go for that. So obviously, lessons learned out of the big data hype. I don't know. You remember that? we had some cases there, right? Some lessons gone there. So the natural reflex of management was calculate me the business case. If it's not making a double-digit impact, right? We ain't gonna go there. Right? And that killed everything, right? And now they actually put out and say like, yeah, here's toy, go it, right? But ain't gonna have a business impact. We need to understand from the mindset, right? This is not a totally magical tool, but if you're thinking on the AI first, it has a pervasive use in the quantity of applications, right? Will bring the entire business together. And that's why, I still urge C-level, you need to understand this is not a holy grail, but any different process and any given product, there will be not AI in there, right? So you want to start now or you want to start later? This is the only question, right? And if we start now, let's talk about the minimum justifiable improvement you want to make. What does a certain application need to move that you get your bone in, right? This is the question to ask. And then you work backwards. And I think that helps. You design for production, not for POC. The time of we're testing out, it's a nice, let's do a bit ImageNet competition on certain kind of devices is over. Let's do business.
Then I can only say thank you very much, Uli. And I hope that you will be able to convince many people that the time is now. Thank you.
Thanks very much. Cheers.
Thank you. Bye-bye. Our next speaker is an enterprise transformation leader by means of high-performance computing, disrupted deep learning, and emerging technologies. He's responsible for performance, availability, and scalability of cognitive systems infrastructure that has created IBM's distributed deep learning reference architecture, and he will talk about two of the most important topics of our century, AI and climate change. Please welcome the senior AI architect and inventor at IBM Systems Hardware Europe and member of the IBM Academy of Technology, Florin Manaida. Hello, Florin. Great to have you.
Hello, thank you very much, and nice meeting you in this way.
Great.
Right. So I will start from a single challenge we had it with our Satori, which was actually the largest to the date AI cluster at MIT. When we delivered, and here there are two of the leaders there. One of them is John Cohn, our fellow. Was the question is how much energy this system will consume, and we had a goal as well to have it on Green 500, which is number 7 at this point in the June 2020 list. That moment it was on the 4th place. But the energy consumption is one of the most important when you look on the operational side. For example, if you look to the GPT-3, there is a calculation out there that if you want to train it for 1 year, you have to spend almost $4 million for a cloud instance. So try to imagine how much energy you can kind of consume there. So one of the questions we had during the last year in December was how much the data scientists they will consume by training several networks. What can we do to inform them in a way to be aware of the energy that they consume, and obviously the impact that those trainings they will have. And second is how we can empower those data scientists and researchers with easy to use tools that can really tell them, you have consumed so much energy, or you have your training has produced so much CO2. So we were just looking around on the operational side, how they actually interact with the workload manager in that system. That was kind of in two ways, either via Python scripts or via job submission templates via web interface. But we wanted to give them the ability to have an energy report. So not only that they will get the output of their training job, but as well to have the energy report to make them aware. That was our first goal. And obviously the second goal is to actually switch from the resource utilization. So right now people, they are entitled to run a particular number of hours typically in a year. But what if you switch that from running hours to kind of CO2e values? So people, they will be forced to actually rethink the way they do the computation, they create those algorithms. So what we have done, actually, I run all those benchmarks there. There are more than what I will show today here, is to take a single pod from Satori, a cluster, and scale across all those systems in a pod. We're using the NVIDIA V100 GPUs we have there, from 4 GPUs, 8, you see here, 16, 32, and 64. And just to take the average instant power consumption for, let's say, 1,000 of iteration. And this is for the ResNet 50, this chart here. And as you can see, as the power consumption is growing, the number of images per second is growing while you are training, obviously, and the more power you are using and the more CO2 most probably you're going to generate. But we didn't have the numbers. So we knew that, okay, this is happening. We didn't have exactly some measurements and to come up with as well what we can do to improve those numbers. So we started with this pod consisting in IBM AC922 systems, air-cooled systems. This is the actually in top 500, actually the single air-cooled system which is present there to the date. We had 1 terabyte of memory there. We used large model support, so pretty decent pods, and Satori is compromising in many pods like this. For example, here what you can see is the training for 1 hour using ResNet 50. What we can notice is that when you grow from 8 AC922s that's to 16 AC922s, the power consumption is really growing much more than expected. And the reason is mostly because you have more data exchange in the network, and then you have as well a longer time to feed those systems from the storage perspective. And this is, we didn't expect, we didn't know it, but we found out by doing the measurements for some training jobs. And here we use TensorFlow and ImageNet, for example. When you do 20 epochs, for example, so that is roughly 1 day, the power consumption will grow. So this is around 500 kilowatts hour for a single pod. Now try to extrapolate this. If you have 8 pods and you have researchers using all of them, how much you'll consume. And this is not only related to ResNet, but you can have other kind of models that can be more energy hungry, and therefore they will elaborate and they will consume more energy at the whole system. Another thing that we see is the emission estimate for 1 training day. So one of the things was, okay, how much you're going to generate in a day as the values. And here is just an estimation for European Union average CO2e levels per kilogram. As you can see, you can really go to 160 kilograms, or close to 160, so 140 kilograms CO2es per day from a single pod. And that's why people, they tend right now, and they actually spend a lot of money training in, for example, in Iceland, where they have these renewable energies and so on, so it can really change the balance. But those levels, they are different in the European Union, for example, country by country. So that's interesting to see that based on from where you get your energy, based on the country values, you can have different values. So we expect that this as well can be a play in further on how the European Union will actually allocate the money for those centers for training those models in the future to be more green efficient and really try to reduce the footprint of the CO2 levels. Now down to a single system, if you go, this is an AC922 power consumption. We see here that initially when you start the training, you get around 600 watts consumption. That is, when you send the data to the system, you initialize all the things there, the libraries and so on and so forth, and then the training is starting. And then this is across 1,000 of iteration, by the way, and then it's stabilized around 1,600 watts, and that goes until this training finish, or the number of iteration that you requested have been consumed. And interesting, when you go to 2 systems, that time for preparing to start the training job, and here we used Horvod, for example, it's becoming a little bit longer, but the power consumption across 2 systems is steady. So that means 8 V100 GPUs with 32 gigabytes of HBM2. And when you go to, let's say, 4 systems, so more than double, that time spending in starting the job is becoming longer. So this is something we have seen, And we didn't expect this, obviously. So that means that you need to rethink, what's going on behind the scene and what can be done to really, shorten this waiting time, where you keep those nodes busy, and therefore other people, they will wait for you to finish your jobs across a pod or across a whole cluster, depending how much you run and how much data do you have. Across 8 systems, that will be, as you can see here, longer, but the power consumption, it tends to grow. So it's not growing linearly, it's growing a little bit more. And this is most likely because of the connectivity in between the systems and the data exchange between all those systems across the network. So then you have an extra power consumption there, and obviously longer waiting times. When you go to 16 systems, which is a full rack, a pod on Satori, this grows, the power consumption is growing as well. So that being said, our question was, okay, what can be done and where we can look more to really understand and find ways to recommend researchers to really change something in the way they consume those systems, and they consume the power, and the CO2e levels are going up. Another model that we took, which is a little bit more complex than ResNet 50, is RetinaNet for 6,000 iteration, a single class. As you can see here, the power consumption is a bit higher. So we can say that the total training time in our case was 12 hours. In this case, we generated 1.14 kilowatts hour. And as an average, that was equal to 4 kilograms CO2e. And again, presenting those figures and looking on those numbers is always good to say, well, if you put more classes, so you train a neural network to detect more classes, or to be trained on more classes, the question is, you're going to generate more CO2e level or not? And the answer is yes. We have found that by moving to a single class, 10 classes, and so on and so forth. And this is because you put more data, you put more effort in training the network, and so on. So again, if you train something, the question is, can you retrain something that was prior training on another data set or another class? To reduce the CO2e levels. To put this in a perspective, a mount perspective, for example, training the Big GAN, which is highly utilized at MIT and IBM Lab across 8 AC922s, is roughly an offset per month to 20 trees. 20 trees. So that's something that maybe we are not aware, but you need to offset this into something. And I think the best is to consider the trees when you speak about the CO2. So what can be done? Because when you scale across multiple systems, multiple pods, and so on, you actually increase the CO2 levels, and not always the people training, they are aware of all those implications. So their job is to finish a project, to write a research paper, to find a new algorithm, but they have to be aware of these climate changes and all the issues which are happening. I have here a couple of conclusions that I want to finish here. So for example, a single system training with ResNet for a single day can generate up to 3 household CO2 levels during a day. So that is another thing that you can consider when you train, that the energy consumed by my training is so much higher than a household, and therefore I have to understand all those implications. Another thing that has to be mentioned here is what we can do to make those neural networks efficient, because the way they are written right now, majority of them, they're very inefficient. and they obviously you consume more computing power, right? So thousands of CUDA cores in our case you use. How we can enforce people to limit their CO2 emissions during a training? So by switching those workload managers or the time that they have on the system to a maximum of CO2 that they can consume per month or per year. But that turns to the site where you are running, because if you're running on renewable energy, in our case, at MIT, we have 95% renewable energy from water. But what if you go in other places where you don't have so much renewable energy? You know, how you can make your policy to constrain and move from running hours to CO2 use. So we are looking actually to include those things into our workload managers that can handle the user's requests. At the neural networks perspective, we believe that transfer learning should be considered more often. So you don't start from the scratch. You take a pre-trained network that was already created there, and you can train that. We encourage people to use more checkpoints. So we have seen that, you know, a training was running for a couple of days, and then for some reason something happened and the training stopped, and the researcher has restarted that training from the beginning. So from that perspective, is always to have checkpoints at every 1,000 of iterations. So you start from your previous checkpoints. So you save energy and therefore lower CO2 emissions for the next training. And those are very easy to be implemented in TensorFlow, in PyTorch. So that's not an easy, it has to be enforced by the center and you know, make aware people and put them to have those kind of deployments. For accelerated clusters, you need definitely high interconnect. You need either HDR or NDR InfiniBand connect, so have smaller latency between the compute nodes, between the accelerators, between the storage and the compute nodes. And we have seen as well that you spend a lot of time reading a lot of images, for example, a lot of them. Or if you are using, for example, the weather data, where you have so many things in kind of like, you know, temperature, then you have radar data and so on. It's good to put those things in the binary formats like HDF5, like XAR format, like TF records, so you can actually read much faster. You can send the data much faster to the compute nodes. And this is because having a data set, let's say a petabyte of a data set that has millions, let's say 5 million of images, for example, it's very hard to read all those images and serve them from a file system. Whatever file system do you have? And therefore, you need to actually understand and force people to have this practice and put those data sets in those kind of images. Last but not least, we need to rethink the model scaling for convolutional neural networks. We need to use efficient nets like kind of architecture. So we need to rethink the architecture of those nets. We need to have an approach of learning from multiple networks, not from a single network when you do the transfer learning. For example, here we did a study at MIT and IBM lab using the maximal correlation weighting algorithm that can extract a set of combining weights that tell you the best to use all of the inputs of the neural network. So therefore, you can, you know, train much faster. You can cover more classes, and even can have some, to a certain degree, some sort of explainable explainability. We need to have as well an approach, and there are research going on right now on the deep compression while you're training and pruning. So therefore, you consume less energy. And then as we go to have a different kind of representation into the processors and accelerators, we should use more, if possible, something like brain floating point 16 that has been right now added to frameworks, to libraries and so on, so we can train much faster with obviously lower energy consumption and CO2 implications. And at least we need to rethink how we can create neural networks that are hardware aware. Therefore, we can have dynamic neural networks that can adapt based on the hardware they are running, number of, the memory they have, the accelerators they have, the type of data, and so on and so forth. So that's very important to understand, and we make them in our planning how we can go forward to reduce the CO2 levels. So that is from my side. I'm open to any questions if there are.
Yes, thank you very much, Florian. I don't have any questions from the audience yet, but I do have a couple of questions that immediately came to my mind when I was listening to your talk. First of all, how many people in AI and deep learning are aware of the topics that you talked about?
Well, there are not so many aware. So this is, we are trying to do a couple of research, couple of presentations here and there, and publish some data. They are aware of the climate change. I believe everyone is aware of that. But when you do your work and when you compete against other people, those things like climate change, the way you need to create your networks to be efficient, the way you need to operate the training and so on, they kind of disappear, right? So we need to push more, and not only to push people to do something, we need to give them the tools and to make them successful with those tools. Not to, to say, well, if you want to run a training, you need to wait 2 years to finish it. That's not going to happen. Right. So that's very, very important. But at the same time, we see that there is a lack of, a community working on those tools.
And is this work that has to be done from within the community, or do you think that maybe activists could help out or would help out and identify this as one field where it's worth going and maybe talking to people and spreading the awareness?
I think it's, first of all, has to come from the community and then from the researchers. So the community has to come with some practices, with some recommendations how you can deal, and this goes to all these large AI systems. When you train and you consume so much energy, not when when you start a cloud instance, for example, with 2 GPUs or 4 GPUs. And every center has his own rules, has his own operational things, and therefore you need to have in that center a team that will be designated to add those tools, to collaborate with other centers and come with a common ground in practice.
Right. What dimensions are we talking about within the next 5 or 10 years? What is the best case, the worst case, the dream or nightmare scenario? If people listen to you and work on these things, or rather ignore that or think that's not one of the major problems they should tackle, what do you think?
Well, there are 2 streams here going on. One is we see accelerators consuming more power. So from 300 watts to 400 watts, 450 watts in the future, and even more, we'll see, with more cores and so on. Therefore, you'll consume more energy for that. In another direction, we see as well researchers that they are working for creating efficient neural nets. Therefore, very efficient algorithms that even you don't need to be trained to train on an accelerator. You can do it on a CPU that the power consumption will be around 175 watts. So there are these 2 big trends. We'll see what's going on there, but I believe efforts have to be done on both sides.
Right. Is this a topic that will stay with us, or is there an idea that maybe in 10 years, when we have much more energy efficient hardware, then the problem will solve itself?
People, they will train always. They will train on how much as resources they will be accessing, right? Because we are in a race. I think it was mentioned several times here. And this is not only between the nation, this is as well on the researchers' centers, right? Who's coming up? And if you need to train for 1 year a neural net, try to imagine if you put restrictions and you say, well, you need to train in 3 years. And by the way, you know,
Right.
other research centers are doing the same thing. So it's very hard to predict what will going on, but I believe efficiency will be top priority for the AI world in the future, and adding as well the other things, because we need these things to work for the future at scale.
Right. And do you think there will maybe be an effort to impose maybe some kind of efficiency regulation in the future? And would you welcome that, or would that bother you?
Well, I think this is happening right now, at
Right.
least at the European Union. We have seen European project being released where if you apply, you need to have a specific CO2 footprint in your center. And therefore, we foresee that this will just go more and more and more as a policy. And therefore, they will rethink the way they create their own solutions, the way they train and so on, to actually access those projects in the future. The question is what other nations will do.
Right. When awareness will start to grow in your profession, what do you think? Will there be something like an efficiency manifesto or any other kind of agreement that the people in the business will make for themselves?
There are some initiatives right now on this, mostly from the edge side, on efficiency, because you need to deploy this, and we have seen so many things going on right now that the inference market will grow a lot, and therefore the energy consumption there is very important, not mostly from the energy perspective, but from the heating perspective, and therefore we should see some upcoming standards on performance per watt, on the nets that they can run there. And we kind of seen this from, for example, from the mobile net kind of family. When you really turn your mobile phone and you want to do inference, you will see that is getting a lot of heat immediately, right? So I will expect some things in this side, but from the training perspective, where typically it's happening in the research, is very hard to predict because that is a competition.
Right. For a moment, let's imagine that this is 2025. There will still, of course, be a rise of AI. What will have happened by then in your field?
I believe for training perspective, we'll see specialized accelerators and specialized networks. And that is very important to understand that the thing, the world we're actually seeing right now, the training are relying on expensive accelerators, a lot of power consumption there, and this cannot go like this. So we may see kind of ASICs that will have better performance, but a lower power consumption, and therefore not so much CO2. And we may see networks that today we are using on GPUs that can be run on CPUs at half of a power consumption.
Right, thank you very much. We're a little bit early, but you have answered all my questions perfectly. So thank you very much, Florin. Good luck.
Thank you, sir. And I wish you good luck and all the best.
Good luck and success in your work. And I hope that our next speaker is already online. He will introduce us to industry use cases of AI computing power in edge. He has a lot of experience in management, business development, and deep technical training. Today, he's the Senior Alliance and Business Development Manager at Huawei Technologies. And I hope he already hears me. Evgeny Vlasov, are you there?
Yes, I'm here.
Welcome. Great to have you. The floor is yours. Time for your talk.
Thank you so much. Of course, welcome to Huawei Slots. My name is Evgeny. As has been said, I'm going to share some thoughts on AI computing in the age, as well as some industry use cases. Hope is going to be quite interesting. But before I start, I would like to say thank you so much for our colleagues from Rise of AI for organizing such interesting events. It's true. And organizing it in so non-standard for all countries, for all people, time. So let's start. For a long time, artificial intelligence stayed in data centers where there was sufficient computing power to perform processor-demanding tasks. Since that time, AI made its way into software and hardware algorithms changed, hardware modified, become more affordable, increased computing power, starts performing specialized tasks, and still start consuming quite low amount of energy. So AI moved to the age of the networks. You may ask what triggered that? Well, there are several points. There is a large amount of consumer devices appeared on the market during the last decade. Smartphones, smartwatches, home smart systems, and many others. Those devices increased the need in AI capabilities, better to say, and drove the AI computing to the edge. On top of that, connectivity developed a lot. We have been widely using wireless and fixed networks, so those devices can stay connected no matter where they are. There is similar situation in different industries like manufacturing, autonomous driving, smart system, healthcare, smart cities, healthcare, but the tendency is slightly different. While in the consumer business, customers learn new AI powered functionalities and benefits using those. In industries, there is a strong demand in the next level of processes, automation and optimization. And it becomes life, or better to say, business necessity. What is edge computing, especially in terms of AI? Edge AI refers to the algorithms or wall applications processed locally on the hardware located close to the data source. This means data analysis can be done without streaming big amount or storing big amount of data back to the cloud. It's important as the number of use cases which can't be handled via cloud is increasing, requiring high-speed processing with minimum latencies. It can be cars, factory robots, many live manufacturing processes, application using drones, or many others. Keep in mind, when we speak about edge, it doesn't necessarily mean building certain AI acceleration module into a device like drone, robot, or vehicle. It can be, let's say, an AI server installed in a factory network, or an edge station, AI edge station installed close to a data source. I've just mentioned edge devices do not need to stream or store data in the cloud. Do not get me wrong, AI edge computing devices are not going to replace cloud, but in fact, those are going to work now together. What's important for AI deployment in edge? Let's keep in mind at first, AI computing requires special chipsets and hardware. Classical CPUs are simply not dedicated for such technology. Yeah, they can accommodate and run AI algorithms, but will do it on a very slow speed. There are two main milestones for AI computing: training and inference. When we speak about AI computing in the edge, over 90% of cases are related to inference. So in this case, what's important? All scenario, ideally edge devices, as well as software, should support as much use case scenarios as possible. Yeah, edge devices are very powerful, but some of them are designed to have a good balance between computing power and energy consumption. Keep in mind that many devices still use batteries, drones, many electrical vehicles, robots, and so on. Such devices can limit use cases, or better to say, running many AI scenarios in the same time. High and stable computing power, which can accommodate high demanding AI applications, having no computing speed drops. Energy efficiency, we described that. There is strong limitation for many edge devices in terms of that. cloud and edge collaboration. As mentioned, edge devices can work together with cloud. There are different scenarios, starting from storing valuable data, indeed after AI analysis, and landing with models update, retraining, and its further deployment on the multiple devices if those work in the same network. Open and universal architecture. It's quite important to have universal platform which allows to develop an application, AI-powered application once, and deploy it on different devices, considering different topologies and scenarios with minimum efforts and minimum changes. Industry specific, there are very specific requirements for many use cases. So industry related SDKs, like the ones dedicated for robotics manufacturing, computer vision and so on, are pretty welcome. That simplifies the development process of AI applications. What else? Management systems, for example, using cloud edge collaboration scenario is one of the possible options. Many AI use cases really requires hundreds and thousands of AI-powered devices to work together in the same system. There are different examples. It can be systems related to traffic monitoring or IP video surveillance or maintenance, utilities or others. Such system includes many AI acceleration devices working together, which should be at first managed and maintained. So we are speaking about the following: edge device management and maintenance, valuable data processing, analytics after running through AI algorithms, so further processing afterwards, and AI models updates or retraining if it's necessary, and then it's further deployment on multiple devices. Most probably you heard that a couple of years ago, Huawei released the AI computing solution under the name Atlas. That means that Huawei provides computing power, hardware and software, while our partners develop different applications for different verticals. There is a nice slogan on top of the slide, so what it really means. All scenario means that the solution covers various AI deployment scenarios, including public or private cloud, edge computing, industry-related scenarios, and so on. While full stack means that solution includes many different parts, starting at first from the AI acceleration devices based on our own chipset called Atlas, and covering two main milestones, two main parts, which is inference and training. CAN, which stands for Computer Architecture for Artificial Networks. CAN includes chip operators library, highly automated operation development tools, and so on. Then framework, Huawei own framework called MindSpore, and it's actually universal. I will say what does it mean, and it's on the current moment open source, so you can find it on GitHub or Gitee. It's originally, when I said universal, it's originally designed for our own devices with own chipsets, but the same framework can work with AI acceleration hardware from third-party vendors like NVIDIA, for example. On top of that, our partners, as an alternative to our own framework, can use third-party frameworks well known on the market, like TensorFlow, Kafka, PyTorch, and so on, developing the applications over there and deploying using our tools with minimum effort. Indeed, that depends, the effort depends on the use case, but the efforts are really minimized. And indeed, this solution includes various tools for application development and making this process as more simple as it is possible. So those tools include development suites, industrial SDKs, pre-trained models, pre-integrated solution, cloud services, and so on and so on and so on. As mentioned, based on our own chipset, there is a range of AI accelerators available under the brand Atlas. We are not going to touch the data center part or the part related to training. As mentioned, over 90% of AI age use cases are related to inference. Colleagues, please play the video, the first video. So please keep in mind, this video is made a bit earlier than we are talking right now, so it needs a couple of devices like one of the servers and racks for data centers. So what do we have over here? Atlas 200 AI module with the size of a half credit card, which provides fantastic computing power and still consume up to maximum 8 watts of power. This module can be integrated in different devices like cameras, drones, robots, or any other devices. Atlas 500 AI Edge Station, the standalone device of a very compact size and high computing power. The device has Wi-Fi, LTE, and Ethernet connectivity on board and can work in harsh environments thanks to the passive cooling system. The next is quite classical in terms of form factor device. It's a PCI card, Atlas 300 inference card, which is based on 4 Ascend chips and provide much more computing power. Normally, those cards can be installed in third-party servers or the servers from Huawei, like Atlas 500 Pro Edge server or the ones dedicated for data centers. There are plenty of use cases for AI computing in the edge: video analytics, speech and text recognition, quality control, various manufacturing processes, medical image analysis, and so on. I would like to share a couple of use cases from our side. Colleagues, if you may play the second video, that would be fantastic. So, Neolix is the company developing self-driving delivery vehicles. This company is one of the Baidu strategic partner. Its vehicles are operating in hospitals, bonded areas, parks, Winter Olympic facilities, or other places. Vehicles have modular design. The bottom layer is autonomous driving platform, while the top one is dedicated for different services, which allows to customize vehicle for various applications like smart retail, delivery vehicles, logistics, or security. It can be a security patrol vehicle. The vehicle deals with different road conditions, providing high safety on the road, interact with different people, analyze behavior of people, and provide feedback depending on, for example, about purchases, people interaction with this vehicle, and so on. Atlas 500 station is used in Neolix vehicles, powering different AI operations like people and object detection, motion analysis, people behavior gestures. For example, the person or the people can wave the hand and the vehicle will stop where and when it's necessary. Interaction feedback analysis depending on the main function, and many others. The reason of choosing such a station is pretty straightforward. Using the device with full functionality on board, high AI computing power, and wireless connectivity, as well as possibility to use such device in harsh environments. Colleagues, play the last video, please. The next use case is manufacturing. Actually, it's a very, very large area, and the number of sub-use cases in this vertical is really enormous, and in many cases are still not 100% discovered, possibilities. But as mentioned, there is a strong demand in the next level of process automation and optimization. This related to many use cases: robots, material flow, warehouses, automation, digital twins, safety, and so on and so forth. The devices like edge servers process various AI-powered applications. For example, computer vision applications for real-time quality control during manufacturing process, visual control, products defects detection, missed or damaged components, and so on. To give you an example, detection rate using traditional ways machine vision applications is less than 90% and variated quite a lot. But it can be increased up to 99 or even a bit higher with some digits after comma using AI computer vision algorithms. In the same time, processing speed during this inspection increased several times. Another example is related to intralogistics. What I mean is the autonomous navigation system for, or systems, better to say, for automated guided vehicles, AGVs, like the ones developed by our partner Gestalt Robotics. Actually, there is several ways to build in AI acceleration modules in integrate, better to say, AI capabilities in mobile robots. The first one is building AI acceleration module into a robot, which has some disadvantages. The second is to put mobile robot navigation management system in the factory network somewhere on the server and connect the fleet of AGVs, mobile robots, back to a factory network using wireless connectivity. The second option provides more benefits along life cycle. First, it makes platform more universal, allowing to work with different AGV vendors in the same time on mixed fleets. An AGV management system can be developed by modular way, providing different functionalities with different costs. So if the customer do not need this or that functionality, it's not going to be charged. Or it can broaden AI functionalities range, especially related to high performance AI. Keep in mind that's an edge server, meaning that this device is still located in the edge, but it can provide much more computing power, so more functionalities, more speed, more progress, and so on. Faster deployments of mobile robots. That's definitely easier with the second option. System redundancy. Yes, for sure. Longer operating time, which is quite critical. Remember, those mobile robots are not permanently connected to any kind of power source, so they use batteries. According to our partners, the power saving is quite significant because robots are not going to consume the power for AI algorithms processing. And the difference is, depending on the robot, depending on the function, is from 8 to 25%, which is significant. So those robots can drive longer, providing the main function with a longer time between charges. And deploying software or firmwares on the fly, including AI models, updates, retraining, fine-tuning if it's necessary of different software parts and so on. That's it on my side, colleagues. We can speak ages. The topic of AI, deep learning, is so much interesting. So there are so much details. So each company, each person who are deeply in this area can share a lot of experience. So you're welcome to ask questions. If I may answer, I'll do that. If not, we will answer in the chat box of Swipecard.
Yes, Evgeny, first, let me tell you, thank you for your talk. And I'm not sure if it's typical German, but I fell especially in love with Neolix, your automated car system. Is this something that is on the road already, or is this a glimpse into the future right now?
If you are talking about Neolix, it is on the roads. The company started deploying the fleet of those robots quite intensively several years ago. Indeed, the company appeared on the market for quite a long time, so it's better to say new business for Neolix. And indeed, it can be really massively deployed everywhere because there are certain limitations, including related to the driving regulations and so on. So the number of places where the vehicles like that can be deployed and allowed to be deployed is limited. But it's already on road. It's massive deployment, according to my knowledge. I checked that before presenting it to you.
Right, thank you. We have a question from the audience. Who's your main client, or who are your main clients to buy these solutions? Do you cater to CEOs or rather to developers?
You can have my personal answer and the company answer. My personal answer is everybody who are really interested in AI. But if I would be a bit more serious, that actually depends on the country, better to say, because each country, even if we talk about Europe, have some kind of specifics. Yeah, for example, if we take France and Germany, it's more manufacturing. There is a lot of companies related to this process, better to say, or to this domain. In some other countries, like Spain, Italy, or others, the main focus is towards, let's say, retail or medical. You know the situation right now with pandemic. So there is a lot of work done by our partners towards using AI functionality, AI capabilities in medical sector. So that actually depends on the country, but there are main milestones, not milestones, in verticals where we play, as mentioned.
Right, thank you. And now we were, of course, or you were, of course, talking about edge solutions already. But I'm curious, what do you see, will your next steps be during the next couple of years? Do you have a roadmap for the products you showed us? Is there a next version already on your mind or in development?
There are plenty of products. Those are related to something I can share right now. There are some very interesting developments. But just to give you the feeling, at first, the strong push for edge to cloud collaboration. When it's necessary, it's not just stupidly push this area, but when and where it's applicable. That's the first point. Secondly, making the devices more affordable. On the software side, on deployment side, and so on. Then if we talk about training, during this session, I've spoken mainly about inference because it's the main part of edge computing for the moment in terms of AI. But there are a lot of steps done and going to be done in terms of training, even some extra parts related to video training and so on. So something which is quite exciting, better to say, for me personally.
Right, thank you very much. Thank you very much. I very much appreciate your keynote, Evgeny, and I would love to see one or two of the Neolix at maybe the next Rise of AI. Thank you very much.
You can see it not only from the customer, but there is an open lab in Unix, or there are plenty of other interesting use cases and devices and robotics and so on. So you can visit and see it in Germany.
Great, thank you. Bye-bye, take care.
Thank you so much. Stay safe and stay healthy.
And we will have a little break now and continue at 16:30 Central European Time with the scaling laws of artificial intelligence. See you then. Thank you.
the entire community is excited about artificial intelligence. For the first time in humankind history, we seem to have a tool that can solve any problem if it's given enough resources. But nothing in life is for free, and this relationship is actually quite brutal. The power law relationship means that if you want to improve performance of your model by, say, an order of magnitude, so from 90 to 99%, or from 99 to 99.9%, you need to almost exponentially increase the total amount of data. And that is non-trivial, because some problems just do require this extremely high level of accuracy. If you think about self-driving cars, building algorithms that achieve 90, 99, or even 99.9% performance is not sufficient. Models like that would cause a lot of damage. Therefore, they need to be substantially more robust. And as moreover, a lot of systems are not just built out of a single model. They are built out of multiple models combined together into larger applications. This leads to a huge data requirement, a data requirement that can be met if we're thinking only about raw data collection, but a data requirement that is difficult to meet when we think about labels. Okay, within the space of a self-driving car, it is possible to hire a huge amount of people to label. In fact, if you refer back to a talk by Clément Farabesso, NVIDIA's director of AI infrastructure, you'll find out that we hire about 1,500 people labeling data for the self-driving car. The same is not possible in other disciplines, such as in medicine, where extremely high domain expertise is required to label data sets. But even in simpler data sets where you need just to have a medium level of skill, finding labeling force is challenging. So even if you think about translation problems, there aren't that many people that would be proficient in carrying out those tasks. And this leads to a very high cost if we just try to follow this power law function. It becomes prohibitive to solve a very broad range of problems. Fortunately, over the last several years, we've started seeing substantial success of self and unsupervised learning. And there are quite a few different ways of approaching self-supervised learning, yet the idea behind it is quite simple. We would like to use the data set that we have collected in absence of human-generated labels, or at least we would like to decrease the volume of those human-generated labels that we need. And we've seen success of self-supervised learning across multiple disciplines. The example that I would like to use is the use of those algorithms in natural language processing. So rather than training natural language processing on supervised tasks with human-generated labels, where it's not really that practical, we would like to create an artificial problem for the neural network to solve that doesn't require that human intervention. One idea that is now very broadly used is to just download unsupervised data set, so download unlabeled textual corpus, and remove certain tokens, phrases, combinations of phrases from the text, asking neural networks to predict what those missing elements should be. Alternatively, we could provide neural network with two sentences and ask the neural network whether those sentences occur next to each other or not. But this is not only applicable for natural language processing. This is something that we start seeing successfully applied to a much broader set of disciplines. For example, in computer vision, people use approaches such as contrastive learning to try to achieve the same goal. So for example, they would take an image and extract two segments from that image, heavily modifying those, asking the neural network to recognize whether those two segments originate from the same image or not. Alternatively, those two segments could be provided from two different images, making the task for the neural network challenging and building complexity within the neural network. Alternatively, we see people use other more innovative approaches, such as generative adversarial networks or teacher-student training approaches, where the teacher is trained on a smaller supervised data set, but then trains the student on a much, much broader data set, which is labeled by the teacher rather than by the human being. And this allows us to overcome this challenge of scale. Suddenly, our ability to scale up the training data set is only limited by our engineering skill in building those unlabeled data sets and the resources that we have at our disposal. And this is made even easier to some extent by the abundance of unlabeled data sets. So whether it's in natural language processing or human or computer vision, we currently have huge volumes of unlabeled data set. Today, I can start a download of 8 million YouTube videos from YouTube 8 million. Similarly, today, I could start a download of huge data sets of billions of words, such as Common Crawl or open source large crawled Almanac 2. And this allowed us to make substantial progress, predominantly over the last year and a half in natural language processing, but also in other disciplines. And what we started seeing is a continuation of those scaling laws that I mentioned earlier. It turns out that they hold true for more than 9 orders of magnitude of data. And it doesn't seem that this trend is going to finish anytime soon. So as you can see, the line representing the relationship between loss and the volume of data, model size, is not starting to plateau quite yet, suggesting that we can continue to increase the model sizes, continue to increase the data set sizes by at least another order of magnitude. But this is not something, as I tried to suggest earlier, unique to natural language processing. We see the same trend in computer vision, where larger models not only behave better, but they cope in a more efficient way with very large data sets. But also in other disciplines, such as recommendation systems and sequence-to-sequence modeling, we start to see an advent of very large models and larger and larger, more frequently, semi-supervised and unsupervised data sets. But it's more than just accuracy. Those models are also easier to design. It turns out that as the models increase in size, their exact hyperparameter configuration becomes less and less important, leading to models that are easier to build in the first place, reducing the total effort required for hyperparameter search. Secondly, larger models, at least within the NLP space, the future will show whether that reapplies in other disciplines, seem to be substantially more sample efficient, meaning that a larger model counterintuitively can be trained at a lower computational cost than a smaller model, because the smaller model might have to be trained for a substantially longer period of time, whereas the large model could be trained for a very short period of time, terminated early, and deployed with superior performance, despite the fact that it is nowhere near convergence. Finally, those large models seem to generate superior features, more important features that are easier to transfer, learn to other problems, hence the appeal of this family of models, this family of approaches in natural language processing, computer vision, and many more. It's important to note that their ability to transfer, learn, at least early results in natural language processing space, seems to be superior. So you can see in this graph that an extremely large model of 175 billion parameters substantially exceeds the performance of 10 and 100 times smaller models, which are by no means small, even after being exposed to a single sample, so within the one-shot learning regime. But it's important to point out what do we mean by large models. And you might have seen graphs like that in the past, but I don't think they give the problem justice. That is why I think it's important to maybe show this graph in a slightly different way. So let's put it into a bit of a perspective. If you try to compare neural networks such as ResNet 50 to neural networks such as BERT large, yes, those models are bigger. Yes, they're considerably bigger than models in computer vision. But if we now try to compare those to some of the biggest models in natural language processing space that are used right now, such as TNLG or GPT-3, you'll suddenly find out that those models dwarf all of the other approaches. In particular, ResNet 50 is unrecognizable on this plot, unless you have extremely high resolution display, and BERT large is barely visible. So this is what we mean by large. And in fact, if we would try to train this model, it would require quite considerable computational resource. In fact, so much that on a single Volta GPU, it would take about 31 years. So it's important at this point to stress what makes those models possible. What did we as a community do to actually enable development of models of this size? First of all, we made substantial improvements in algorithms, especially algorithms that allow us for very large batch training. As you might have heard, large batch training, if done naively, degenerates models' performance. Over the last several years, we've made substantial improvements. We've introduced algorithms such as LARS, LARC, and now LAM, which allow us to train some of the largest models at unprecedented scale, with batches of tens of thousands, without degradation of performance. More importantly, we continue to innovate in this space, and further algorithms such as Novograd continue to accelerate the training process. We've made substantial improvements in the optimization algorithms themselves, creating not only more efficient implementations, but also we started to see distributed implementations that allow us to better parallelize not only execution of the forward and backward paths, but also the optimization process. Thirdly, we've made substantial progress in terms of building of software for distributed systems. We now have libraries such as NCCL, which are already tightly integrated into deep learning libraries such as TensorFlow or training distribution libraries such as Horovod, which substantially accelerate the exchange of gradients in a distributed training scenario. And we also made substantial improvements in terms of hardware, which allows us to hardware accelerate some of those operations. Finally, give me a second. Sorry about that. Finally, we've made improvement in terms of software quality. So NVIDIA, but also the broader community, was continuously over the last years improving the quality of the implementation of not only deep learning libraries, but models themselves. So what you're seeing right now is acceleration that NVIDIA managed to introduce into ResNet 50 training from August 2017 to December 2019. As you can see, for example, with MXNet, in August 2017, we were training at approximately 5,000 images per second. And today, on exactly the same hardware, it is possible to train the same model at approximately 11,000 images per second. So we've made substantial improvements in just pure code quality of not only the deep learning frameworks, models, but also broader set of utilities. More importantly, those utilities are now freely available. You can go to our ngc.nvidia.com and just download the state-of-the-art models and state-of-the-art copies of deep learning frameworks. And this allowed us to make substantial progress in terms of training time. I don't know how many of you trained models such as BERT before, but today on 8 ampere GPU system, it is possible to train a neural network like BERT large in 49 minutes. And this is largely to hardware improvements, but more importantly to substantial improvements in software quality and all of the other algorithmic improvements we've made. And what we are starting to see right now, and I've hinted to that earlier, is an advent of even larger models, and that brings another layer of complexity to the table. Because if you think about, say, transformer-based language model, A model bigger than 1.3 billion parameters will not fit into 32 gigabytes of memory. That is why there is an ongoing effort focusing on building model parallel implementations of those models, as well as utilities to ease the development of model parallel implementations across multiple disciplines. Our approach that is now widely used, not only by ourselves, but for example, by Microsoft implementing TNLG, to distribute transformer training in both model and data parallel fashion is called Transformer. And it allows us to scale linearly, not only within the model parallel, but also model/data parallel training regime. And finally, we've made substantial progress in our understanding how to build even larger training systems. Our past experience in natural language processing, but also in other fields such as perception for self-driving car or automated speech recognition, taught us what does it take to build systems for large-scale training. And now there is a very clear understanding how those should be designed. In particular, internally for research and development purposes, we're operating the 7th world's most powerful supercomputer in the world called Selene. And we're not alone in that respect. Many companies that are treating natural language processing, automated speech recognition, computer vision seriously are deploying systems based on that architecture. It became much easier than ever before to build systems like that and to scale the training process. So with that, I just want to point out the low-hanging fruit, if you wish. The direction that, at least in the near future, the research will take, most likely. As I've mentioned, very large models are very appealing. They have certain properties that smaller models simply don't. So until that changes, it is very likely that we'll see continuous growth of both natural language processing, computer vision, recommender, but also other models. With that, I would like to leave you with a call to action. Reach out if you're working with problems that require scale. That's at least my core expertise, but I have a lot of colleagues across the globe that are specialized in the same application area. Check out some of the training courses that NVIDIA offers, teaching you how to train at larger scales. And check out also all their talks from our own GTC conference, where we have a lot of engineers describing in a lot of details how to tackle some of the challenges mentioned. With that, thank you kindly, and I would like to open for questions.
Thank you, Adam. A very simple question at first.
Sure.
Why does the company that sells us these amazing graphics cards have a deep data and AI specialist as yourself at all? Why are you interested in these kind of topics?
So right now, overwhelming majority of research and development within the artificial intelligence space is carried out with GPU. So high performance computing and artificial intelligence is almost half of NVIDIA's business. So yes, computer graphics is a large proportion of our business, roughly half of it. But currently, almost half of world's most powerful supercomputers, so supercomputers that you use every day to get weather information, supercomputers that are used for creation of vaccines and medications, are using the GPU. Similarly, every time you say, okay, I will not say the name, otherwise we'll have a lot of beeping in the room, or the other personal assistant keyword, that is unavoidably hitting a GPU. Which is executing some form of a neural network or another in the backend. So artificial intelligence is a core part of NVIDIA business, and we largely enable it for the entire community.
Right, thank you. And then we have a question. You have been talking about large and largest neural networks, and you have only listed advantages. Are there disadvantages?
They are expensive, computationally. They take huge amount of resource to build and train, and they are quite challenging to deploy to production. We are trying to address all of those problems. So we have a fairly large engineering effort, for example, focused on optimizing execution of transformers. Mm-hmm. So we can now infer on, say, BERT large within a 2 millisecond latency window. So all of those, they create totally new problems that we didn't have before, all of which need addressing, and we're trying to tackle them one after another.
Right, thank you very much. One of the talks before you was talking about energy efficiency of AI networks and of course climate change, stuff like that. You said that the larger the neural networks get, the more efficient they are. Can you tell us something about the net benefit maybe for energy consumption?
So, and this is still something that that we as a kind of research community do not fully understand yet. But it seems like, at least within the disciplines where we have preliminary evidence, that for any given data set size, there exists an optimal neural network size that will lead to the smallest computational cost. And that neural network size is never the smallest of models. It's neither the biggest of models. So there is almost this U curve representing the relationship between the model size and its computational cost. And there are some good research attempts trying to quantify that and help you find where that sweet spot at the bottom sits. Also, you'll find that overwhelming majority of systems on the green top 500 supercomputer list, so most energy efficient, high performance computing systems are GPU accelerated, and we treat that very seriously.
And will this be one single sweet spot for energy consumption, computational power, cost, or will there be different advantages and disadvantages for different areas, and you will have then to weigh all the different factors? What do you think?
I don't think anyone knows. We have only very limited understanding of how those larger models work. That understanding will evolve over the next year, 2 years. At this point of time, it seems that this seems to be a relationship with the dataset size.
Right.
So for every given dataset, there seems to exist a fixed kind of finite curve, which for a family of models seems to lead to its, this optimal model performance.
Right. I think that people who are who like technology and are always looking at the potentials, like me and you, this idea of self-supervision is great. I think there are other people who fear that AI is not explainable, that AI has a lot of bias. They probably think this is a horror show. Can you tell us something about how self-supervision relates to these problems?
It doesn't. So neural networks, they are utterly simple. They do one thing and one thing only. They approximate functions. So you give them a data set, you give them some labels, and the only thing that they are capable of doing is approximate a function that maps that data set to a label. From that perspective, they are trivial. The challenge is that we provide them with poor quality data typically. And they are obedient, so they don't have any reason. They're just mapping whatever data we gave them into a function. So if the data we give them contains biases, they will obediently replicate those biases. They don't think. Those are just function approximators. They are as smart as a sinus function. So our understanding of how to better design data sets evolves, but there is still much more to learn.
Right. When neural networks started out, everybody has been trying to model the functions in our brain more and more accurate. I think this is quite a thing of the past now, or is there research in that direction also? Because we learn new neurophysiological facts every day too, right?
Sure. There is, but that's by no means the area of my expertise, so it's difficult to comment.
Right. All right. Sorry, I didn't want to press you on this. I was just curious. Maybe from your point of view, what are the next challenges you are working on? The problems that you right now cannot tackle, but are very curious to get your hands on and your head around.
So there are countless problems in this space. A lot of them revolve around the problems that you've mentioned. So problems around how to design better user interfaces. To help people interact with machine learning algorithms. So that problem of explainability, if you wish, I think that I'm not sure whether it's the right word. There are problems around the second topic that you've mentioned, how to design data sets more efficiently, unsupervised or supervised. So how to do a better job assigning, labeling resources. So within active learning space. There are huge opportunities right now in natural language processing and computer vision associated with this new wave of much better algorithms. Huge amount of low-hanging fruit in downstream disciplines. So whether you're working with named entity recognition, relationship extraction problems, you will benefit from those models from immediately. So a lot of things became possible as a consequence of this new revolution, so this new ImageNet moment that we had about a year and a half ago.
Right. So thank you, Adam. Thank you for your great presentation. Thanks for answering a lot of very, very nosy questions. I learned a lot, right? And I see that there's still a lot of work to do, and I'm happy that smart and passionate people like you are doing it. Thank you.
Thank you kindly, and have a great event.
Thank you. You too. Thank you very much. So that was Adam Grzewachewski from NVIDIA. And now it's time for a panel by KI Park. It is titled AI Can Improve Our Lives, We're Working on It. And I am happy to pass the torch to 3 people working on it. Olli Salzmann, Ruprecht Rittweger, and Alexander Rinke should be here. Gentlemen, are you online already? Oh, the sounds of silence. Just like, let us all take this minute to contemplate AI. We're a bit early, but they should be online any second now. I see a slide. Gentlemen from KI Park, can you hear me already? In the age of video conferencing, this can mean anything, right? They can't hear me, or they can hear me and they are talking, but I can't hear them. So let's maybe wait a couple of seconds or a minute. Yes. Hello there. I have a picture. Hi, I can also hear you. Welcome.
Finally, glad to be here.
Right. We finished a little bit early, but now it's your turn. Go ahead.
Oh, that's great. Thank you. The people with me today is Ruprecht Rittweger from Investor Holding GmbH, and we have Alex Rinke from Celonis with me today, where we want to introduce you to the AI Park, the initiative we are starting and launching, and we want to introduce to you today. First of all, I want to thank you, Veronica, Fabian, and the team for this remarkable event. I mean, looking back, when we are full speed ahead at the beginning of the year to launch the AI event, but also launch the AI Park in the first half of this year as the pandemic hit, and we kind of stopped everything within days. But I truly have to say here that I've never seen so much passion, courage, but also resilience from Veronica and Fabian and the team in order to make this event happening this year. And this is remarkable. So thank you very much. And hopefully we can also contribute with our speech and with our doing to this event. We've seen a lot of great speeches from our friends, from like-minded people, from AI experts. And I think there's truly clear that there is no question that in Germany, in Europe, there are enough talents. We do have scale-ups, and we have money in order to kind of really muscle through and start a new era. As Fabian mentioned in his opening speech yesterday about renaissance of AI, or the AI as a hype, which I clearly see as just do it. I mean, there is out there so many now possibilities that we need to grab that. I mean, companies and whole industries are poised for transformation in the near future. Many corporates believe that AI is the key for them to better become or stay the market leader in their area. Reflecting on the speech from Hans Uskereit yesterday about enterprise AI, I truly acknowledge and I can clearly see that in the last couple of years, the most benefits enterprises and corporates are seeing are in process efficiency when applying AI, which is, I think, normal in such a heavy process-oriented industry as in Germany we are seeing in terms of engineering, automotive, and the like. So it is clearly that there is the most impact right now and most benefit. But there are new signals coming, especially in the light of new growth, new business models, better decision making. I mean, this whole shortened disruptive life cycle that we are seeing, even accelerated by global innovation hubs, by front runners and wave makers, are even increasing the speed of change, which is good. And I think also clear is that 80% of companies will buy AI solutions. They will work with startups and scale-ups together in the near future in order to make the difference, creating an impact and using AI in their space so that they can really drive change and make sure that they are ahead of the curve and really fast and speedful in that event. So how can we support this? And what does corporates need in order to kind of flourish and drive through? What are startups requirements in order to kind of go up, stand there and execute? What does AI need to be successful in Germany? We need a thriving ecosystem for collaboration. We need founders, we need researchers, NGOs, political actors, companies, and leaders to really collaboratively work and exchange their ideas in one spot, in one community, in one ecosystem. And those people with the relevant skills into this ecosystem to build this holistic AI value chain, they should really help to drive the ideation of ideas all the way through execution and then to downsetting those events. For those who are a bit younger, but was pretty famous for the brand made in Germany. And I think we should consider those strengths we are having. We are a land of engineers, we are a land of founders, and we should make sure that we are using that trend. Germany has all the potential necessary. However, we need to make sure that we overcome our own company's competitive thinking. We rather should go into a collaborative mode. We should go from IP protection, proprietary systems into an intellectual partnership where we really drive jointly together the change and apply AI in an enterprise scale. We do not want to research. We want to really start applying AI. We want to create tangible values for Germany and for Europe. And especially, we want to help businesses to really grow and find their place in this really disruptive and changing world. Not to forget that this is also something which is for the society and for humans. So we need to stand up for our values. And as Professor Gabriel mentioned yesterday in his panel discussion about ethics and algorithms, value do not differ by nations. It's all the same. I think values differ by bad people and bad governments. So we as Europeans and we as our community, we need to stand up for our values. We need to make sure that whatever we do in this ecosystem and going forward is absolutely transparent. And there is a lot of integrity in space, especially the respect for human rights and data rights. And these guiding principles in all is what we want to create going forward. That is exactly the reason why we created the AI Park. We want to give purpose, we want to make it tangible, and we want to increase speed. Our first building blocks, each represented by my dear partners, which are also speaking today, will focus on the connection, on the application, and the education of AI in Germany, in our ecosystem. So Ruprecht, how do we build and connect our AI Park ecosystem?
Thanks, Ollie. Well, first of all, let me introduce myself. My name is Ruprecht Rittweger, and I represent two companies. One is Investa, a real estate developer, and the other one is NTT, which is one of the largest telecoms companies in the world, the second largest Japanese company, where I'm chairman of the data center division in EMEA. So what I do is I develop real estate, data centers, and other sorts of real estate. And you may ask yourself, why are several partners speaking for the initiative AI Park? As we all know, it takes several different bits and pieces to put AI applications in real use. So what does it take to develop AI? In my view, it takes, technology infrastructure, compute, storage, connectivity, data centers, cloud players, physical spaces, office space, co-working areas, recreational areas. It takes talent, well-educated talent, capital, especially in the early stages, applications. AI can only be understood and evaluated when applied in concrete use cases. The potential for application of AI, however, needs to be better understood, and it needs to be more transparent to startups in Germany. Data, no AI. We need rules, especially in the EU. AI should not violate our values, such as the right of informational self-determination, especially, being aware of the purpose that your personal data is being processed. So my angle on AI, large-scale infrastructure. So what do I bring to the table? A platform for people to connect in the real world and develop AI and access to multiple cloud providers, a large variety of internet exchanges and telecommunication network providers, privileged access to compute and storage. So where do we do this? So the facts. We do this in Berlin at the Marienpark, which is a very large industrial site in the south of Berlin, roughly 360,000 square meters, approximately the size of 50 football fields. And we dedicate a large portion of that for development of AIs as a flexible and secure workspaces for startups and infrastructure. Makerspaces for infrastructure-savvy AI development, such as tracks for autonomous driving, labs with enough room to experiment and to combine asset-savvy production with software, something we think is currently really missing in Germany, and several cloud data centers with space of almost 60,000 square meters in the first phase. The data center site at the Marienpark will be, Europe's largest data center, and we're developing this as NTT over the course of the next 2 to 3 years. If we were a fashion label, our offering would be called the Essentials. So we provide the essentials for our AI operated in Germany. Thanks. Back to you, Ollie.
Thank you, Ruprecht. Really impressive. And there are also a lot of questions already in the audience, which we are really trying to address in the next couple of minutes and slides, better by myself, and also some pens to go into the direction of Alex, but also obviously then later in the Q&A section. Apply. So we really want to make sure that we do no kind of experiences. We want to really focus on applicable AI under market economic conditions. Together with our partner Agorize, we've launched an open data innovation platform on our website, which is seamless, digital, and a complete self-service. What is in for corporates on that site, on that platform? You get instant access to more than 5 million registered users in the space of software development, AI, UX, UI, and so forth. You also have 12,000 startups, 700 AI startups in Germany, and we are still counting, at your fingertip, hoping and willing, together with you, solve your biggest challenges jointly with humans, with your businesses, and with the technology. What is in for startups? I mean, you get access to our expert network. you get a direct place on the field in terms of solving some of the real world challenges with your ideas, plus you create an eminence. This is a central point of ideas where you get all of the like-minded frontrunners and wave makers together, whether in the real world, but also in the virtual world, to really start working on applicable AI. If you go to the exhibit section, we are still offering for corporates and startups some free vouchers together with our user-centric starter lab. Frame your challenge and guide you through the first kind of steps in your journey to make AI enterprise ready. In this case, I also mentioned that at the beginning of the speech, it's also about transparency. So we also launched on our website an AI map where you see, based on state in Germany, where the startups been placed, who they are, how they look like, what they're doing, in which field they are working in, so that you also get a kind of a sense of where we are and what we are doing in Germany. But it's not just about AI solutions and products. It's also about our future AI leaders. Alex, can you help and explain the audience what we are doing in the AI Park to find the new AI leaders?
Yes, thank you, Oli. And also, you know, first of all, let me say that it is an honor to be here and launching the KI Park Deutschland. You know, I represent Celonis today, a company that I started around 10 years ago, and that is one of the leading AI companies in Germany, but also all around the world, one of the leading emerging AI companies. And, you know, one experience, and if I may just briefly say this, on the connect and apply part is, you know, was very personal. When I met Oliver here, he was a decision maker at Siemens, and he made it possible to apply our AI solution. We were very early stage in the company with one of the largest industrials, and it helped us to scale Celonis, and it helped us to create the foundation for a much bigger company. And I think this is why the connect and apply part is so important. When I was asked whether I would join this initiative, and I was honored to be a part of it, I thought about, you know, how can we contribute in the best possible way? And what is interesting, what I learned about AI, and what I also learned about Europe from building Celonis across Europe and the US, is that the key part of AI is the talent. It's the human capital that is able to build these AI solutions and to apply these AI solutions. And the thing that I learned about Europe is that the biggest advantage of Europe is our people and our amazing education systems and our 500 million Europeans that can leverage AI solutions, that can build in an ecosystem of new AI solutions and really prepare Europe as a competitive player in the future. And this is why we focus as Celonis with our contribution here on AI education, which covers a diverse set of skills. First of all, it's the technical skills, the programming, the data science, the engineering skills that are so important to the AI economy. The second piece are the digital skills, like online communication, like being able to collaborate in a remote team. And then the third, which is very, very important, and I learned this as an entrepreneur, the business competence. Like, how can we apply artificial intelligence to real business problems? How can we solve real problems with artificial intelligence? How can we think like entrepreneurs and start our own companies? And I think there's one more thing that also makes Europe special, is that a skill set that is needed in addition to this is digital ethics. Because as we create the next generation of AI leaders, we need to make sure that we apply AI in an ethical way, because we want to be proud of the society and the future that we create for our children. So this is why the KI Park will have an integrated education approach involving industry and academia. And we are an industry partner, And at the same time, our Academic Alliance program that we are bringing to the to the KI Park covers a network of over 400 leading universities, research institutions, and other partners with the goal of educating you and everyone who's interested on a responsible AI. And we decided to open our Academic Alliance and all of our training programs that we use to everyone in Germany through the KI Park. And we're very proud of this commitment and are sure that this will help facilitate the education of the next generation of responsible AI leaders. So we're very excited to be a part of it. I'm very excited to be a part of it and honored, and very much looking forward to building a strong European platform for artificial intelligence. With that, giving it back to you, Ollie.
Thank you, Alex. Really inspiring talk, and I always fascinated when thinking about the fact that I think 9 years ago, standing in a Currywurstbude across St. Martinstrasse, talking about the future, and now you are one of the most successful AI-driven scale-ups out of Germany and Europe, and I think there's much more to come. So I'm super excited and thankful that you are here and helping us. So this is actually a call for action for leaders, as we are here today to join this ecosystem, to start the exchange with us, to bring values, some kind of expertise and additional expertise to the table, to really build a value chain which is driving this initiative and helping our businesses and our industry to become and stay as this great industrial nation as we are today already. But this is also a call for action for businesses and for startups. Join us, speak to us, use the access to us in order to make sure that we are jointly working on the future. You're here at the moment, we are 3 partners, 3 leaders, which is Ruprecht Rittweger with Investor and NTT, obviously bringing a lot of space and compute power to the table. You have Celonis as a role model for startups in the AI field, from making it from the idea to one of the most dominant companies in that space in the world. And you have Deloitte as of today, which is bringing our professional and global network, including our industry insights, into this initiative. As we speak, we are in good and really fruitful discussions with other leaders around venture capital, around data, around sustainability, which also want to contribute. But please talk to us, contact us. We are really happy to talk to you and make this change happen, respectively make AI applicable in an industrial and enterprise scale. Thank you so much. At least we are on time, and looking at
you're very much on time. We don't have questions from the audience yet, and I at least was thinking that you would take half an hour. So you would have 9 more minutes if you want to discuss some further things.
Supposedly most of the questions have been answered so far, but
right.
I guess
I do have a question, because you were all very optimistic, right? And this is, I'm also the optimistic kind of guy, but I still want to know from everyone, what is the hardest part of what you were talking about? What is the hardest maybe to, you were telling people to think creatively and then be like a real doer, right? But even people who are very practical and who really want to walk the mile, there are still challenges. So what, from your perspective, are maybe the greatest challenges in what you told us?
Maybe if I start and then please others join. What I'm seeing is the most challenging piece is what I mentioned at the beginning of the speech, that a lot of people and companies are still having this kind of own competitive thinking, which is a proprietary and really closed type of working. And to open that up, to build ecosystem, to work collaboratively and jointly as a partner is really one of the biggest hurdles, but it's mainly a mindset shift. And you only, I think, can create that mindset shift to become leaders into a kind of a group of people together into this ecosystem to build trust. And once you build trust and you also build track record, that then obviously this mindset will change. So it's not so much a topic of cultural or technology, it's more mindset shift, what I'm seeing, which makes it most challenging from my perspective.
Right. If you allow me a follow-up question, the idea of being open and of collaboration, things like open innovation, has been around for some time, right? And some people have adopted it very successfully, and some people haven't, right? For different reasons that you and I might not share or understand. So what makes you think that this time around these people might change their attitude or their mindset? Or will it be a necessity because business simply won't be going great for anyone who has a rather closed mindset? What do you think?
So I can maybe chime in here as well. I mean, I think that it takes courage. It takes courage. It takes courage to be in a company and take the risk and invite a startup to come in and do a new AI project. It takes courage to rethink how you're doing things today and apply AI to it and change things. It takes courage to start a new company and introduce a new solution to the market, because that's typically not the safest path. And I think that there's already a lot of AI in Europe and in Germany, and there's already a lot of people that have the courage. But I think what we can do a better job at, and this is why I'm personally so excited about KI Park, is that we can inspire a larger and larger group of people to first of all have this courage and jump in. And everybody can jump in. It doesn't matter whether you work at a business, whether you have your startup idea, whether you are in academia. There's so many different ways to jump in. Whether you're in real estate, in data center, you can jump in. And I think that that's why we are here today. That's what one of the principles of KI Park is. But then it's more than just inspiring people. It's also then helping and giving the tools, providing the networks, providing the application, providing the platform to make it happen. And I think this is not a, this time around, last time around kind of thing. This is something we all have to grow together. And right. By the way, I think this conference is also part of it.
Right. I think that many execs would probably say, of course I am courageous already. Still, I don't want to go there. What would you answer them?
All right, so think again.
It's exactly. That's one thing, and maybe I can take this as well. Look, and I think also a couple of people said that. That's fine. We don't want to convince people to change or to say I'm already best in class. Then that's okay, because what we are doing is true, is honest, and we want to be a role model. We want to drive forward. We take the courage also in some areas maybe to fail, but we are, as a team, as a partnership, we will really try to make this happen. And as Alex mentioned, I think we also want to inspire. That's why we're bringing leaders to the table to help us really make this thing real.
And I think what you got to do is you got to be bold. You got to, try really, to also, from a real estate perspective, to invest speculatively. That's also going to be very, very important. Not to wait for tenants to come in, but you build it and then they will come. Mm-hmm. That's also a bit of a different attitude that you usually see in Germany. It's a little bit more hesitant, more on the safe side. So we're trying to be more entrepreneurial, mm-hmm. And I think we've all proven that this can work also in Germany, and that's what we're trying to put here, and then together with Deloitte and Celonis. I think it's a very strong team that can lay the foundations and can invite others to come in and join. And that's the attitude of the KI Park.
Right. I get the feeling, and correct me if I'm wrong, that the mindset or the mentality that you're looking for sometimes it's called the entrepreneurial mindset, but it's rather something for people who found their own startup than for people who are interested in a corporate career or might have been pursuing a corporate career for a couple of years already. Do you see that as well? And is that a problem?
Rupert.
No, I think it's open for everybody, and I think there are a lot of entrepreneurial people in the corporate world. And we do want to encourage also the corporate world to come join in the KI Park. We're talking to very large German corporates to come in and join, but to join in an entrepreneurial idea and to be part of it. And it's very important. We don't want only, startups. We want, entrepreneurs. We want startups. We want the German Mittelstand. We want large German corporates, and we want the German government as well. So we want everybody to participate in our platform.
And
right.
I completely agree. And by the way, you mentioned careers. I mean, we have worked with so many corporates over the last years, and there's been amazing corporate entrepreneurship, people that change the status quo, that implement new solutions. And honestly, it's the best way to make a career. The best way to make a career in a corporate, and in a way, Ollie is also an example of this. Sorry, point you out like that, Ollie, but is to embrace new things. And embrace AI, because this is where the future is going, and I think it would be hard to debate that. So, it's the right time to jump into the pool.
Right. How do you see the work that is cut out for you during the next couple of years to make all the things that you talked about a reality?
We're going to spend some money and be happy about it and take speculative risk. Mm-hmm. So NTT is betting big time on Germany. They're betting big time on Berlin. And we're going to spend more than 480 million euros on building a currently speculative data center. An investor is going to spend, double-digit millions in order to build speculatively co-working facilities and develop the marine park. So you got to be bold. And in the past, in Germany, people were bold as well, but we got to, do a little more these days in order to compete with the other regions of the world where people are very entrepreneurial as well, especially, if you think about, California, Silicon Valley, China, Korea, where, and we also want the government to take a bigger and smarter role in KI Park. And I think the government did understand that it's very important also to have some government spending together with startups and government spending in order to enhance, the infrastructure of our country. The IT infrastructure of our country is so utterly important. And that's why, we're trying to provide, AI hosted in Germany. That's what NTT and Investa are trying to do. And we're trying to bring the right pieces together.
Right. You're betting on Germany, and we are betting on you guys and your work. So thank you very much for the very interesting panel, and have a lot of success in your work. Thank you.
Thank you so much.
Thanks.
Bye-bye. Take care. Bye. Thank you. So we were, up to the last minute, we were not sure if our speaker would be here in person or if he would be online. Let me introduce him, and then we will see if he is already connected, because I haven't seen him in the room. The title of the next keynote really intrigues me. It promises a world where anyone can use a robot. I personally would already be happy in a world in which anybody owned at least one robot, but I'll try not to get ahead of myself. Our speaker received the German Zukunftspreis, or Future Award, in 2017. He was crowned Manager of the Year in 2018. He has an impressive collection of publications and awards, as well as national and international patents. Please welcome the CEO and co-founder of Franka Emika, Simon Haddadin. Hello, and I can see you, Simon. Great to have you with us.
Yeah, hello. Good to hear you. Good to hear. Unfortunately, I cannot be in Berlin. Would love to be there, but unfortunately, due to the COVID situation, I wasn't really allowed to come to Berlin. But we're trying our best to show you a couple of things we're doing here, also in live.
Yes. All right. We still have a little bit of sound from the panel that ended a minute ago. So if we would, I think that's corrected now. All right, Simon, off you go. We're glad to have you, even if it's only virtual. We'll see you in Berlin soon enough, I believe.
All right, thank you so much. So yeah, welcome from my side again one more time. My name is Simon Haddadin. I'm the co-founder and CEO of Franca Amica. This talk will be about the democratization of technology, a world that we imagine where everyone can use a robot. And if my colleague could start the presentation, can you already see it? Because unfortunately I can't. I cannot see anything. And this is a bit late. On a screen share. All right. We have some technical issues, unfortunately, apparently.
Well, we can see your slide now.
Ah, you can see the slide.
We can
All
see
right.
the slide, right.
Thank you so much. Maybe take this one away because it's a bit a minute later, and I always assume this is actually the live one. So if you see the images on the very first slide, we see a couple of groundbreaking tools that have been developed over the past centuries that levitated humanity on the next level, enabling us to create new things with our hands, basically. And for us, robotics is in that very same group, a tool for humanity that will ease in our life, that will relieve us of strenuous, tedious work. Our vision at Franca Amica is to create robotics technology for everyone. And for that, I would like you now to start the video that I shared for you. Yeah, it's running, okay. So basically, we launched our very first product roughly 2 years ago, the world's first AI-enabled robotic tool. It has a completely new type of performance. We'll show you later. We have designed, developed, manufactured the entire system here in Germany in our manufacturing facility, basically where robots build robots. The robot is, as we used to know, not a difficult machine anymore that only experts and professionals can use, but we also gave a completely new software stack so that everybody by now can use a robot even in complex scenarios. The robot system itself is for us not only a robot, but it's actually the extension of the digital world in the physical world, into the physical world. And I'll show you in a couple of seconds what we actually mean by that. When we started launching our product, we not only released
Simon, just one thing. We did not hear, we almost did not hear anything that you were telling us because the sound of the video and the music was quite loud. So if there was important info, right, then next time you should either mute the video or maybe you can just explain what you told us because it was very hard to understand. But the video was great.
Okay, so
right.
so I asked to mute the video. It's not a big problem. So what I said in a nutshell is basically that roughly 2 years ago we launched our very first product, the first AI-enabled robot system in the world, and we basically combined our skills of algorithmic, of a software operating system, combined with the highest mechatronic density, meaning that the robot system is actually learning capable, meaning you do not need to program this robot anymore, but you can just teach it by demonstration, for instance, or you can just deploy robot apps, which are tasks or features the robot has to do, and you do not need to program anymore. You can use our cloud system, Franca World, and you can download your apps and skills onto your robot system, whether it's here or whether it's in Japan, it doesn't really matter anymore. By now, we are engaging with a large community. Our community is primarily the industry, the disruptors, the educational space, and the academic space. Industry for us, the prime is the 3C manufacturing, meaning consumer electronics manufacturing. Disruption space is basically what we are doing here. So people who are trying to give robot systems new capabilities can use the robots for new applications in food sciences, in health, or in finding out how does AI work in the real world. Education is for us also very important, as the knowledge in robotics is actually very limited. Only few people only have access to robots and to knowledge in robotics. So we partnered with educational bodies, with non-profit foundations to bring knowledge of this kind into the general population. And the fourth, the academic space, is basically our, let's say, influencers, those people who know robotics best, who know control best, who know AI best, and by now the biggest labs like Stanford, MIT, Facebook, Google, etc. They're all using our robot systems to understand and learn about AI applications in the real world. And basically what we are doing, to put it in a nutshell, is what Apple did in the computer space is what we're trying to do in the robotics space. And now I would like to ask my colleagues to turn around the laptop because I only see everything 1.5 minutes later. So maybe turn it around for a second. Yes, and then we go on the next slide. So, so what I just mentioned is what we're doing here is basically a fusion of software and hardware technology into a single product, which is very simple for most people or all people at some point in time to use. And why do we do that? Because a major milestone in technology already happened. We already are living in a world where everyone can use a computer. On the left side, if you Google computer nerd, you see, unfortunately, still this image. It's the few people who were able to program a computer. And then roughly 30 years ago, Mac or Apple came around with the Apple I, with the idea of a personal computer. And by now, we see the world where everyone uses a high performance computer in their everyday life. Next. Now, why is it that robotics is not on the level where computers are? And why are manufacturing facilities still look like what you see here on the screen, specifically in the biggest manufacturing market in the world, that is the so-called 3C manufacturing market. 3C stands for computers, communication devices, and consumer electronics. So everything we use every day on a daily basis, none of that is manufactured in Europe anymore because our labor costs, unfortunately, do not match the requirements anymore, and these things are impossible to automate. So everything was outsourced into low-income countries, and this is, at least in my point of view, a major gap because the biggest market in the world, and Europe doesn't have any part in the value chain. And why is it not automated? It's not automated because robots are not usable, they're too expensive, and they're not capable to perform the tasks that a human can perform. And that is why, next slide, we only know this type of industrial automation. Everything behind a safety fence, no flexibility, and those robots can only drive from A to B, they can paint, they can weld, but they're not able to assemble or to test or to grasp something in their hand. And that's unfortunately one of the outcomes is 2 years ago, we have this press release from Süddeutsche, the German newspaper, telling us Europe's last PC factory just shut down. And I think everybody understands that this is a major problem, and we're trying to solve one of those problems. What we have done, we basically built an electronic system here in Germany. What you see there is our manufacturing facility, a former Nokia Siemens facility that we have reactivated. And when you click on the next one, and now please turn off the music. What you see here is our manufacturing facility, where basically man and machine are building robot systems in order to be even competitive against low-income countries. We need to automate as much as possible. Unfortunately, something doesn't work right now. And we're trying to give this technology basically to everyone so that we can deploy automation also here in Europe again, bringing mass jobs also back, but only we can do that by combining man and machine, so we are somehow competitive with low-income countries. Now, where is one of the challenges? This is an article from Handelsblatt, which shows kind of where does Europe stand against China, where does Europe stand against the United States, and what we see is a fast-running runners, and we have a slow industrial robot trying to follow these guys. Now, if you go to the next one, what we also know is that what has happened over the past 2 decades or longer in those technologies in AI. What we see here is 1996, Deep Blue beating the former, so back in the days, the world champion in chess, Garry Kasparov, and Deep Blue managed to beat him in a chess game. 20 years later, we have on the other side, the challenge of DeepMind, Google's DeepMind beating the world champion in Go, which we all assume are major advances. But who the hell is this guy? So for some reason, we managed to build a brain that can do better moves than a human, but we did not manage that the system will also conduct the movement. So we put a person, a faceless person. So all we have managed at some point, you can say, we only managed to exchange the guy who does the move for the computer. Next. But when we think about AI, all of us, I think we still imagine all the science fiction movies we have in mind. We're thinking about Data from Star Trek, we're thinking about C-3PO, and we're thinking about Agent Smith from The Matrix. All of them have something in common, is because we believe AI is actually something happening in the real world. Even if you take Agent Smith, he only became very powerful when he actually entered the real world and did not remain in the digital world. Manipulating the digital world is much easier than manipulating the physical world, and that's why you go to the next screen. Sorry. So what we see here is the so-called DARPA Robotics Challenge, where we try to solve, with a lot of colleagues from all over the world, basically building scenarios of catastrophic, so Fukushima-like incidences where we can deploy robots and we can sit somewhere on a safe space and we can control robots and send robots to solve our tasks. But this is what the brightest minds try to solve, and what you see is that they cannot even walk on stairs. Next, please. And why is it so? Click what? One more click, please. The sound. I'm really sorry about the sound. We should have tried. So what you see here is now, what is the big difference between mobility and manipulation? And I think, as we always try to use the human as a role model, it's the same in this case. What we see here is, for millions of years, organisms were able to move from A to B. But only primates are able to use the world and build tools to manipulate. Manus, so manipulation comes from manus, the hand. So only primates are capable of manipulating the world as they want to. And this is what we've been trying to do. So in general, AI is something like sense, plan, and act. So, but why is it by now a common assumption that it ends on the screen and it's some major big data computer running in the background? But we cannot do the transfer in the physical world, and this is what we are trying to do. And this is what you see here. The human on the left side with his capabilities, I can feel and I can use my muscles to manipulate the world. And this is basically what we gave robot systems. Next, please. And why do we do that? Because we want to give, another one, we want to give us, I'm really sorry about the sound all the time. So we want to give people a tool at their hand. What you see here is the bike manufacturer Puki. It's a children's bike manufacturer. And in disabled workshops, actually, these bikes are being manufactured. And we can give now even people who have limited skills a robot tool that can help them to assemble these bikes. And then go next. And what I would like to take you along now is a small demonstration of where we think AI does not end in the digital world, but actually bring it into the physical world. And basically, I will show you, or we will show you 3 steps. We will show you learning by demonstration. So we can teach a system to do something and the system will conduct it. On the second scale or second level, we will show you how a robot system without any knowledge about the concrete task can learn itself how to conduct the task. And the third one is, how can I give a collective learning? So the robot system in China, in the US, in Europe, it doesn't matter, can all share the knowledge and bring it onto a single system. And for that, we will go now into our lab. As I said, we wanted to be in Berlin, but we're trying to make this experience as hands-on as possible, because robotics is hands-on. And I wanted to bring a robot, actually, or at least one robot onto the Berlin stage, but we're using our lab for these days. So we are here in Munich, Schwabing, in our headquarters. And this is one of our major labs where we'll show you a couple of applications and skills that our robot systems have. So first of all, so maybe you swing a little bit. I hope everybody can see. You can see here a small fleet of robot systems. This very first one, what you see here, he's trying to follow a path, and what I can do, I can interrupt him, and even if I interrupt him, the robot system will still try to follow its path. And kannst du mal Collision Detection anmachen? And one major skill that every robot system needs, it needs to be safe to interact with humans. And for that, we basically gave the robot a reflex that the human has. That's the sense of touch. So every interaction I have with the robot can feel it. Kannst du Zero G machen? Now, another capability is basically this robot is not a mechanically stiff robot, but it's like my human arm. I can have it strong or I can have it loose. And this robot actually weighs almost 20 kilograms, but I can move it with my little finger because the robot keeps its own weight or compensates its own weight, and that makes it very easy to guide and to move around. And why do we need these skills? Sense of touch, collision detection. For a purpose of manufacturing, we need those things to conduct these tasks. I hope that everybody can more or less see what we're having here, but these are typical tasks from electronics manufacturing, and I will show the robot basically how to insert this plug or this plug and taking them from over here and I'm not sure if you can all see in the background. Maybe if you lift it up a little bit. I don't think anyone can see it properly, but this is our programming interface, so you don't, no, just stay there, it's all right. You don't need any codes anymore, any special computers, but what you see is that through the browser, we logged in onto the robots. So we don't need any special computers anymore. And what I do now, I basically show the robot how to insert this plug, and I will show the robot how to insert this plug. And now if you can, I will push play. I will put these over here. And what you will see now is that the robot will try to do exactly what I just showed him. And he's picking up this very, let's say, complicated plug. And what you will see now is like a blind person, he's trying to wiggle this plug in until he reaches the goal that I just showed him. So you still see those wiggling motions, and now he managed to insert it, so he's moving backwards, and now he's picking up an Ethernet. Oops, just pushed, turned off itself. Nice. Oh no, now he's, huh? That's how we know it's live, yeah? Now where is the Ethernet? There it is.
Simon, while you're trying to start it again, so will he always have this little janky motion that you showed him, or will he be able to optimize his movement after you showed him it once?
Okay, then let's continue to the next room. I'll show you right away.
Great.
Because basically what the robot used here is inherent capabilities that somebody else gave him already. And he will try, with the capabilities he has, he will try to solve this task. And now we will show you where does he learn how to solve these tasks. And that is what we basically call self-learning. So the robot, again, to conduct these tasks, we will go to the next station. Maybe we show here this real quick. So what we see here is a couple of assembling robots, basically testing and assembling iPhones and packing them for shipment. And we have to move a little bit further. I'm really sorry. And now turn a little bit. What we see here in the background, maybe you see a computer assembly. So that's where 3 robot systems are basically assembling a computer. And now I'll show you how the robot understands and learns how to conduct this insertion. Come on, play. So what we see here is now the robot wants to insert this USB-C connector into this socket. So it's a USB-C insertion problem. And these are the biggest problems in automation, how to insert objects. And what we see here now is that this robot is trying to insert, and he's trying different types of strategies. He's using force data, he's using motion data to understand how do I insert this plug. And this knowledge can then be transferred to either this robot or another robot to perfectly insert this specific USB-C plug. What do we do now? Huh? You have trained? Yes. So we have trained now, and now let it play. So basically, no more programming. Nobody is sitting around programming here, but the robot is basically learning itself. And now you saw it went in right away because he understood what is the best strategy to insert this plug. And he will do it just like a human when you think about you're in your hallway and it's dark and you're trying to insert the key into your lock. And that's exactly what this robot is trying to do here. Now, maybe another one. What we can show you now is monitoring, right? So now the robot understands this is my perfect way of how I will conduct this task. So every obstruction, every difference in this way will be felt. So even if I put a balloon here, the robot will feel this balloon, and I can restart everything just by touching him. And then he will conduct his task again. And I can put this balloon, it doesn't really matter. I can put it here, I can put it there. The robot has a sense of touch all over the body. So that means the process we want to automate will be much more robust, and the task will conduct it very fast. Now, we kind of still have to program a robot by using different apps we give the robot, but sometimes it's a bit difficult to know what apps do I actually need. And this is what we'll show you here now, is understanding. Can we zoom in on this screen as close as possible? So what you see here is basically the dashboard of the robot. And now our colleague will basically will show the robot what to do. Usually you have to pick the apps into your timeline. And now go a little bit backwards. Now please teach the robot. And this is the second level of learning by demonstration. So nobody needs to tell the robot anymore what apps he will use. He will understand by pure guiding what happens here, and he will accumulate and segment by understanding the process and put them into modular building blocks by himself. So what we just saw is that automatically, just push play, automatically this timeline filled up without anyone telling the robot what to do. He just understood what he has to do. And then we can just conduct the task, and the robot will grasp the object and will put it there where it was shown to. So what we saw before was we have to give the robot the apps that he needs to know, but now we don't need to do this anymore. The robot understands himself. And now a quick view on the, right, can see the picture, is what you see here is basically, that's where a lot of those data is accumulated. It's basically a robot farm where constantly all day long, robots are trying to see and grasp objects. We have here stiff objects. We have in the back, you see compliant objects like toys and stuff. And in the middle, we have insertions. So that's basically where we generate this data so that the robot systems understand how to conduct and how to solve different tasks. Now we could go back onto the demonstration to the next slide, please. We're almost on the, in the end. So why is this important? So robotics currently, specifically currently, we see that we are lacking major automation steps. And our entire industry broke down because if you look at the left side, this is 3C manufacturing. Under COVID situations, it's no way that this manufacturer can still run. So if we deploy robots, we can even keep social distancing in manufacturing facilities. Next one, the same accounts for healthcare. We are exposing our healthcare professionals all day, every day to a potentially deadly disease instead of using robots that can actually do the task, that can actually take the nasopharyngeal swab so that our healthcare workers don't need to do that anymore. Another system failure. Next one, please. And even at home, we are having so many people that are stuck at home, nobody takes care of them anymore because they're not allowed to do it anymore. So robot systems, again, can help us to engage with our elderly, to help them, to assist them in their taking their drugs, taking their food. And again, everything ends on the screen, but we do need physical agents to block this gap. Next one. And for that, I would like you now to start the other video I uploaded to you, because one major thing in robotics and in every technology is to bring this knowledge to everybody. What you see here is now a glimpse of that, what we're doing. So we're trying to teach and to bring this knowledge to even to the youngest people, so we can create an entire generation of robotic natives, similar as digital natives, but then not just ending on a computer screen, but actually interacting, bringing these things into the real world. And then go on to the next slide, please. Not only on a let's say, gaming level, but we actually created together with the Industrie- und Handelskammer, this is the professional training facility in Germany, to build courses for everybody so that we can bring this knowledge not only into homes, but actually into schools, into industrial training facilities. And from there, we can scale, obviously, from trainers to learners, and then they can bring this knowledge into their work, whatever it is they do. Next, please. Now, if you remember this image, this was from Handelsblatt. And of course, we see there is a lag in Europe against China, against USA, but we don't think this accounts in robotics and mechatronic systems, which are actually the gap or the bridge givers between the digital and the physical world. And that's why after this image, we made a counter image, which looks like this. Because we believe in mechatronics, in mechatronic systems, and cyber physical systems, Europe is not behind, but we're actually number one. And if we manage to do that, to train our people, to make systems affordable, to make them usable, to make them safe, then we can, from being a factory assistant, because this is what currently reality is, we can do the next step into service applications, whether that is health or food, for instance, and then at some point in time, of course, want to bring robotics into everyday life. And then I thank you very much for your attention, and if there's any questions, I'm very happy to answer everything.
Wow, first of all, Simon, let me say, wow, there's a lot of excitement in the chat. I'm very excited. Please don't feel bad because you had the music turned up at the beginning or because you were talking to your people to change the slides. This was a terrific presentation. I think I can speak for everyone that it was as much as we would have liked to see you in Berlin. It was great to have a look at your workshop, right? And basically watch your work in progress. So big compliments, kudos to you and your team. There are indeed a couple of questions, and since we are, I mean, we'll take a couple of minutes, but since we're almost done, please answer them briefly. One question is, could these robots solve a child's jigsaw puzzle?
Yes.
Great, great. Very, very nice and concise answer. I think next
you asked
answer
for a concise answer. So.
Next answer will probably be a little bit more elaborate. What's your understanding?
So maybe let me give you
sure,
real quick. So we are using the human as a role model, and I have children. We all have children, and if you see at when our kids grow, I mean, in the beginning they are starting to understand their own body. You see that when they're lying on their back and they're just moving their hands around. I mean, this is the years when kids are learning their own body. And then we are giving them toys like cubes and circles to insert them into these toys, like a jigsaw puzzle. And then understanding this insertion, they will transfer this knowledge. And if you give a 4, 5, 6-year-old a key, that's why I said that before, if you try to let them insert a key into the hole, it will take it some time, and they needed years of training to do that. And basically, what we showed here is that we can use the same skill, but train them within seconds. That's basically what we're doing here.
Right, fantastic. Next question is, what is your understanding of the timeline until every other household has robots like this at home, maybe even ones that are not only arms, but full body robots?
So every other household is a different question. If you ask my household, it's yesterday. But let's say if we actually want to deploy these in masses, I used the analogy of computers in the very beginning. And if you look at the computers, we have a little bit similar story. We had giant computers to do very rudimentary tasks, and it took 20, 30 years until everybody has a household PC at home. And we believe that roughly in the next 10, 15 years, the systems will be in that way affordable and capable and safe that they can actually be bought, let's say, at MediaMarkt in the Christmas shopping time.
Right, thank you. Another question.
Or bought on Amazon, obviously, by now. But
yes, of course. Are the robots available for individual developers or only for companies?
No, so basically we have different tracks. So obviously our prime business is B2B to major corporations, but that's why I mentioned real briefly our so-called disruptors track. That's where basically people who want to use the robot system as a platform. So the mechatronic system and our software to create new tasks, basically everybody can order these things.
Right.
And the price is roughly either 1,000 euros per month as a service, or there's packages from something like 12,000, 13,000 euros to 20,000 euros. So you need to have a little bit cash, but Yeah, that's more the issue, if you can afford that on a personal level.
Right. Okay. Thank you. Someone says, I believe Franka Emika Panda cobots are doing good on the education side. What are the upcoming advanced new features?
So some of them we saw here. So basically, the very first demonstration I showed you, these are the things that we already deployed. So over the next weeks and months, we are deploying the features I just showed you. So basically, learning capabilities, different interfaces. So currently, it's so-called Desk. This is our browser-based interface, but a software developer's interface, similar on like IDE for the smartphone. So you can create your own applications. We have a so-called FCI, which is a Franka control interface, which is a 1 kilohertz interface, meaning you can control the robot all the way onto the joint level. We can use MATLAB Simulink if somebody, most people from control and automotive engineering know that, or you can use, we have one partnership also with NVIDIA SDK, it's called Isaac. So you can use basically all common programming languages to use the robot. Besides the software features, what you see here, I think the video is still running, right? So if you have ever seen an industrial robot, usually they are built on a major platform, and you probably don't really see it, but there is a clamp here. We call this the power paw. Basically, you can attach this clamp to any surface there is, and the control box is hanging into the same cabinet, so you don't need any major infrastructure anymore to buy a robot. Another one we can see here, actually, it's a new gripper, which basically will have or has the same sense of touch capabilities as the robot already has. So these are a couple of new things that are coming up.
Very, very clever solutions. Now it's time for my questions, and they are quite brief. One is the Rock Band question, and the other is a startup question. The Rock Band question first. Where does the name Franka Emika come from?
Why is this a rock band? I was thinking
because we always ask rock bands, where does your name come from, right?
Aha, okay. I thought you were going to ask me what's my favorite rock band. Okay.
No.
So Franka Emika is basically, do we have a logo somewhere here? Jesus, on my shirt. So this is Franka. So I don't know if everybody realizes, but this is a girl with a ponytail chasing a ball.
Right.
And basically this girl, because the logo existed first and the logo needed a name, and we wanted a German name that is, let's say, understood everywhere in the world. And then it was, we are a bit older at the time. Franka Potente was still a name. Now nobody knows her anymore. And that's why the name already came from there. And there's, of course, personal connections, but this I would like to share maybe in a biography at some point in time.
Right, great, interesting. You see that it was also a rock band answer. And now for the startup question. So what are you looking for at the moment? Are you looking for funding, for customers, partnerships, employees? What are you looking for?
Probably you can make a check everywhere. I mean, we've been growing heavily over the past years. Of course, this year was a bit different than all other years, and I hope that everybody who listens is coming along quite well, health-wise and business-wise, because the year was a bit tricky. Basically, currently we are, let's say, coming back a little bit from a small hibernation mode, and we are scaling up heavily. So we are currently raising capital, we are recruiting heavily, we are expanding again our partnerships with especially our industrial customers. But the biggest thing that I would like to share here is, of course, that I would like everybody to get robot systems, whether it's at home, at your company, get our app development kit, get our control interface, use the robot to solve whatever problem you have, put it at home, it makes you orange juice, coffee, everything you want. And this is actually my biggest wish for today, that the entire community, especially German and European community, will use robot systems to solve all problems that are happening in the physical world. That will be my wish.
Great. So once again, thanks for the great presentation. What a great way to end the program today here at FutureSpace. Simon, have a lot of success, and thank you very much. I think a lot of care and preparation went into showing us all these different things. Thanks a lot, and greetings to your team.
Thank you very much. I will tell them.
Thank you very much. Take care. Bye-bye.
Bye-bye.
And now it's time for Fabian Westerheide's favorite part. This time also at the announced time slot. a wrap-up of 2 whole days of AI and 1 whole day of applied AI. He's still getting his microphone because he's really, really surprised about what we're doing now. I like this so much, Fabian, really. I mean, this is the moment he's been planning for half a year, but yes, take your time. It just makes you seem even more exotic, unimportant. And this is Fabian Westerheide getting rigged for his appearance on stage. You were also daydreaming a little there. So
I was honestly checking social media because people out there, they tweeted, they shared, they pushed it on LinkedIn. We just got a very huge article by Deutsche Welle.
Right.
With picture of you, by the way, too.
Wow. Good for them and good for me.
Yes, they reported on us, and I was just reading. I was like, oh, damn it.
Great. Great.
I have to run now.
Thanks for telling me first. So this was your dream for a long, long time. Sometimes when dreams get real, it's not as good as one thought it would be. How was it for you today?
Okay. First, I didn't sleep a lot in the last weeks, so I didn't dream a lot either. Second, I had a business problem. I could not scale. I'm an entrepreneur, and doing physical events is tricky because if you want to have more people, people don't scale. And so I always thought like, oh, I would like to make this open to the whole world, but no one was willing to stream last year or the years before. I offered them, they said, no, we don't want this. We want to be there in person. I don't care if you stream this. Watching this is boring. This year, it's the opposite. Corona forced us to do it, and now the market is there. Everyone is streaming. We had over 1,700 people registered and shared over the several streams over the 2 days, and it's the biggest Rise of AI we ever did, and still the smallest Rise of AI we ever did. I think this is a beautiful combination.
Right, and finally, I mean, people are used to streaming stuff all the time, and finally something good, right? I think that's why people were watching all the time, right, from beginning to end, which really makes me proud and should make you proud.
It is. There's 1 or 2 guys on LinkedIn who commented every session, who were like analyzing as like, man, that's cool. I love this.
Yes.
And I'm very thankful for the people out there. I thank you for still being online, because if you're not, you don't hear this. And I'm very relieved now. Like I was nervous because it was a very tricky thing. What we have there in a tech team, you can check this on social media, behind the stories, it's amazing. And therefore, thank you to the technical team over there who's cutting and editing this in real time. You did an amazing, great job.
Absolutely true. I second your sentiments. So, you know what we say in Germany, nach dem Spiel ist vor dem Spiel, after the game is before the game, right? So what are the next stops on the Rise of AI roadmap? Should we mark any dates in our calendar yet?
So first, no vacation.
All right. For any of us, or?
No, you can do vacation. I'll sometimes say vacation is to take a break from your life, but I enjoy my life.
Right.
And it's great. Sure, I will try to take my wife a little bit outside for a couple of days, but still, we already have planned the next one. Next year, we want to continue streaming to the world. We want to make all this accessible for everyone, but because of Corona, it will be physical, very limited, invite only. So if you want to be there in person, be nice to Veronica, and we will create a small guest list of people there. You will be there again, I know. Some of the speakers will be here again, and then we will do it, you know, the same.
Right.
Also, what I like this year, last year we had 4 stages, and I saw no talk at all because I was running all the time. This year we had 2 stages, and they were not in parallel. It was beautiful because first time I could see my own conference.
Great. And I have to correct your little husband's mistake. It doesn't matter if you want to be here in person next year or not. Please be nice to Veronica anyway, right? Right. So I know that you desperately wanted to get some of your team on stage. I think this will probably make it hard for the cameras because we will have to have a very even distribution here, right?
No, we are fine, and I have the same household with her.
All right.
We are a team. But please ask my team to come.
Right.
Leave your very comfortable chairs.
How about a little applause for the team?
Join on stage. So, I will move a little bit to you.
Sure. I'll make some room.
We have enough space. First, I start with her because you know that. Big hand for Veronika, please. Whatever you see, whatever you tasted, or what you heard, it's from her. She is the mastermind of making this a beautiful organization, of making it very professional, this stage design, the details. I mean, for weeks we were discussing every minor detail. She is the mastermind behind it to make this physical happening, and I thank her a lot for this. We move the camera now, for a second, to Florian. If you're out there, try to hire this guy. He is the mastermind behind figuring out how we can stream this with OBS, with all the technical setup behind there. We had weeks of where we pivoted and tried and experimented a lot with Widget Chat. And I have to say, big thank you for running this. You saw nothing in real time, I know, but he managed, 20, 30 virtual calls, partial. I think, thank you very much. And then, I wait until the camera shows you. This is Tina. And Tina, you have mainly seen in the chat today. She was in all the chats, everywhere present, taking care that you get connected, that you know what's happening, how to ask questions, curate them. She was babysitting all our partners in a positive way, like helping them to promote themselves the best way, how to attract, etc. So she's in the background too. Also, she was and is our first full-time hire. And I say this with being proud because she's employee number 1, and maybe in 10 years this is something great. Also, for us, this year was not easy for events. I think it's the hardest year ever to do physical events, and therefore I'm very thankful for this loyal team, for your dedication, for your hard work. Thank you again. And I say also thank you to all the people in the background, which is, for example, Jens, who's running with his crew, all the camera, all the lighting, everything behind it. We have Thomas there, who's taking pictures all the time. You will see them later and can enjoy them. I say thank you for the audio and the video team, for the hostess in the background. We had a huge team, not huge. This year, Corona, we had to reduce it a lot, but we made it happen, and we made it happen even we have high Corona barriers to make this a very safe thing. We all felt comfortable, and I think a lot of us started even enjoying it, being either at home and enjoying this, or sitting one of these very comfort chairs, having a popcorn here, and binge watching all the talks with eating popcorn all the time, and someone serving you drinks. It's like they didn't want to leave because their bellies were full. And last but not least, I want to thank our partners, because you in the stream, you didn't pay for it. And I think this is good, because this was my dream all the time, to make this free. But just in contrast, for last year, for example, the average ticket price was to cover for the cost 600 euros. This year was free. And we could only run this for the commitment of the team, but also for the commitment of our partners, who were there, who supported us through the crisis and stayed with us. And I want to thank them for being loyal, for supporting us, and being flexible and adaptive, to be brave enough to support a hybrid format where we didn't know how well it went, but it went really well. Thank you for everyone out there too. Whew, did I forget anyone? I did. You want me to mention them by name? Okay, first I want to mention KI Park. We had today a talk about them, and it's something you really should check out. Second, I want to mention IBM, because IBM is a loyal partner for years too, and they are needed in the infrastructure space, and we work for them for years too. Third, I want to mention Siemens, who is there for the first time, and it was a really good relationship in the background. I really liked their team, and I was positively convinced that a very old existing company can be very modern and flexible. I think this was something too. I want to mention Huawei out there, who gave me it was very interesting. I never had so many people involved in a group call to discuss what to do, and so they were very dedicated in the background and gave me a lot of advice how to do it, and I think this was really good, and there was commitment too. And then we have privacy solutions. You saw this talk by Jochen on the hybrid stage, and he was here the whole time and checking it out too. We had Cognigy with us. We had Accenture yesterday, who did the Humanity Challenge. I think this was really interesting too, because they, and I want this for next year too, they asked us if they can link to our platform and host their competition with us, because we share community this way, we can share the technology. I think this is also a way how we can cooperate next year more with partners. Use us, because we know how to run events. Use us to help us running your events at the same time, because then we share the community, the reach, the social activity, etc. Anyone else? Oh yes, Berlin partners, also thank them, because this year they supported us again. And I think it's good that local government is in support. I know how I hustled for AI for years. We didn't get attention from anyone. And then over the years it got better, and the city of Berlin is officially supporting us. I think this is something good, because it shows the commitment of the city to help us and to host us. And all our community partners, which are the... I'm sorry if I don't know them all by heart. So, I know we are doing it here. So I went to Berlin Digital, which is part of the city of Berlin, and I saw their share on social. We have the DFKI, the German Institute for Artificial Intelligence, which is always a good partner too, and it took us years too to convince them to official partner with them. We have KI Briefing out there. It's a very good curated newsletter in German. You should check it out. It's KI Briefing. We have Netzpiloten, who's always doing really good stuff in the background, good articles. We have T3N, which is the usual tech. You should check it. I mean, it's standard. And I want to mention the Bundesverband KI, which is also a good thing, because 2 years ago, there was no association for AI companies in Germany. And they have grown within 1.5 years from 0 to over 250 AI companies. I think this is itself. And I want to thank all our speakers, because at the end, they are the core. They shared the message. They came here, half of them in person, half of them did it virtual. They did an amazing job. They were very flexible, and they shared so much knowledge with us, which was beautiful. Thank you, thank you, thank you.
Whew. And of course, thank you, Fabian, because without you, we wouldn't be here. It would be a little less stressful, but a lot less fun. So thank you. This was Rise of AI Summit 2020. We hope you will stay safe and healthy, and we will see you all again next time. Thank you. Bye-bye.